Yes, I am serious. Today, we'll be doing 100 calculus 2 questions, and of course, we'll be doing them in one take. That's the clock on the board already. And of course, this right here is for you guys, for your calculus 2 final exam. And you guys can, of course, go to the description so that you can go download the file. And be sure you guys go also use the timestamps so that you can jump to any questions that you need to. This file should give you a really good review of everything that you should know for your Calc 2 final, including all the integration techniques, all the infinite series, power series, and also the polar parametric equations, and some differential equations, and a lot more, such as the work with hydrostatic force, the integration formulas, improper integrals, and all the stuff, right? So be sure you guys make good use of this, and we will be working them out together. So be sure you print it out and do these questions along the way. So best of luck to you guys for your calculus 2 final exam. And if you guys find this video to be helpful, be sure, please give this video a like and subscribe to my channel. Thank you guys so much. But before we start, I'll have to address this. I know this is pretty much the end of the Calc 2. I'm sorry. Yeah, because this is the Calc 2 final, right? But what shall we do in Calc 3 though? I'm sorry, I don't have a lot of videos for Calc 3. I only have a few videos for Calc 3, right? So let me recommend you guys, right? For Calc 3, please go check out my dear friend, Dr. Payam. Some of you guys know this already, right? And if you guys really want to learn the concept well, go ahead and check out 3 Blue, 1 Brown. And he has amazing animations, so you can really understand the mathematics. And Khan Academy and Patrick GMT, these two, they are the math OG YouTubers. So yeah. And lastly, but not least, this right here, Max. He is my former student, and now he's doing his math PhD at UC Berkeley, right? So hi Max, if you're watching this. Anyway, so I will have the links to their channels in the description, right? So make sure you guys go check them out, especially if you are studying more mathematics later on. All right, so again, please, if you find this video to be helpful, like and subscribe. Thank you. Now, here we go. The first 30 questions will be multiple choice because I want to go home before like 10 o'clock or so. Anyway, no, in a more serious note is that for my actual final, I will be giving out some multiple choice questions for my students, and you guys will see why. I'll talk about it later on. But I will also have the shorter questions later on. But the first 30 questions will be multiple choice. First question. This right here says, which of the following diverges because of the test for divergence? So we have this 4 infinite series. And now, in order to do this, we have to know what test for divergence is, right? Recall, all we have to do is, if we take the limit as n goes to infinity of the an, as long as this is not equal to 0, then we can conclude that the infinite series, as n goes from 1 to infinity of an, this right here, diverges. So that's the test for divergence. But if this is equal to 0, we cannot say a thing about the infinite series, right? So keep that in mind. Anyway, with this in mind, all you have to do is just look at the an part and take the limit as n goes to infinity. Let's look at the bottom one first. If you look at this and take the limit as n goes to infinity, do this inside out. N over n plus 1 will be approaching 1. And if you take ln of 1, that will be approaching 0. Unfortunately, that's not applicable with the test of divergence. So this is not good. I'm not saying this right here must diverge, or I'm not saying this right here must converge. I'm only saying we cannot use the test of divergence to make any conclusion with this infinite series. So just take the limit of the an part. Likewise, if you take the limit as n goes to infinity, this is just 1 over, on the bottom you pretty much have infinity. So that again goes to 0. This right here, well, this n squared over n to the 3rd power and all that, again will go to 0. So no good, no good. And yes, this is why I start with choice D, because I know the answer is A. And this is why. So look at the an part, which is cosine of n plus cosine of 1 over n. So if you take the limit as n goes to infinity of cosine of 1 over n, all we have to do is put the infinity to here. So we are looking at this as cosine of 1 over infinity. And this is just cosine of 0. And of course, cosine of 0 is equal to 1. Now, when it's not equal to 0, and congratulations, we can use the test for divergence to show that this infinite series diverges, right? So this is number 1. And one reason I like about the multiple choice is that because notice how I can actually ask you guys 4 questions in just 1 question, right? So that's why. Anyway, so this is the first one. And now we have 99 more to go. All right, so let's see if we can go home by like 10 o'clock. I have no idea how long this will take us. I have all the topics that from calculus 2. So I want to give you guys a good enough explanation for all. But I will also assume that you guys have seen this material before. So I will skip some steps whenever I think it's suitable, right? All right, so as you can see, the second one, we are talking about polar area. And for this one, I'll just write down the question for you guys and do the computation, right? So I put this down on the graph, on the paper for you guys. So we have a picture looks like this, and that. So it's meant to be all the same, okay? It's meant to be all the same. So we have it like that. Now this is even worse, and this should be bigger. Okay, now I have a. Alright, so I'll start timestamp right here. Alright, for question number 2, it's asking us to find the area of the shaded region, which is this part, and this right here, the equation is R equals cosine of 3 theta. Right, so that's the equation. Well, notice how because of symmetry, this region is the same as that, and it's also the same as that. And in fact, to make our life easier, we can consider the following. Why don't we just look at the area right here and double that, and that will be the same as that, right? So I will just go ahead and do the following. 2 times the area of this portion, right? 2 times the area of this portion. It's easier this way. Again, if you double this, this will be the same as that paddle, and it will be the same as that. So that's the strategy. Now, this is all you have to do. First of all, if you look at when theta is equal to 0, you will actually be starting right here, right? So we have to know the starting theta value and also the ending theta value. And again, if theta is equal to 0, then we're looking at cosine of 3 times 0, and that will give us 1 for the r. So I will just put this down like this. R is equal to this, which is equal to 1. So that means I'm looking at the zero's direction, right? 0 degree or 0 radians actually, and I will have to go 1 unit out. So this is theta 1, our starting theta value. So that's good. The harder part is that what's the theta value right here? Notice this right here, it's at the origin. So in order to make this happen, what we have to do is we have to make r equal to 0. Whenever you have the curve hits the origin, you have to make the r equals to 0. So again, I will just go ahead and put this down right here. R, which is equal to cosine of 3 theta, I will have to set this equal to 0 for the origin here. And you have to ask yourself, cosine of what angle will give you 0? Well, the first possibility is pi over 2. But be really careful though. The input here is 3 theta. So that means I want the 3 theta to end up being pi over 2, right? And then of course we can divide the 3 on both sides. We're looking at this as theta equals pi over 6. And in fact, this is precisely our theta 2. That's pi over 6, like this, pi over 6, right? And yeah, and if you want to double check with your answer, you can just use your graphing calculator, graph this curve, and just make sure your theta goes from 0 to pi over 6, and you will only end up with this piece right here. Now, the rest is just the setup of the integral, which is the easy part. First of all, we have this 2 right here, so I'll put down the 2. So this is going to be the area, right? 2 of this, times, for this area, we will just have to go from 0 to pi over 6, like that. And you have to remember the formula for the area of a polar region. The formula is you have the 1/2 inside, and then you multiply by r, which is cosine of 3 theta. So just go ahead and put that down cosine of the theta, and square on the outside. This 1/2 is needed, and then you do the r square, and you will be in the theta world like this. This integral will calculate this area, and I'm just asking you guys for the numerical answer. And use your calculator, which you actually get about 0.2618, and this right here will be the answer. Okay? So that's question number 2. 19 something more to go. I have to make sure I write smaller, otherwise I have to erase a question every single time. That's not going to be fun. All right, number 3. This one right here says we are going to find an integral of the surface area rotating the arc, and we have a parametric equation, right? We have a parametric equation. So here is question number 3. Consider the parametric equation x is equal to t plus e to the t, and y is equal to cosine t. So this is the x and y equations, and we also have the time interval. Time goes from 0 to 1. So you will get a curve like that. And we want the surface area, so just say SA. And I will just tell you guys, rotate about the y-axis, right? So that's pretty much the idea. Now, for the surface area, and I will just put down SA just to make it slightly more clear. Usually you can just put down S if you would like. But anyway, here we go. For the formula for the surface area, you actually have the integral, and then it's 2 pi and also the radius. But now, have a look here. Usually, if you have a curve like this is not necessarily the same as that, right? Take this curve, and if you rotate about the rotating about the y-axis, so let me give you guys a big different curve, so that it's easier for me to draw the picture. So if you have a curve look like this, and rotate about the y-axis, and what you can do is you can do a mirror image like this, and you can just do the oval at the end like this and like that. So you can do it's like a pretty good 3D picture like this. Anyway, look at this, and for the surface area, you actually use like part of the cone, so it's actually slanted. So it's like this right here, right? And the most important part is that you have to find out the horizontal distance, pretty much like the radius. And look at this right here. It's exactly, you need the x value like that, right? So it's 2 pi times x, right? And this right here, you have to see the whole proof for that. If you would like, you can just remember the formula, right? But it's like the circumference. So you can look at 2 pi times the radius, which is x in our case. But you have to make sure you have the dl here. And for the dl, you will have to open the square root. And because this right here is a parametric equation, so you only have one form for that. And let me just write down the formula for you guys. You will have to do dx dt, which is the derivative of the x equation with respect to time, and you square that, plus dy dt, and again, you square that. And we are in the t world for this. Because we're in the t world, you just have to make sure you go from t1 to t2, so you just go from t is equal to 0 to t is equal to 1, like this. So now, it's going to look like integral from 0 to 1, 2 pi. The x, just refer it back. You have t plus e to the t for the x equation in terms of t. And then you multiply by the square root. dx dt, you just differentiate that and put it here. So, differentiating this, we just get 1 plus, and the derivative e to the t is still e to the t, so you have e to the t right here, and you square that. Plus, open the parentheses, dy dt, differentiating cosine t, we get negative sine t. So, that's pretty much it. And I just want you guys to set this up. That's all. And of course, if the question asks you to get the numerical value out of this, then just use your graphing calculator, because most likely this kind of things is really hard to integrate by hand. So I will just ask you guys to this one, right? Yeah, that's the answer for this one. So yeah. All right. Finally, I can fit 2 questions in one board. So this is question number 4. Right here, question number 4 says, given a sequence, and it's written like this: a1 is equal to 5, and an is equal to 8 minus an minus 1. So 8 minus the previous term. And this is true for n greater than or equal to 2, like this, right? And the question says, which of the following is true? And again, before you guys watch the solution right here, you should seriously just try it first before you just like copy the question down and all that, right? So which of the following is true? Perhaps to save time, I will just project it like this. It says an diverges, and an converges to 3, an converges to 5, an is increasing, and the last choice is an is decreasing. So which one do you guys think? Well, let's write this down first. Let's write down the sequence. Let's write down our first couple terms. The first term is 5, right? Well, for the next term, you have to do 8 minus the previous term. 8 minus 5 is 3, like this. Yeah. And then, next term, you look at 8 and then you minus 3, which is 5. And the next one is going to be 3. And the next one is going to be 5. And then so on, so on, so on. So, which choice is correct? Well, the idea is that this right here, if you take the limit as n goes to infinity of an, this right here doesn't exist. So, the choice is A, an diverges, right? An diverges. This right here, it's not increasing. It's also not decreasing because it's go up and down, right? And of course, this right here does not converge to any specific number. So the answer is an diverges, right? And by the way, I'm not going to write down the answer choices for you guys, like the correct answer choices anymore, because this is a very nice pattern. So you guys can try to figure that out and be the hero in the comment section and just say, hey, all the answers in the multiple choices is what? And maybe there's a pattern, just write down your answer key for that. All right, so that's it. That's it for the first page. But this is 14 pages, so just yeah. All right, number 5. So this is super fun because I'm not just doing integrals like for 100 times, but man, we'll see. We'll have to really use our 100% of our brain powers. So here we have parametric equation. We have the x and also the y equation, and we want to know d2y dt2 is equal to what? This right, oops, no, not d2y. d2y dx2. So this notation means if you graph this, maybe like the curve looks like that, and we're trying to find the second derivative of the curve, and that will tell you about the concavity. Earlier, I accidentally put down d2y dt2. That will be the acceleration in the y direction, but we want to talk about this, right? d2y dx2. So this is how you do the second derivative in the polar situation. Here we go. Let's go ahead and just differentiate. I will put this down for you guys first. First one, dx dt, right? dx dt. Just differentiate this the usual way, but we have to use product rule. So go ahead, t times the derivative second plus the second times the derivative of the first, right? And we have the dy dt. The derivative of that is just 3t squared, very nice. All right, with this, well, I can tell you the first derivative, dy dx. The first derivative, dy dx. This right here is nicely equal to dy dt over dx dt. And as simple as that. That's it. So you just have to go ahead and divide, but the dy dt is right here, so just go ahead and do 3e to the t's power over dx dt is just all that. And look at, we have the e to the t, so we can factor that out. And then we have the t plus 1. And of course, this and that cancel. So in the end, dy dx is just 3 over t plus 1, like this. It's not so bad at all, right? Now, for the d2y dx2, you have to remember to do the following. d2y dx2. Unfortunately for this one, you do not just differentiate this again and differentiate that again and then divide. It's not like that. For this right here, you will have to go ahead and differentiate with respect to time of the first derivative in terms of the time right here, the dy dx. You have to d dt of the dy dx, right? And then divided by dx dt again. So you have to divide it by dx dt, like this. So how does this look like? Well, why don't we, no, let's just put this down here. We will have to go ahead and differentiate 3 over t plus 1, right? And then divided by dx dt. Luckily, it's just this, so that's still good. And again, I'll just factor out the e to the t, so we have e to the t times t plus 1, like this. So this is from here already, but this, we have to do the differentiation again. So, to do the differentiation of this, perhaps the easier way to do it is just, let me write it down here for you. d dt, you write this down as 3, but you write it down as t plus 1 to the negative 1 power, like this, right? And then divided by that, which is e to the t plus 1. Now for this, of course, you can bring the power to the front, minus 1, and now we are looking at this as negative 3 times t plus 1 to the negative 2 power, like this. But don't forget the chain rule. Look at the inside, the derivative of t plus 1 is luckily equal to 1. So if you did forget about the chain rule, lucky you. So yeah, just multiply by 1. Multiply by 1 doesn't matter. Over e to the t plus 1. And in the end, of course, we can bring this down. And this is negative 2 power, so bring it down, you just have to make sure it's 1 plus 2. So you have altogether the third power. So all in all, negative 3 over e to the t plus 1 to the third power, like this. Right? So that's actually the answer for that. Okay, so that's it for number 5. Now, number 6. Okay, good. Another differentiation question. So I will just put it down right here. It should fit. So given our function f of x is equal to the, here we go, the inverse hyperbolic tangent, okay? And then the input is sine x. Man, we have to find the derivative of this. And this is just the usual derivative because we are in the x world and that is not the parametric situation. Well, this function is instead of the inverse hyperbolic tangent. What we should know is, what's the derivative of inverse hyperbolic tangent? This right here is 1 over 1 minus x squared. It's very similar to the inverse original tangent, right? If this is the original without the h, it's 1 plus x squared on the bottom. But this is the hyperbolic version, so it's 1 minus. So anyway, with this in mind, I can show you f prime of x. Differentiating this, that means you should put it inside here. So we look at this as 1 over 1 minus sine square x, like this. Right? The second part, I put it down right here. But this time, chain rule matters. Hashtag. Look at the inside. This is sine x. We have to multiply by the derivative sine x, which is cosine x. Right? Now, have a look here. Perhaps I'll use a green pen for the first time. I don't need to though, actually. Let me just, not yet. That's the secret weapon. This right here is what? Cosine square. So on the top here, we have cosine x over this right here is cosine square x. Cancel, you get 1 over cosine x So in the end, we get secant x, and we are done. And the truth is, if you want to integrate secant x, you can use this as your answer as well. It's a possible answer for that. So anyway, this right here is number 6, and this was number 5. So we have the derivative questions back to back. Right, so, yeah. I'm going to conserve energy, so I'm not going to talk too much while I erase the board, right? But you guys can maybe use my back to do some reviews on integrals. So hopefully that helps. Okay, now here is the question number 7. And I will just explain what this is. Given, so we know the following. We know that the improper integral from 2 to infinity, 1 over x squared root of x squared minus 1 dx. We know this right here converges. So it was a given information, right? But based on this, which of the following can we also conclude it converges by using the comparison test? So I have a couple choices for you guys. I will just write this down for you, okay? A, B, C. And let me tell D and E are not the answer, so I will. Well, actually, we just have 4 choices. So choice A is the integral 2 to infinity 1 over x squared square root of x squared minus 1 dx. The second one is 2 to infinity, and we have x over square root of x squared minus 1 dx. Integral from 2 to infinity 1 over square root of x squared minus 1. And then lastly, 2 to infinity 1 over square root of x squared plus 1 dx, like all this. So based on this right here, which of the following also converges by the direct comparison test, right, DCT? Because when we're talking about improper integrals, usually the thing I teach my students is just a direct comparison test, meaning you compare inequalities. So now this is what we are going to be looking for. This right here converges. This right here, they are the ones who are trying to make the decisions on, right? When you have a convergent, you have to remember this. This is the comparison theorem, right? When you have an improper integral that you don't know, so this is the one that we don't know. If we can show that, let me just actually make it more legit. Let's say from like, I don't know, 1 to infinity. This is the one that we don't know. But if we can show that this right here is less than or equal to a known, I'll just write this down better, and a no. This right here, if you can show that this is less than or equal to a known convergent integral, then you can conclude that this right here also converges. And the reason why is because you can imagine convergence is finite. So you can imagine this right here is like a young person. If you can show somebody is less than or equal to a young person in terms of age, what can you say about this? This person also has to be young, right? So that's the idea. But if you have a greater than or equal to a young person, a guy is greater than or equal to a young person, can you automatically say that he's old? No, we cannot, right? So this is the first version, and of course you have to make sure everything is positive here. So this is the one that we have to know. But if you happen to be given a known divergent integral, and you're trying to make decision on this, then in that case, you wish to show a greater than or equal to situation, because if you are showing something is greater than or equal to a non-divergent, remember this right here is, you can imagine this is past infinity. You have to be even bigger infinity to be greater than this, right? So I can also say this right here, they have the same conclusion, also diverges. So these are the inequalities that you have to remember, right? So the comparison test. And now with that being said, this is a non-convergent, so I'm just trying to see which of this will give me less than or equal to, 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 the original that we are looking at, the one we are given, which is this. So I'm just trying to compare. So I'll just do it like that, right? And the truth is, the first one works, right? The first one works. And one way to see is because, as you can see, this part and that part are the same. This is x, but this is x squared. So the bottom is actually bigger. If the bottom is bigger, the whole thing is going to be smaller than that. So you can just eyeball it if you would like. But if you want to show some algebra work, then you will just see 1 over x squared, square root of x squared minus 1. Just compare the inside. This right here, you hope to show this is less than or equal to that, which is 1 over x square root of x squared minus 1. And again, pay attention to this goes from 2 to infinity. So you just want this to be for 2 or bigger. If x is equal to 1, this is ruined. So that's why we start with 2. But anyway, cross multiply if you wish. This right here is going to give us x square root of x squared minus 1 less than or equal to. Over here we have x squared. You see, this works. Cancel, cancel. So I have x is less than or equal to x squared. Is this true? You can cancel the x again because x is greater than or equal to 2. So this is 1 less than or equal to x. This is true, right? So this is true. And unfortunately, for the other ones, this is actually bigger than that. This is actually bigger than that. This is also actually bigger than that. You can go ahead and check it out. But if they are bigger than this, we cannot say anything about if they are automatically divergent. We have to do more work on that. But anyway, for the first one, that's the only thing that we can conclude by the comparison test, right? All right, number 7, and it took me 30-something minutes. We'll see. The first 10 questions is always like, I feel energized, but I don't know. Number 8, we'll be solving a differential equation, all right? So here we go, put it down right here. So we're going to solve a differential equation, and the differential equation is dy dx equals x y squared. And we are also given an initial condition, y of 0 is equal to 4. So here we go. Solve this by separated variables. In Calc 2 for our class, we don't go over the linear differential equation. That will be for the differential equation course. So we'll just do this by separating the variable. So with that being said, you don't see any other techniques for the differential equation, right? Anyway, multiply dx on both sides, divide y squared on both sides. So bring that to the other side. We are looking at 1 over y squared dy, 1 over y squared dy, right? That's equal to x, and the dx on the right-hand side. Then we can integrate both sides. So go ahead, integrate this guy, integrate that guy. Now, to integrate this, you can look at this as y to the negative 2. You add 1 to it, divided by the new power. Negative 2 plus 1 is negative 1, divided by negative 1, so you have negative. And y to the negative 1 is the same as 1 over y. And do not worry about the constant on the left-hand side. Just go ahead, integrate this, which you will get 1/2 x squared, and put down the first constant on the right-hand side, like this, right? And then if you would like, in this situation, we can actually just go ahead and isolate the C1 right away. It's easier that way, actually, because the reason is we'll just be able to solve for C1 right away. So you can do that right now, or you can solve for y first and then plug in the initial condition. Up to you. I am going to do it right now because why not? So put a 0 in here and put a 4 right here. So we're looking at this as 1 over negative 1 over 4 equals 1 over 2 times 0 squared plus C1. And it works wonders because this is automatically 0. That's why I wanted to choose C to do it right here, right now. In another word, C1 equals negative 1 over 4. And with that said, we know the equation now is 1 over y, and that's equal to 1 over 2x squared minus 1 over 4, like this. And we just have to isolate the y, so that will be pretty much it. So I will go ahead and multiply everybody by negative 1. So I will get positive 1 over y, and that's equal to negative 1 over 2x squared, and then this is going to be positive 1 over 4. This is 1 over y, so I'll just do the reciprocal on both sides. So this is going to give us y, but because this has 2 terms, I will just do 1 over both of them. So 1 over, let me put this down first though, 1 over 4, and then minus 1 over 2x squared, like this. And we can just multiply the top and bottom by the common denominator. This and that, where the common denominator is equal to 4. So multiply the top and bottom by 4. We see this is 4 over, this is 1, this is 2, and we have the x squared, and we are done. Third page. Well, 2 pages done. This is page 3 on the file. Okay, so that's pretty much it for that. And now for number 9, we will have an integral. But I tend to write pretty big for this video. I don't know why, but like I will just have to erase. So just excuse me. While I erase, go ahead and try the next one, right? So that's the way to go. Pause the video and try it, and then you continue watching. All right, number 9. We will be integrating the integral. We have 3x to the, not the 5 power, don't worry. 3x squared minus 5x minus 4 over x squared minus 2x minus 3 dx. It looks like we should just go ahead and use the partial fraction and do the carve out right away. However, the degree on the top is 2. Likewise, the degree on the bottom is also 2. Proceed by long division first. So this is what we do. Do it on the side. Put the top inside, so it's 3x squared minus 5x minus 4. And then put the bottom on the outside, so we have x squared minus 2x minus 3. And we just have to ask ourselves, what times x squared will give me 3x squared? It's just a constant that we need, so we need a 3. Put a 3 right here if you would like. And do 3 times this, it's going to give us 3x squared, and 3 times that is minus 6x, and 3 times that is minus 9. And then don't forget we have to subtract all this. This will be 0. Negative 5 plus 6 is positive x, right? The x term. And then negative 4 plus 9 is going to be plus 5, like that. So the first thing that we do after the long division is that we break it apart. The first one is you have the 3. It's the whole number term like this. And then the fractional part is we add x plus 5 over the original denominator. However, you will have to factor this and then do partial fraction. So if you factor this, we will end up with x plus 1 times x minus 3, like this, right? Dx. Okay, integral 3 plus, do partial fraction with the carve out method. The first thing is going to be something over x plus 1, and then the second one is going to be something else over x minus 3 dx. And we use your both hands or both fingers on the test. Here we go. To figure this out, we just need a number because the bottom is just x to the first power. So for this number, you go ahead, go back to the original and cover the original. And you have to ask yourself, how can you make x plus 1 equal to 0? X has to be negative 1. So you put negative 1 here and here. So negative 1 plus 5 is 4. Negative 1 minus 3 is negative 4. All in all, we get negative 1. Right? Next, to figure this out, we will have to go back to the original and cover this up, the same exact denominator. And you have to ask yourself, how can you make x minus 3 equal to 0? X has to be 3. So you cover this out and you put 3 here and here. On the top will give you 3 plus 5, which is 8. On the bottom, 3 plus 1 is 4. 8 divided by 4, you get 2. So this is 2, like that. And in the end, we of course just integrate. Integrating 3 in the x world is just going to be 3x. And this is a minus 1. And because the bottom is linear, so you get natural log with the absolute value of x plus 1. Plus 2, we'll just put it down like this, and then again ln of x minus 3, like that. And you should always check what the derivative of x plus 1, what the derivative of x minus 3 is. They are both equal to 1. So when you divide it by 1, it doesn't matter. But sometimes if you have, let's say, 5x plus 1, be sure you divide it by the constant, right? Divide it by the 5. Anyway, this is it. Don't forget the plus c right here, right? Yeah. All right, so that's number 9. And I will fit in number 10 right here. This is a limit question. We have a limit as x approaching infinity. And we have natural log of 2x over natural log of x cubed plus 1. All right, real quick, if you put infinity to here and here, you get infinity over infinity. That's good because we can use L'Hopital's rule. So go ahead and do d dx and d dx. So now let's see, this will give us the limit as x approaching infinity. Notice how we have two separate natural logs. So this right here, when you differentiate that, we get 1 over the inside, which is 1 over 2x. And then use the chain rule, multiply by the derivative inside, which is multiplied by 2. And the truth is, you could have break it down as ln 2 plus ln x. Up to you. I will leave it like this though. We get the same answer anyway. Differentiate the bottom, we get 1 over, this will be on the bottom. And use the chain rule again. The derivative of this is 3x squared. Like that. So that's very nice. This and that cancel, that's good. And we see that this is equal to, on the top is just 1 over x. And on the bottom we have the 3x, all that stuff. This is the 1 over x over 3x squared over x cubed plus 1. And again, take the limit as x goes to infinity. Of course, this is not what you want to look at because you still get like 0 over 0, but now we can just do some algebra. We can multiply the top and bottom by the common denominator, which is just both x and also this. So x cubed plus 1, x cubed plus 1. On the top, this and that cancel, so we just end up with x cubed plus 1. And this is again the limit as x approaching infinity. So go ahead and write this down, x cubed plus 1 over, when we do this times that, they cancel, by x times x squared, we get x cubed, but this is 3x cubed now, right? Now, when x approaching infinity, x cubed plus 1 over 3x cubed, what we can do is, well, you can just care about x cubed and then 3x cubed. You don't need to worry about the plus 1, right? And of course, if you just do a limit as x approaching infinity, this right here will give you a nice number, namely 1/3. And that's it. It works wonders. So the answer for this is just 1/3, like that. Okay? So that's number 10. Okay, number 11. We'll have a infinite series question again. We are going to evaluate. We have 16 minus 4 and then plus 1. Minus 1 over 4 and plus 1 over 16 and so on, so on, so on, like this, right? So let's see how we can do this right here. It's what kind of series is this? Well, if you look at from here to here, it's actually just multiplied by 1 over 4 negative. And we actually do the same, multiply by negative 1 over 4 and so on, so on, so on. So this right here, it's a geometric series that actually converges, right? So all we can say is this right here is equal to the first term, which is 16, over 1 minus the common ratio, which is negative 1 over 4, like this, right? And of course, this right here is just 16 over, add this up because negative times negative, we get 5 over 4, and you flip that, so this is going to give us 64 over 5. Done. So, geometry series. That's it. All right, number 12. Number 12. This is about slope field, and I will just give you guys a quick explanation for this, and we can pick out the answer. That's all. So this right here, this is how you are going to do the slope field. So that means when you have the x and y plane right here, right? What you should be looking at is, where is the derivative equal to 0? Imagine if you set this equal to 0, then of course you can see that y will have to be plus or minus 2 after you solve this equation. And when this right here give you 0, that means the derivative is equal to 0. That means the slope will be 0. That means the shape is going to be horizontal. So if you look at 2 and negative 2, like this, you can expect to have horizontal tangent segment like this. Right? So it's like just like that. Okay? And in fact, if you look at this equation here on the right hand side, it has nothing to do with x. So all you have to do is, you can make a quick table if you would like, but yeah, let's just make a quick table. I just need y. And you see dy dx is 4 minus y squared. We discussed it when we have y is equal to 2 and negative 2. I'll just put on 2 and then so I have 1, 0, negative 1, and then the negative 2. When y is equal to negative 2 or 2, the slope is just going to be 0. So that's very nice, right? Now, you just have to put 0 in here, and the slope will be 4. So it's positive. And if you go to when y is equal to 0, that means you are on the x-axis, and you just have to remember to draw the tangent segment with slope equal to 4. And slope equal to 4, man, this is like slope equal to 1. This is when dy dx is equal to 1. 45 degrees meant to be, okay? Slope equal to 4 is like really steep and it's going up like that. So you just have to know it's going to be like up like this and up like this. And earlier it was just horizontal, like that. You don't need to draw the arrow if you don't want to. You can just do like this if you like. It's meant to be really upward. It's meant to be really upward. And then the deal is it's meant to be the same for everything, okay? So it's meant to be like that. And if you have 1 or negative 1, you get 3. So it's going to be like slightly not that steep. So it's like this. I don't know, man. This is really hard to do. That's why it's a multiple choice question. Something like that. And if you have, let's say y is equal to 3, well, if you put 3 right here, you get 4 minus 9, which is going to be negative 5. Likewise, you also end up with a negative slope. So in the end, you actually end up with like when y is equal to 3, so you actually get like this. Something like that. Something like that. So which one does it look like? Yes, hopefully you can say it. Answer choice A. Right? Answer choice A. I have to do the answer choice right here because my picture doesn't look too good. So, yeah. Right? That's number 12. Now, number 13 is a fun one. We are going to integrate a crazy one. Inverse tangent of x squared over x squared. But the good news is that we don't need to do anything fancy. Actually, really fancy. We are going to be using power series. Anyway, right here, of course, we have to know how the power series of inverse tangent of x look like, and then we just have to make some change based on that, right? So, here's the deal. Let me remind you guys, when we have inverse tangent of x, this right here is going to be the series as n goes from 0 to infinity, and we have negative 1 to the nth power over 2n plus 1 times x to the 2n plus 1 power like this, okay? And now we just have to put this right here, all right? So let's see what I mean by that. First, we have the inverse tangent. Let me actually just change to this colored way, like this. Inverse tangent of, I need the x squared. If I need the x squared, that means I just have to put the x squared right here. So we are looking at this as the series as n goes from 0 to infinity. Let me just have more space. And then this is negative 1 to the n over 2n plus 1. Put x squared in here, so we have a parentheses with x squared in here, and then 2n plus 1, like so, okay? But we have to divide it by x squared. So that means I have to just multiply this by 1 over x squared, right? Same thing. Now, fix the power here, and perhaps this time I will use the purple pen. Why not? Fix the power. This is actually going to give you 4n plus 2, right? And you should also distribute the 1 over x squared in. So when you do that, let me do another color. This is like saying x to the 4n times x to the second power. This and that cancel each other out, okay? So to make this easier for you guys, all I'm saying is the integral, let's look at this. The power series for the inverse tangent of x squared over x2, this right here is nicely equal to the sum, the series. They are interchangeable, by the way. This is negative 1 to the n over 2n plus 1. All in all, you are just looking at this as x to the 4n power, right? After you simplify all the exponents and all that stuff. In the end, we are going to just integrate with respect to x, integrate this with respect to x, like that. Well, we can integrate inside of the radius of convergence, but to integrate this in terms of the form, we can just add 1 to the power by the reverse power rule, and then divide it by the new power. So I will put the 4n plus 1 like this. So finally, we will see. Let's usually put down the c plus first in this kind of situation, okay? And then I will have the series as n goes from 0 to infinity, and I'll just write this down for you guys. Negative 1 to the n over 2n plus 1. And hopefully we can still see my mistake on this. And this is x to the 4n plus 1. Right? 4n plus 1, like that. So that's the answer you guys can see, huh? Yeah. So this right here is it. All right. So this is how you deal with the integral if you have to just use the power series. The main thing is you have to remember the power series, right? You have to remember your friend, your best friend, and also the other friends. Okay, that was number 13. Truth to be told, I just realized that I forgot to put down the plus c on the answer choice, so I'll have to fix that. But I have the plus c on the shirt, so I'm good. Anyway, number 14, right here. All right, number 14 says, which of the following is an example that an approaches 0, but the series of an diverges? Right? So I will write this down here for you guys. Which of the following is that we want the limit as n goes to infinity of an, this being 0, but the sum as n goes from 1 to infinity, an diverges. So it's kind of like the reverse of the first question, kind of, right? It's like a supplement, not like a reverse. Because if you have the limit as an goes to 0, this right here, it can converge or it can diverge, but we'll see. Here are the examples. Well, here are the answer choices. The first one is an equals 1 over square root of n. Not bn. For b, an is equal to 1 over n factorial. And then an equals 1 over n squared. And d, we have e to the negative n. All right, here we go. First of all, take the limit as n goes to infinity. Everything here will be approaching 0. This one is the same as 1 over e to the n. And in fact, this is geometric. So now the question is, imagine we have to do the summation, right? Do the series on this. And I'm not going to write down the 1 to infinity because that's too much work to do. So just like this. The question is, which right here will diverge? Does this diverge? No, this is actually a convergent because this is a geometric series with the common ratio 1 over e. You can put this down as 1 over e to the nth power. So this right here, it converges. That's not the answer. This right here converges because it's a p series when p is equal to 2. This right here converges as well. If you would like, you can use the ratio test or you can do a comparison. You can see that this right here is smaller than this. This right here converges. That right here also converges by the direct comparison test. This right here, it's the same as saying the series of 1 over n to the 1/2 power. It diverges. So it's A. Diverges by the p series because p is only 1/2, right? So that's not good. No, series, I'm not talking about you, okay?
Sorry, I didn't quite catch that.
Alright, excuse my series. Yeah. Alright, so that's it, number 14. Now, number 15, I will just put it down right here. I will try to be slightly more organized if I can, because every time question is different, so I don't really know how much space I need for each one. So, an integral question, 2 sine x over sine of 2x. The angle here is x, the angle here is 2x. We have the double angle identity for sine. Let's go ahead and use that. So this is the integral. On the top is 2 sine x. On the bottom, sine of 2x is the same as 2 sine x times cosine x, isn't it? And then this cancel, this and that cancel. All in all, we're looking at 1 over cosine x. And we know we just have to integrate. This is just secant x. And integrating secant x, you should know that. Natural log absolute value of secant x plus tangent x, and we are done. Don't forget the plus c, which is on my shirt already. By the way, do not wear my shirt on the final. All right. So that's it. And then, yeah. Okay. All right, I'll do number 16, the really fast way. So I'll do 16 right here. This is a series as n goes from 1 to infinity, and we have 1 over n squared plus 5n plus 4. I will show you why I'm able to do this with this space. Here we go. Can we factor this? Yes. How would you factor that? Well, it's just n plus 1, n plus 4. And then we can do partial fraction. So let's see. This right here, we need n plus 1, and then we need n plus 4. Go back to the original, cover the same denominator. Well, I have to let n equal -1. Put it here, 1 over -1 plus 4, we get positive 1 over 3. For this, we go back to the original, cover out the n plus 4, n has to be -4. Put it here, we get 1 over -4 plus 3, we get -1 over 3. Now, check this out. Both of them have 1/3, so I will just factor that out. And this right here is a telescoping series. N goes from 1 to infinity, and we have 1 over n plus 1. And this is minus times plus, so it's a minus here, and then we have 1 over n plus 4, like this. Let's do this the fast way, because the fast way is really fast. What you do is the following. This is 1 over 3, like this. All right, look at n plus 1 and n plus 4. What's the difference between this and that? They are off by 3, right? They are off by 3. So this is what you do. You see the starting n value is 1. Look at the first term. You plug in 1, 2, 3 into here, and you have the first 3 surviving terms. So let's go ahead and do that. So first time you get 1 over 2, and then you add 1 over 3, and then you add 1 over 4, like this. Again, if they're off by 3, then just put the starting values, and then 3 of them, like 1, 2, 3, into the first term right here to produce the 3 fractions. But you're not done yet, because sometimes this right here will really matter. You also have to pay attention to the part you have to subtract. So to do that, what you do is, this is your ending part. You just minus 1 over m plus 4. And then the term before that, you also have to subtract. The term before that is m plus 3 on the bottom. And then the term before that is 1 over m plus 2. And this right here will be for the nth partial sum. And this is the quick way to do it. But here is the part that people usually miss. You have to take the limit as n goes to infinity. This right here, it's not so bad, because this right here will go to 0. This right here will also go to 0. This right here will also go to 0. So in the end, we are just looking at this as equal to, we have the 1/3 here, right? And we just have to multiply by 1/2 plus 1/3 plus 1 over 4, like this, right? And I'm just going to do the math for you guys. You just add them up, you get 13 over 36. So that will be the answer right here. All right, I'm turning out of frame so you guys can see better. All right. Yeah, I should have used the space over there, like it's a little bit more, but whatever, you know, because, yeah. All right, so I think we are making a pretty good progress. I don't know how long it will take me. It's been an hour. So the next year plan will be, of course, the 100 limits. Yeah, the one you guys have been asking. And perhaps I will do another 100 everything series. I will do 100 trick equation that you have to know and all that stuff. Oh, hey, we're done with another page. But for the multiple choice question, each page is like 3 or 4 questions because of the answer choices. So I'm not too happy because this is number 17. Right here. We will be finding the arc length, right? So we want the arc length. And we are given the curve sinh x. And we want this to go from 1 to 4 for the x value. X is equal to 1 to 4. Right? So for the arc length, just go ahead and remember the formula if you would like. Capital L is equal to the integral. And because we are going from 1 to 4, and thankfully, y is a function of x. So we can just do it the usual way, right? Open the square root, 1 plus, you put the derivative of this inside. Derivative sinh is positive cos. So you just differentiate that and put it here. Sometimes people forget to differentiate, they just put this down in here. That's no good. And you have that in the x world. You are in the x world because y is a function of x. So take advantage of that. And all I want you guys to do is to use your calculator. So use your calculator to enter that. You get 26.437, right? 26.437. So that's it. Right? So a quick question, just pretty much to see if you remember the arc length formula or not. Number 18. So this one, I don't know if your teacher covers this or not, but in my class, I do. What you do is you have a semicircle plate right here, okay? And then this is the water. So as you can see, you submerge just this part of the plate into the water, and I'll give you the dimension. From here to here is 6 meters, and from here to here is just 1 meter. Right, so that's the idea. And the question is, we're trying to find out the hydrostatic force that's acting on this part of the plate. And this is how we are going to do it. So force, hydrostatic force. You need to remember 3 components. I will write this down right here for you guys. What you need to know is you need to know the area. I will put this down in red, I think. I'll put it down in green, why not? I'll put it down in green. So you need to have the area. Put it down all the way at the end. And then you multiply by the density with the specific weight of the water, well, in the water, right? So depends how you want to say it, density with a specific weight. And lastly, you have to multiply by the distance, and this is the distance from the surface of the water level down to whatever, right? So now, let me show you what I mean by all this. For the area, this is a semicircle, but just excuse my picture. What you should do is, go ahead and set up your reference frame, namely your x-axis, all the way on the bottom. It's preferred it. I tried it with other students, right? If you tried it with other places, you can put the x-axis here or here, but everybody likes the bottom right here much more, right? And of course, for the y-axis, just put it right in the middle, right? So you can take good advantage of the symmetry like this. So that's what we have. Now, for the area, what we do is we want to take a horizontal slice, take a horizontal rectangle like this. Now, as you can see, for the area of this green rectangle, this right here, we are going to label that as dy because that's just a small change amount in the y values. It's meant to be really small, but I just have to draw it big so we can all see it. All right, and then I want the area of the whole thing. From here to here is x, right? Because when you go from the y-axis all the way to the right, that's x, the horizontal distance. But I need to know the whole thing, so I need to have 2x. So for the area of the green rectangle, it's actually what? 2x. So perhaps I'll put this down right here. I want the whole thing. I'll just put it like this. Right? So the area is again 2x and 2x times dy. That's the area of the green rectangle. Now, pay attention to the density. Namely, we are in the water and we are in the SI unit. So what we have to do is multiply by 1000 for the water and then 9.8 for the gravity. Then look for the distance. Now here's the deal. When you have this right here, this is the x-axis. From the x-axis to the rectangle, here is the y. All right? And this is the water's level. I want to know the distance from here to here. Look at this. This is the diameter of the semicircle. So that means this to here is 3. So the whole thing right here is 3. That means this right here will be just 2. Because all things 3 and this is 1 already. Well, from here, I need to go up to the surface of the water. And of course, this is y already. That means this right here will be 2 minus y, like that. And that will be the distance that we will have to multiply, 2 minus y. So that's pretty much it. And then in the end, we have to integrate this. Well, we are in the y world. The plate goes from here to here, namely from 0 to 2. So go ahead and integrate this from 0 to 2. And that's pretty much it. However, there's one thing that we don't like in this integral, namely the x. X cannot be in the y world. So what we have to do is look back to the picture. Because we have a semicircle, we can totally write an equation of a circle for this, right? But this time though, the center of the circle is actually right here. The center is actually at 0, comma, well, from here to here is 3. So the center is 0, comma 3. And yeah, the radius is 3, so that's pretty good. Anyway, let's go ahead and do the equation of the circle. So to do that, as we know, x minus h, which is just x squared, and then we add y minus k, which is 1 minus 3, and we square that, and that's equal to the radius, and we square that. And I want to isolate the x, so that we can put it here, and we will just have what? This is going to be x equals, move this to the other side, this is going to be 9 minus that, y minus 3 squared. But this was x squared, so just make sure you take the square root. And just the positive square root is enough because we are on the right hand side. That's the x, right? So positive square root is enough. Double that will be this. So for the x right here, you have to enter square root of 9 minus y minus 3 squared like this for the x right here. Put this here and then enter everything onto your calculator. And you will get approximately, I'll write this down right here for you guys, 6698. 6698. or maybe you should just do it on your own. 66980.42 Newton, and we're done. Because it's a hydrostatic force. So that's it. Alright, number 19. It looks like I'm slightly more organized. So we'll see. And number 19. Convert the Cartesian equation with the Cartesian equation. Okay. Cartesian equation y is equal to mx plus b. Yeah, the Cartesian equation. We want to go from here to polar. So this is convert. I'll just write it down. Convert this to polar. Well, remember the ingredients when we want to go to the polar world. We have a few things that we need. We need x is equal to r cosine theta and y is equal to r sine theta. Those are the two main ingredients that we need. So here we go. This y is r sine theta, so we have r sine theta, and that's equal to the m is still m. The x right here is r cosine theta, and then plus b, like this. And ideally speaking, we want to isolate the r. That's the idea, right? So in the polar world, isolate the r. It's not so bad. We can just move this to the other side, and both of them will have the r. So let me just factor out the r right here at the end, and then this right here is sine theta. Once we move this to the other side, it will become negative, so we have the minus, and we have the m right here, and the cosine theta here. Right, so sine theta minus m times cosine theta times r. Let me just write it down, better for you guys. Sine theta minus m times cosine theta, and then the r I will factor it out and put it at the end. This is multiplication. And the reason I don't like to put the r in the front is because sometimes some people may mistaken r as a function of this and you do the input. But no, this is just the multiplication. Anyway, you have the b on the right hand side. In the end, we can just divide this on both sides and we see r equals b over that. Sine theta minus m times cosine theta, and congratulations, you are done. We are done. Pikachu is done. All the stuff is done. So let's see. 20 questions took me 20 questions. Well, 19, so 20. It's 1 hour and 12 minutes. So 20 questions will take me about like an hour and 20 minutes, so 6 hours. Okay. And yes, for the short questions, some of the questions are longer because I will be doing some proofs with you guys. Alright, anyway, number 20. We are going to find the Maclaurin series. Namely just a Taylor series at a equal to 0, right? So we want x cubed sine x, right? Well, this is not so bad. This is just x cubed, but you have to remember what's the power series of sine x, namely the Taylor series when a is equal to 0, so that, right? So remember that this is the sum as n goes from 0 to infinity. Sine is an odd function. You will see all the odd factorial and also the odd power, and it's alternating. So you have negative 1 to the nth power over 2m plus 1 factorial that x to the 2m plus 1 power, like this. You have x to the third power on the outside, so all you have to do is distribute this right here, and of course you can just add the exponents. So we have the series as n goes from 0 to infinity, negative 1 to the n over 2m plus 1 factorial that x to the 2m plus 4, because 1 plus 3 is equal to 4. Alright, number 22. Pikachu question is here. Pikachu thinks the integral of tangent x from 0 to pi over 2 diverges. What do you guys think? Again, you should be trying the questions along the way and not just looking at the solutions, alright? So let's look at the integral from 0 to pi over 2 tangent x dx. First of all, why is this an improper integral? And you should tell me, Because if you look at the graph of tangent, it looks like this. And we have a vertical asymptote at x equals pi over 2. So for this integral, we're trying to get the area right here, if possible, if it's finite, right? Well, let's just go ahead and integrate this and see what happens. And this is technically going from 0 to pi over 2 minus. So just keep that in mind, because we have to stay a little bit away from pi over 2, just a little bit before, so like that. So take the limit as b approaching pi over 2, but if you put this down, it should be pretty clear. Alright, so we'll see integrating tangent. That's what you have to remember as well. We get ln absolute value of secant x for the inverse tangent. And if you guys want more practice with integrations, be sure you guys check out my integral video, the 50 integrals for integral starters, all the techniques you have to know, right? Anyway, you go ahead and do from 0 to pi over 2. And that's a minus, so you just go ahead and do that. You get ln absolute value, you have secant of, this is pi over 2 minus. And then minus ln absolute values. You don't need an absolute value though, but whatever. Like this. Alright, this right here, it's not so bad though. Secant of 0 is the same as 1 over cosine of 0, which is just 1. Ln of 1 is 0, so this is just minus 0. But what's secant of pi over 2? Well, if you would like, you guys can look at the graph of secant. And of course, secant x looks the same as, well, it's the same as 1 over cosine x. If you graph this, you actually get vertical asymptote right here as well. And x cannot be pi over 2. And you end up with a graph like this. Right? You can remember the graph, or you can use a graphing calculator. So when you are at secant, but pi over 2 a little bit before that, so you see this right here will go out to infinity. So this right here will be infinity. That means we have to look at ln of infinity minus, again, this is ln of 1. But because ln of infinity is infinity, that's 0, so on all we get infinity. So I will just tell you, yes, Pikachu is right, because this integral does diverges, right? Does diverge. There we go. Yeah, I feel the tiredness, but it's okay. We have just 80 something more to go. All right, so just do it like this. I need more space for that. All right, next one's a little bit different one. We are given a polar equation, and we're trying to get dy dx out of that. So here is number. Wait. I don't have question number 21. This is question number 20, and then this is question number 22. I didn't prepare question number 21. Oh well, question number 21 is missing. I guess this is actually question number 22. Yep. My bad. Anyway, just to avoid confusion, for myself or for yourself, I'm just going to keep the same numbering, okay? Otherwise, it'll be really confusing. So, the missing question 21. There's no question number 21. I don't know why. Somebody stole question number 21. Anyway, I can make one up, but no. Alright, question number 23. We are given r is equal to secant theta times tangent theta, and we want dy dx. So again, this is a polar curve, and we want to get the slope of the tangent line in terms of theta. This is how I remember how to do these kind of questions. For any polar functions, well, we can change that to parametric, because we know this. We know x is equal to r times cosine t, but because we are using the parameter here is theta, so I will keep it as theta. Likewise, y is equal to r sine theta. This is the parametric form. right? Again, we're using the theta as the parameter. Well, this right here, r is what? Just this, namely secant theta times tangent theta, because we're given this right here. I'll just put it here. And for the x component, just multiply by cosine theta. Similarly, for the y, we just do this. Secant theta, tangent theta, and we multiply by sine theta, like so. And then we will see that, okay, x is equal to what? Can we simplify anything? For the top one here, it's very nice because secant theta is the same as what? 1 over cosine. And this is cosine. So this and that cancel each other out very, very nicely. Right? This and that cancel each other out very, very nicely. So I think I will just write it down right here. We get tangent theta for the x. Yeah. Then if you would like to use t, that's tangent t, but I will stick with theta here. Now, this right here, again, is 1 over cosine theta. And if you look at this right here is sine theta. Now we are multiplying. We can put the sine theta on top of the cosine theta here, right here, right? So this and that together will give me tangent theta times another one. So we will have tangent theta, but this way here, because we have another tangent, this is tangent square for that. So that's pretty good. Now, dy dx. This right here in our situation, it will just be dy d theta over dx d theta. And let's just do the work. dy d theta is right here. We will have to bring the 2 to the front. So we have 2 tangent theta to the first power. But don't forget to multiply by the derivative tangent because of chain rule. So we have to multiply by secant square theta right here. Divided by dx d theta is just the derivative tangent theta, and that's just nicely equal to secant square theta, and yes, this and that cancel. In the end, we just end up with 2 tangent theta, and that is very nice, like that. We're done. All right. Number 24. I think I should be able to fit in here. We'll see. All right, here is the series as n goes from 1 to infinity and -1 to the nth power over n3 to the nth power, and then x minus 2 to the nth power. So we know this, and I will also tell you r is equal to 3. But we will try to find out what's the interval of convergence, right? So now this is how we're going to do it. Because of this, we know the center A is at 2. And since the radius of convergence is 3, so that means starting at 2, you can go to the left 3 units and the right 3 units. So I'll just draw the picture real quick, 3 and 3. So we'll end up with 5 and -1. This is 5 and this is -1. But the problem is that I do not know if this will converge when x is equal to -1, nor I don't know when x is equal to 5 if this converges or not. So I will just have to check the endpoints. So if x is -1, right? If x is -1, put this here. We are looking at the series n goes from 1 to infinity, and we have this -1 to the nth power over n times 3 to the n times -1 minus 2 to the nth power, like this. Now, let's do this in your head. This right here is -3 to the n. This is -3 to the n, and this is going to be -1 to the n times 3 to the n. Yeah? And you see, 3 to the n, and that will cancel. This -1 to the n times -1 to the n will be +1 because it's -1 to the 2n. So this right here will give me the series as n goes from 1 to infinity of just 1 over n. Alright? And the problem with this is that, well, this right here is a harmonic series, so it diverges. So I will just put this down right here. For this one, we cannot include -1. So it will be a parentheses and -1 right here. Now, I will just have to check when x is equal to 5. When x is equal to 5, it's the same idea. And just put 5 in here, we get -1 to the n over n times 3 to the n. And you put 5 in here, so this is 5 minus 2 to the n, like this. Now, this is just going to give us 3 to the n, and this and that will cancel out. So we are looking at this series as the series as n goes from 1 to infinity. We have -1 to the nth power over n. And this right here converges by alternating series test. Or if you would like, you can also say this right here is the alternating harmonic series. So it converges. And either way though, it does work. So I'll just come here and do the square bracket. So this is -1 to 5 with a square bracket right here. So that's it for that. Okay? So have a look. Man, this is like the most efficient part, the most efficient board that I have used so far. I wrote down 4 questions in here. So just to make up the question number 21 that I didn't have, I will just give you guys maybe one more then if in the end. I will see. All right, number 25. Number 25. So I will just perhaps read the questions with you guys along the way. It says you have a, let me see, you have a rectangular swimming pool. Length is 20 meters, width is 12 meters, and the depth is 2 meters. Filled with water to 1.7 meter mark. How much work is required to pump all the water out? Right, so let me just draw a picture to demonstrate the situation. So in the front right here is 12. So I'll just say this right here is 12, and the whole depth is 2. So the whole thing right here is 2, and then is 20 length. So I'll just say it like this. If you reverse the 20 and 12, doesn't matter because it's a rectangle anyway. But the depth, that's how deep the water is, it has to be the vertical. So that's the only insist. The water though, it's only up to here. So the water is only up to here. So that's the water, only up to the 1.7 meter mark, right? So perhaps I will put this down right here. This is the 2 on the outside, and this right here is the 1.7. Again, the whole thing is in meters and all that stuff. All right, now to do this again, we have to have a reference frame first. Actually, no, I haven't done this. Now this is the first work question that we're doing here. All right, so I will put down a reference frame right here. So here we have the x-axis, and here we have the y-axis. Right? And what we are going to do is we are going to consider horizontal slice first. So here we have a rectangle like this. And this is a pretty bad one, man, I'm sorry. And then, of course, this right here extends to the other side. It's meant to be like a small rectangular box. Really tiny one. Right? So, man, the picture is not perfect, so I'm so sorry on that. And then, of course, this extends to this and all that stuff, right? So you have a rectangular box. It's just like a piece of paper, and the piece of paper actually has a volume as well. Now, we need the following. And let me just write this down right here for you guys. We are going to calculate the work, right? We need 3 components. These are the 3 components you should be looking for to construct your integral. All the way at the end. First, though, you need to have the volume. This is a different situation than the hydrostatic force. For the hydrostatic force, you need the area. This right here, you need the volume. You have to move this volume up. Next, you need the density or the specific weight, depends on how you want to say it. And lastly, you have to multiply by the distance that you have to travel in order to pump the water out, right? So you don't just go to the surface level of the water, you actually have to go to the top of the swimming pool because you have to pump the water out, right? So that's the main difference between the distance. All right, here we go. Do this one first because it's better this way. Just trust me, yeah, because I'm tired already. So anyway, this right here, I will label this will be dy because it's just a small change amount in the y value. Good thing right here, it's always 12 because it's like this, the distance is always 12. Same thing, this is always constant, vertical up, right? So for the volume, it's just 12 times 20 times dy. Right? That's it. There's no variable, there's no x, we're good. Volume of the horizontal slice. Then density, and again, we are in meter. I'm not going to put on feet, the US unit, in this file because for the book, they say the water weight about 62.5, right? Pound per cubic feet. The book does that 62.5, but in other sources they say 62.4. So I just want to reduce the confusion. So remember, the only thing different is that if you're in the SI unit, you do 1,000, and everybody can agree on this. And you also multiply by the 9.8. But if you're in feet, that's the US unit, you do not need to multiply by the 9.8. So that's the main thing. Now, distance, well, again, from here to here is the y, okay? But per our conversation earlier, we have to go all the way to the top of the swimming pool so you can pump the water out. Therefore, you get 2 minus y. The whole thing is 2. This much is y already, so the whole thing is 2 minus y. That's the distance. And then please integrate this, and we have to integrate this from just how much water that you have, namely from 0 to 1.7. So I'll write this down here for you guys, 0 to 1.7. Okay, so that's pretty much it. And I don't know if I should just tell you guys the answer or you should do the work. All right, you do it. On the final, do not just put it down, you do it. You actually have to do it and tell me what the answer is, okay? I'm the teacher, okay? I can tell you guys should do it and then tell me the answer. But do not just tell the teacher to do the question. No, don't do that. So just for fun, you guys do this one, okay? So that I can make sure you guys are paying attention. Leave the answer down below and let me know what you guys get. And perhaps for the next one, I'll also tell you guys to do it, even though I know what the answers are, right? But I will tell you guys to do it. Given the integral from 1 to 4, and you have 2 to the x over 1 plus x dx. We want M3, not the car, right? Not M4, M5, and whatever, not the car like that, but this is the midpoint rule to calculate the, to approximate the area. This is what you do for the midpoint rule. And this is what I recommend you guys to do. M3 means n is equal to 3, right? This means n is equal to 3. You're going to use 3 rectangles to do this. So perhaps it's a good idea to find out the delta n, the delta x, sorry. Perhaps it's a good idea to find out the delta x, which is just 4 minus 1, over the n value, which is 3. All in all, it's just nicely equal to 1, right? Then this is what you can do. I will just draw a number line for you guys. I'll just draw a number line from 1 to 4. And I'm going to cut this into 3 parts. So I'll just cut, that's 3 parts. And of course, each one will be with length, with width 1. So it's 1, 2, 3, 4. Good. However, these are not the x values that we're using. Because we're looking for the midpoint, we will be looking at this right here, which is 1.5. This right here, the middle of this and that, which is 2.5. This right here, which is 3.5. These are the by the formula, they have the x 1 bar on that. The average of this and that, right? So now, here is the midpoint formula for that. M3 equals, first of all, you have to do the delta x, which is just 1. right? The delta x is just 1. And the idea is that you are just finding out the width of the rectangle, which is just 1, delta x. And then you multiply by the height of the rectangle. And this is the x value that you're going to use. And because everybody will have the same delta x, so you can factor out delta x all the way to the front. And then you do f, which is this function right here. This function is our f of x. And you enter 1.5 in there. And then you just continue. Next one, f of 2.5. And the last one is f of 3.5. And that's pretty much the idea. So I'll just write this down a little bit here, plus f of 3.5, like this. And again, the delta x was 4 minus 1 over 3, which is 1. And that's the delta x that do over there. All right, so again, you just plug in numbers and then you work this out. And I will really do this one for you guys, I guess. 5.262. But this one, you guys do it, right? Anyway, so do that one. Yeah. All right, so how are you guys doing? It's only been 1 hour and 36 minutes, and it's 5:20 p.m. right? And also it's dark already because the daylight saving and all that. So now we have it's at night. So I have to multiply this by 4. All right, so again about like 6 hours. Man. All right, why do I like to ask this kind of question now? Which of the following? Hold on. So which of the following converges absolutely? Man, so I have to do like 4 questions again, kind of. Anyway, 27. Which of the following converges absolutely, right? So I'll give you guys the choices. So here we have A is the series as n goes from 1 to infinity, and everything has like -1 to the nth power, right? So this is the first one. Second one, the series n goes from 1 to infinity, and we have -1 to the n over square root of n plus 2. C, the series as n goes from 1 to infinity, and -1 to the n, and we have n to the third power over n third power plus 1, and D. And again, you guys should be thinking about this along the way already, okay? And let me know if you are watching it like as I go as well. That would be really cool. So if you are doing that, let me know. So I hope this right here makes you feel like you are in the review section with me, even though right now there's no students. Anyway. All right, so how do you check if something is absolute convergence or not? Well, look at all this, and you apply absolute value to them. Do not do alternating series tests, because for the absolute convergence, all you have to do, you take the absolute value, and it pretty much will just make a -1 to the nth power disappear. So, for example, the first one is going to look like the sum as n goes from 1 to infinity, 1 over n factorial, like this. And the second one is going to be the sum as n goes from 1 to infinity, 1 over square root of n plus 2. And then this right here. So we're looking at this right here and see which one still converges after we take the absolute value. What do you guys think? Does this converge? No. You can do a limit comparison test with 1 over n, because you can ignore that and you can reduce that to 1 over n. They are pretty much about the same size. So this right here does not converge. How about this? Not converging neither, because you have n cubed over n cubed. So an will go to 1 by test for divergence. This right here does not converge. This right here, if you ignore the plus 2, this is very similar to 1 over n to the 1/2 power. So by the p series, that does not converge neither. This right here does converge, because you can show that this right here is less than the sum as n goes from 1 to infinity, less than or equal to the sum is that 1 over n squared, if you would like. right? Because you can just use the list if you would like. And yeah. Yeah, that's it. Well, you can do it like that. Or you can also do a ratio test if you would like, but like anyway, this right here converges. Yeah, or ratio test. So choice A is the absolute convergence. All right, so that's it. Now 28. Okay, so I have to write down some notes for myself so I can remember the numbers I'll tell you. Okay, so I'll read this along the way for you guys. It says you are going to put 600 fish into the lake, and you are going to estimate the carrying capacity is 15,000. And after 2 years, the fish has tripled it. And assuming we are looking at this as a logistic equation, and we're trying to find out the fish after another 2 years. So here we go, dp dt. Here is how you set out a differential equation for this situation. This right here is k p times 1 minus p over m, like this, right? All right, so here we go. P is the population. And let me just tell you, whenever you have the logistic differential equation, you can solve this if you would like, but for my class, I actually tell you guys about the general form. And the general form is, this will tell you the population as a function of time is equal to m, which is the carrying capacity, and then you do 1 plus c e negative k t, like so. And in our case, m, it will be 15,000, right? And I will also tell you the c right here, well, c is actually equal to this, right? I'll write this down right here for you guys. You do m minus p initial divided by p initial. So in another word, m is 15,000 minus the initial is 600, because you put the 600 into the lake and you divide it by 600. So you actually end up with 24 for the c, right? So this is what you know, and that's the initial that we know, the 600. So we actually solved this already, and you can see that this is p of t equals 1500 over 1 plus 24, and we have the e negative kt. This right here will be the general form that we need, right? But be aware, sometimes you may be just given this differential equation, and if you need to solve it, you can actually use the form I just told you in my class. And if I ask you to prove it, then you just have to prove it then, okay? So that's the thing. And then based on this, based on what we know, after 2 years, the population has been tripled. So I will tell you P2 is going to be tripled, so I will put down 3 times initial, which is 600, like this. So now we just have to put in the 2 into the t, so I'm looking at this as 15,000 over 1 plus 24 e to the negative k, and the t is again 2. And again, triple the original, right? So this right here is the thing. And now, I will solve for the k for you guys, okay? So let's see how we can do it. I will multiply this on both sides and divide this on both sides. So this is going to look like 1 plus 24 e to the negative 2k. That's equal to this right here, which is 15,000 over, this is 1800, we know, so I can just put that down. I'm not going to reduce because you do it on the calculator anyway. And then you minus 1 on both sides. So I will do this for you guys, okay? Here is 15,000 over 1800. Minus 1 on both sides. And then divide the 24 on both sides. Yeah, divide the 24 on both sides. So I'll put it as 1 over 24. And now you have e to the negative 2k. Then I will have to take the natural log on both sides. So I'll take the natural log on both sides. So I'll take the natural log, I'll put a natural log like this of the whole thing, right? Divide, well, you take the natural log, so you have negative 2 now, negative 2k, and then divide the negative 2 on both sides. So you get k is equal to negative 1 half all that, and I'll tell you k is approximately, and this right here, I will have to write it down because just to save time. This is approximately 0.5928. 0.5928. So you can come back here now and you can say, hey, the equation is actually P of t is equal to 15,000 over 1 plus 24 e to the negative, and the k is that, namely 0.5928 t, like so, right? And in the end, of course, you can just find out p, and it says we want the amount of fish in, well, after another 2 years. So all in all, we will have to put on 4 because it's 4 years after we started. So you put on 4 right here. So in the end, you just get 15,000 over 1 plus 24, and you have e negative 0.5928 times 4, like this, all right? So that's pretty much all you have to do for the P of 4. And of course, you can work this out on your calculator. And don't forget, we are talking about the number of fish. So whole numbers, okay? So this is approximately 4628 fish. 4628. And of course, I will have to show you guys the signature fish, right? So 4628. This is my fish. Really happy. It's really happy. All right, so have a look right there. All right, almost 2 hours, man. All right, so I'm going to erase. Now, oh, okay, we're doing an improper integral, so I will just put that down right here, number 29. Man, this marker is about to be done. I'll try to finish until 2 more questions. Multiple choice questions. They aren't so easy, huh? 0 to 1, x, ln x, dx. We're trying to get the value out of this. Okay, first of all, let me tell you, do we have any vertical asymptote? That's like a bonus question. It seems like it, huh? Because if you put 0 in here, ln of 0 plus, technically is it goes straight down. It's a vertical asymptote. However, when you multiply by x, check your calculator. You actually do not have vertical asymptote for this function at all. But anyway, we are going to see the value of this integral, and this is how. Let's just go ahead and integrate it, and then plug in numbers and hope for the best. So here we go. This right here, x times ln x. What should we do to integrate? Integration by parts. Good. So di on the side, plus minus. To get ready, I will be differentiating natural log of x and integrating x, right? Because integrating ln x, you have to use integration by parts again. Good idea to differentiate ln x. We get 1 over x. Integrating this guy, we get 1 over 2 x squared, like this. Multiply, and then this right here still give you another integral. So we see that this right here is the integral. So this right here, this times that, it's the first part of the answer, 1/2 x ln 1/2 x squared ln x. Yeah? And then this right here gives you another integral. This is the minus, and you have to still integrate. Now check this out. Of course, 1 over x and that cancel out, so we just have x to the first power, and we have 1 over 2 right here, x to the first power only, right? And we have the dx like this, right? So this is x to the first power. All we have to do is, of course, you add 1, which is 2, divided by that, so you have to multiply by another 2. And let me just finish the integration steps first, and then plug in number. 1/2 x squared ln x minus 1 over 4 x squared, right? Now, don't forget, we still have to go from 0 to 1. So we have to go from 0 to 1. First thing, putting 1 into all the x. So it looks like 1/2 times 1 squared ln 1 and then minus 1 over 4 times 1 squared, like this. This is the first part, and then we put in 0, but here's a small trouble. When we put in 0 into here, we end up with 0 times ln 0, which is like 0 times negative infinity. That's no good, but I will write it down anyway first. 1/2, and here's the trouble, so we'll have the 0. This is going to look weird. We'll just put on 0 squared, ln 0 minus 1 over 4, 0 squared, like this. Right? Well, let's do the easy part first. This right here is just 0 because thanks to ln 1, this right here is 0. This right here is just 1 over 4. So all in all, we have negative 1 over 4. Yeah? But if you're doing this, right? If you're doing this as a short equation, then this is what you have to do. This is no good. Because again, this is at 0 times negative infinity. And you have to remember, this is at saying 0 plus, meaning you are taking a limit. So what you have to do is the following. I will have to erase more space, so I have more place for me to do work. All right, so for this part, you have to just make a note on the side. You have to take the limit as x approaching 0 plus. Again, when you put a 0, it's actually because 0 to 1, so it's 0 plus. Of this portion, you have to take the limit. So ln of 0 plus. And you have the 1/2 x squared times ln x. Again, the trouble here is that you end up with a 0 times negative infinity situation. Namely, we get an indeterminate form. So we have to do more work on this. And this is what we can do. Still have the limit as x approaching 0 plus. I'm going to bring the x squared. Down. So you will see, actually, I will also take this with me, the 1 over 2. I will take this with me down to the denominator. No, I don't want to. I think that was too bizarre, but actually, the 1/2 can be all the way in the front, but yeah, let's just do that. Let's put the 1/2 all the way in the front. So we have the 1/2. So that wouldn't bother us, the limit as x approaching 0 plus. So the 1/2 will be all the way in the front. It's a constant multiple, doesn't matter. I'm going to keep the ln x on the top over, bring this down. So I get 1 over x squared. Then I will differentiate the top, differentiate the bottom. Because this time, when you have 0 plus in here and here, you are talking about infinity over infinity. So you can use L'Hopital's rule, so LH applies. Then when you do this, you get 1 over 2, still take the limit as x approaching 0 plus. This right here gives you 1 over x. This right here, write it as x to the negative 2 power, you get negative 2 times x to the negative 3, which is 1 over x to the third power, like so. Right? And then what you can do is, okay, notice how this and that cancel out, because actually I'll just do this for you guys first. Let's multiply bottom and top by x cubed. So you're looking at this as 1 over 2, limit as x approaching 0 plus. This right here give you x squared, yeah? Over, they cancel, and you have the negative 2. But anyway, this and that cancel. But anyway, this times this plug into here, you end up with 0. Anyway, so all this right here is equal to 0 by note. Right? By the note. So you have to supply this computation for the indeterminate form computations for that. So this is 0. That's also 0, of course, obviously. Now, the answer is just negative 1 over 4. So that's pretty much it. And yes, I know this is the multiple choice question. So if you just put down 0, it's not the best, but whatever, you got the right answer. But short work, you do have to supply the computation for the limit for that. Yes, no, not yet. I cannot do that yet. One more question till the end of the multiple choice. Number 30. This right here, man, It's a series as n goes from 0 to infinity, 1 over 2 to the n factorial. Oh my god. This time, we are not talking about does it converge or not. We actually want to find the value for this. Man, how can we do this? Well, we have the n factorial on the bottom, and there's no such thing. There's no like 2n plus 1 whatsoever. Which power series do we know that has the? Which function do we know has the power series with a 1 over n factorial on the bottom? E to the x. Yes. So let me write this down right here for you guys. We know that when we have e to the x, this right here is equal to the sum as n goes from 0 to infinity. Again, it depends on what the x is, right? We know this right here is equal to 1 over the n factorial, haha, and then times x to the nth power, like this. And this is good for all x. Any x value that you want, you can plug in x equal to whatever you want. Maybe not I don't know. But anyway, this right here, it works for any real number. Now we have a 1 over 2 to the n. This is x to the n, so what should we let x equal to? 1/2. Yes. Look at, this is e to the 1/2. I'll just do like this. Let x equal to 1/2. So you're looking at this as the sum as n goes from 0 to infinity, which match perfectly. And then this is 1 over n factorial. And then the 1/2 is right here. And then the n. Isn't this the same as the one that we have? Yes, it is. This is just nicely equal to the sum as n goes from 0 to infinity. 1 over 2 to the n. Let's put that down first, and then n factorial that, right? And of course, we can now put in 1/2 in here, namely e to the 1 over 2 power, namely square root of e. And we are done. Okay, so that's it. Not so bad, huh? Okay, all the multiple choice questions took me about 2 hours. Well, I'm not just doing the questions, okay? I don't just do the questions. That's not what this channel is about. It's about showing you guys how to do it so that you guys can do it too. That's the most important part, right? You guys need to understand the ideas and the procedure, and yeah. Okay. Number 31. Okay, word problems. I need me more water. I'm going to read this for you guys. Okay. You should have the PDF with you, so read the question and do it first, because I wrote down the answer on a PDF so I can see what the numerical answer is. Okay, now we're going to read it together. It says you have a tank and it is with capacity of 400 liters, and now it's full of mixtures of water and chlorine. And the concentration is 0.22 gram of chlorine per liter at the moment, right? That's the initial thing. And in order to reduce the concentration, you are going to have fresh water, right? Fresh water is pumped into the tank at the rate of 12 meters per minute. And the mixture is kept stirred perfectly and is pumped out at the same rate. And let A of t equal to the amount of chlorine in the tank. After 10 minutes, what's the amount of the chlorine that you have after 30 minutes? I know the answer is right here, but now let's see how to do it. For the word problems, this is what I suggest you guys to do. Take some, drink some boba tea first. I realize I'm hungry too. So I should have a bigger lunch earlier. I only ate a little bit. That's not smart. But anyway, here is number 31. Excuse me. All right. Yeah. So this is how you are going to do the tank mixture questions and all that stuff. So here we go. You always need to write down what you know and what you want to know. So let me demonstrate what we mean by this. What we know is the following. First of all, when you have like anything coming in and things go out, you are going to look for the difference between the rates. So here's an example. Suppose you have a household. You have the dad, the mom, and then the kid, right? Like this. And now as you just all know, the parents are the ones who are making the money. The kids, the one who is spending the money. And suppose on a daily basis, the daily income for them is $400. But the kid is going to spend $100 per day. So may I ask you, what's the rate of change of the money that they have per day? $300 per day, right? How do you do it? This minus that, right? So that's the idea. So in this kind of situation, the ADT, all you have to focus on is the rate in minus the rate out. So I will just write this down right here for you guys. This is the rate in, and I will also tell you, I will just tell you the rate of the chlorine going in, and then you have to minus the rate of the chlorine that's going out. Whew. All right, so let's focus on the setup first. Well, first of all, you can imagine you have a tank, so maybe just like this. You have you want to dilute this, right? So you are going to put in fresh water in. So what you are actually going to do is, even though you have stuff coming in at the rate of 12 meters per minute, this right here is 12 liters per minute. This right here is a flow in rate, but let me put it down. You also have to multiply by the concentration though. But because it's again fresh water, so you have to multiply by 0 because fresh water does not contain any of the substance. So let me remind you, this right here is the flow in rate, but you have to consider the concentration as well, right? So it's slightly more complicated than the money example I gave you, but the money example hopefully shows you this is actually the ideal to go. Now we're going to minus the rate out. Well, the flow out rate will also be 12 because it says the solution is pumping out at the same rate, so it's 12 as well. But how would you multiply by the concentration? That's all we need as well. So think about it. Again, this is the flow out rate, but I would like to know the concentration. Well, how do you find the concentration? You can just look at what's the concentration of the boba. All you have to do is just look for the amount of boba in the T here and divide it by the whole volume, right? That's pretty much the idea. Amount divided by the whole thing, the whole volume. The amount, it changes. It's A divided by, it says the whole tank is 400 liters of water, well, of the solution. So you divide it by 400. Amount divided by the whole thing, whole volume. That will give you the concentration. So this right here is the setup, right? So that's the idea. But I'm going to erase this so I have more space for you guys to do the work for you guys. And now I will actually put this down. This is what we know, the ADT. In this particular situation, this right here is 0, so it doesn't matter. This divided by that, I will tell you is negative 0.03. Just decimal is easier. And then we have the A. So this is what we know. And do we also know any initial condition? A of 0 is what? Well, originally you have 400 liters, but it says 0.22 gram per liter is the chlorine, right? So what you are going to do is this right here is saying 0.22 times 400. Again, concentration times the volume will give you the amount for that. In this case, you're talking about the amount. amount. And earlier it was the amount of the quantum that's coming in. That's why it's the rate, right? Anyway, if you do that, you get 88. So this right here is what you know, and this is what you want to know. You want to know what A30 is equal to. So that's pretty much the idea. Now, with this in mind, go ahead and solve the differential equation, plug in the numbers, everybody happy. So here we go. I don't know if I ever should do the 100 differential equation in one take. I don't know. Anyway, I'll just do it now. Anyway, dA dt is equal to this, right? So I'm going to divide this on both sides. So here we go, divide this on both sides. We get, let me leave a negative here, okay? So let me actually start over so that it's more organized this way. Negative 0.03a. Here we go, solve this differential equation. Move this. Actually, I can just divide the a on both sides. That's even better. So divide the a on both sides. So we have 1 over a. And man, that's actually pretty easy. So this divided both sides by a. And this is equal to negative 0.03 dt. And this right here is with the dA, of course. And multiply the dt on both sides. So that's pretty much how you separate the variables. Divide this right here and multiply the dt on both sides. And this is the dA. And now just go ahead, integrate. On the left-hand side, this right here is ln of a. Hey, did I forget about the absolute value? Yes, but I don't need to worry about the absolute value because this right here, we know the amount is always greater than or equal to 0 anyway. It's actually greater than 0, right? Well, greater than or equal to 0, so you don't need the absolute value, right? Anyway, this right here is equal to, integrate this, we get negative 0.03 t plus c1, if you like. Now, e to this power, e to that power, this and that cancel. So, we get a, which is always positive. Now, I don't need to worry about the absolute value. And this right here is e to this power, so we have this is equal to e to the negative 0.03 t, and then the other part is e to that, and you multiply. So you multiply by e to the c1, yeah? But e is a constant, c1 is also also a constant. Let's just put on c2, you guys know that deal already. So that's the equation that we have, right? And now, perhaps you can write this down as a as a function of time. And with this right here, I can just put on 0 into t, and we know a of 0 will be ATA. That would be C2 times e to the negative 0.03 times 0. This is just going to give you 1, so that means C2 is equal to ATA. So in other words, we know a of t is just nicely equal to 88 e to the negative 0.03 t, like this. And of course, now we just have to put in 30, so a of 30 is going to give us 88 times e to the negative 0.03 times 30. And we'll use a calculator. This is approximately equal to 35.78 grams of the thing, of the boba. All right, so that's pretty much it, right? So again, let me know how you guys are doing. Are you guys still watching, or maybe you're just doing all the questions on your own, and that's even better. And perhaps you guys can just like play this while you do the questions, so that you can feel that I'm doing the questions with you, right? I won't make my students do the things that I won't do. Okay, so tell my students, if you can do like 100 questions to prepare for your final exam, then you'll be doing well, right? So I'm doing the 100 questions with you guys as well. Okay, 32. I know it's hard. I know it's tough. I know it takes a lot of time, but I'm doing this with you guys too, right? Anyway, number 32. We are going to find a parametrization, right? Parametrization of the time interval, with time interval, and you want a circle. with a circle radius 2, center here 1, 2, and starting at 1, 4. So now, here's the picture. Here's the picture. Let's look at this from a picture first. So we have 1, 2, and then the radius is 2. So I will have to make sure my picture makes sense. So let's say this is 1, and this is 1, 2. So this is 2. Right? And we have the 4. This is our starting, right? And this is the center of the circle. So I will make this in red, 1, 2. And you want to go, the first one, you want to go counterclockwise. So counterclockwise, CCW. And we want, again, a circle, radius 2. So this much is 2. Counterclockwise, it will go like this. So I will go like this. So I will put this down in black, and then again, it's this way. Right? So for counterclockwise, this is actually easier because this is the usual orientation if you do the following way. So for the following way, it will work out nicely. You have the x and also the y equation. Remember, x is with cosine t and y is with sine t. But this time, the radius is from here to here, which is 2, right? So what you have to modify is, you just multiply this by 2 and 2. That's pretty much it. And this right here though, it's unfortunately not at the center, but it's okay, no big deal, it's a small fix as well. The x value of the center is 1, so just come here and just add 1. So of course this is on the outside of the cosine t, and the y value here is 2, so we just come here and put parentheses and we add 2. That's it. However, if you do it this way, you have to be really careful with the time interval. This right here, I will tell you on the time interval. I will just, on the time interval. How should I say? For time interval, something like that. Okay. I need to know the time interval. Usually, if you just go from 0 to 2 pi, it will start right here, the positive right-hand side, this part right here, and then just go counterclockwise. But this time, we want to start right here. So, you actually want to start at the pi over 2 direction. So I will just say, we have to go from pi over 2, and then you are going to go all the way, one loop, right? So that means from pi over 2, you add 2 pi. Well, you add 2 pi to it. Of course, it's the same as adding 4 pi over 2. So you have to go from this to 5 pi over 2, like that. So this is how you go from the counterclockwise situation. And part B, we want the clockwise situation. So for the clockwise, again, it's the same circle, but we go this way. So perhaps I will put this down in green, so you guys can see the difference. Part B, clockwise. Now, you can utilize the same equation and the same time interval, and you can just do the following. Let me show you. So if you would like, you can still just write down, we have the 2 cosine something, and then plus 1, and then y is equal to 2 sine, and the input is going to change, right? And then plus 2, like this. On the time interval, from pi over 2 to 5 pi over 2, right? That's the one that we have originally. And this is how you can do it. Go ahead and look at this and look at that. So I'll just put this down here for you guys. If you want to travel backwards, right, this is pretty much the backwards. All you have to do is add them up. So I will pi over 2 plus 5 pi over 2. Add them up and then minus t after that. And congrats, this will be your new input. Of course, add them up. This right here is 3 pi. Just work it out and then minus t. Now you can just put this down right here, which is 3 pi minus t, and put that down right here, 3 pi minus t. So this will do it. And usually for this kind of questions, I don't request students to simplify too much. This right here is pretty good. It's good enough and it will get the job done. And if you guys are watching, if you guys have other way to do this backwards iteration, you guys can let me know as well. But it's not as simple as you just make the t negative. It's not like that all the time. But if you want to travel backwards, this will always work, right? So that's question number 32. Now, another integral. Number 33. We can still use this marker. Let's see if I can hold up to number 40. Probably not, but whatever. Integral sine to the 5th power x, cosine to the 3rd power x, dx. Alright? No, cosine to the 2nd power, my bad. Now, here we go. If you haven't done integral for a while, this is the time, alright? This is cosine to an even power, sine to the odd power. Ideally speaking, sine cosine can help us out, right? But I want to have one of them being on the outside so I can do some cancellation. And when you want to use identity, you prefer to look at sine to an even power or cosine to the even power, right? Now check this out. This is cosine to the even power, so I will keep it. But I will focus on sine to the 5th power. And I'm going to rewrite it as integral. I will put this as sine to the 4th power x times sine x. I want to have this on the outside, right? And this right here is going to be still the same as cosine square x dx, like this. I want to take this out of that. And the reason why is because we can look at this as sine square and then square, which is the same as that. And when you have sine square x, you can change that to cosine nicely. So this is going to be the following. Integral, parentheses, again, this right here is 1 minus cosine square now, square, and then we have the cosine square x on the outside. And this guy is still the sine x that we had earlier. From this, yes, we can just do a nice u substitution. So we will, I will let u, why did I write down that, but however, let u equal to cosine x, and then you will see du is equal to negative sine x dx. And if you would like, you can divide the negative sine x on both sides. Dx is equal to du over negative sine x. This right here will help you to maintain the signs, like the positive negative signs, much better. Alright, so now let's see. Here we have the integral. This is 1 minus cosine to u now, so we have 1 minus u square, but on the outside we have another square. And this right here is cosine square, so that's another u square, like that. Alright, so if you want to see a cancellation, here we go. This is the sine x times dx is just du over negative sine x. Right? So you have all that stuff. Then cancel, cancel very nicely. Now, this is the deal. This is the negative sign. Let's take that all the way to the front. Integral. Well, you have pretty much this remaining, right? So what we'll have to do is we are going to expand this part. So when we do that, we get 1 minus 2u squared plus u to the 4th power. Again, write that down twice if you like, and then multiply it out. But you can also use the formula, this square minus 2 times that, plus this square, which is the one I just put down for you guys. And then the u square on the outside, du. Okay, now, I will still maintain the negative on the outside. Integral. I have to distribute this guy. So we have u square, yeah, and then minus 2u to the 4th power, and then plus u to the 6th power. Yeah, du, like this. And you know what? We can finally integrate. Alright, so now, here we have the negative, open the parentheses for the result of the integration. This is u to the 3rd power over 3 right here, right? So I'll just put that down. 1 over 3 u to the 3rd power. I'll put the u in red too, so why not? And this is minus 2 over 5 because I have 1 divided by the power. So 2 over 5 u to the 5th power. I have 1 divided by that, so we get plus 1 over 7 u to the 7th power, like this. U is what? U is cosine x, so I'll put that down. In the meantime, I will also distribute this, so it will be negative Yeah, negative 1 over 3. Let's see if I can write it down nicely. Cosine third power x. Okay? Okay, so we have enough space. And then negative times negative, so that's positive. So this is a plus now. And we have the 2 over 5. U is, again, cosine, and this is to the 5th power, and we have the x. And then this times that becomes a minus 1 over 7, and we have the cosine 7th power x. This is my 7. And we are done. Ah, very good, huh? All right. Whew, okay, number 30, we have a look, right? All right, number 34. We have a crazy integral of ln of 1 plus x cubed dx like this. But not so bad. We'll use power series, right? We'll use power series. In fact, to make this better, I will use a new marker for this. So, just excuse me. This is really, here we go. I don't know how long this is going to last me. Let's see, number 34, so we'll see how long this takes. All right, so we are going to just integrate this with power series. That's all right. So, of course, we have to remember the power series for the natural log of, oh my god, much better, 1 plus x. Right? So, here we go. This right here is equal to the series as n goes from 0 to infinity, negative 1 to the n over n plus 1. And here we have x to the n plus 1 power. If you need to remember or maybe see more examples on power series, I have a 26.2 power series video for you guys already, so you guys can go check that out. But anyway, this is what we have. And of course, this right here is just a matter of entering the x to the third power here and here. That's how we can get the power series, right? So we see that this is ln of 1 plus x cubed. Is this equal to the series as n goes from 0 to infinity, negative 1 to the n over n plus 1. And we have the x cubed inside, and this is to the n plus 1 power like this. Right? So to save some space, I will just work this out. This right here is just pretty much going to be x to the 3n plus 3. Yeah? Because you distribute the power and 3 times x and 3 times that. So that's what we have. And then what we can do is just integrate both sides. Integrate both sides. Like this. Well, integrate both sides. What we do is well, let's put on C plus first. Not plus C, C plus. It's much better this way. And then you have the series n goes from 0 to infinity, and then we have negative 1 to the n over n plus 1, all that. But we haven't integrated this yet. Come here, add 1 to the power, namely we get 3n plus 4, and you have to divide that right here, 3n plus 4. So I will have to multiply this by 3n plus 4 on the bottom as well. And then this is going to be x to the 3n plus 4 power. Done. So I don't know if you guys like the usual integration more or the integration with power series. Leave a comment down below, let me know. Okay, so that's number 34. Now, number 35. This is let me see. I should erase the board. I don't know how much space it will take, but I will just erase the board. It seriously takes me a lot of time to erase the board, so it's not like it takes me a lot of time to do the question. All right, and takes me and it takes my. I'll just do the question. No more talking. Number 35. What we want to do is consider the region, right? So you have this. I will tell you we have 1 over x. So this is 1 over x. Y is equal to 1 over x. And we care about 1 over x, and then also y is equal to 0, and from 1 to 4. So this is 1. Let's say this is 1. Doesn't look like 1 actually, but whatever. And let's say this is 4. 1 over 4. So let's say this is the region that we have, and we want to find the centroid, right? So this is the region. Find the centroid. Few things that we need, 3 things actually. Of course A, and then remember the formula for x bar and y bar. So let's do the A first. A is the area under the curve. So this right here is not so bad at all. From 1 to 4, 1 over x dx. Let's do this on our head. You get natural log of x, and then you're putting 4, that's natural log of 4, and then putting 1, which is the 1, which is 0. So all in all is natural log of 4, yeah? Now, x bar, you do 1 over a. I'll remind you guys the formula, and you integrate from a to b, whatever the x value, in this case will be 1 to 4, and then you do x times f of x. So perhaps I'll actually write down the formula for you guys, as I said. Integral from a to b, and then you have x times f of x, like this. Let's work this out first. So in this case, we get 1 over a, which is ln 4, and you should always do the a first. And then integrating from 1 to 4, and this is x, it's just x. But f of x is our function here, which is 1 over x dx. And now let's do this in our head again. This right here cancels out, huh? It's just 1. Actually, I still do 1 over ln 4. Integrating from 1 to 4. It's just 1. Let's do this. This is 1. And then you have... Okay. You just do 4 minus 1. That's 3, okay? But okay, let's do this way. Integral from 1 to 4, and then you have 1 dx. All right, so you cancel this out, which you get 1. And you integrate 1, you get x. Putting 4, putting 1, you subtract, you just get 3. So all in all, this right here will give you 3, right? So just work that out. So all in all, you get 3 over ln 4. So that's x bar. Now, y bar. Man, if you ever want to open a bar, you want to name it x bar or y bar, let me know. Anyway, 1 over a. Remember the formula first, right? A to b again. But for this one, you have to remember the inside is actually 1 over 2. And you actually have to square the function like this. Why? I have a different video. It's about being the average weight, the weighted average of the centroid with the area and all that stuff. So anyway, I'll do this right here. 1 over a is just 1 over ln 4. That's good. Wrong color though. 1 over a, 1 over ln 4. And then this right here is the integral from 0 to, from 1 to 4. 1/2 is just 1/2, but we are going to square the function, which is 1 over x squared, like this. So we have this, and then the dx, okay? Now, this is 1 over, I will put a 2 in the front, and then also the ln 4, and then I will just follow my work. This is the integral from 1 to 4. This is 1 over x squared dx, like this, right? And then, let's see, this is 1 over 2 ln 4 times, integrating this, we get the following. We get negative 1 over x, okay? And then you are going to plug in 1 to 4, like so. Plugging 1 and plugging 4, and then we'll get negative 1 over 4 minus negative 1 over 1. So this is negative 1 over 4 plus 1. So all in all, we get 3 over 4. Yeah, okay? So 3 times that is just 3. So we have 3, and this is 3 over 4. 4 times 2 is 8, and then ln 4. So it's 3 over 8 ln 4, like that. Y bar. So in the end, you can answer the question as x bar, y bar is equal to 3 over ln 4, comma 3 over 8 ln 4. And let me just double check to see if I make any mistake. Well, not, hopefully not. So hopefully that's the situation. And for this one, some of the questions I didn't write down the answer for most of the questions because, yeah, I want to do it on the spot. I only wrote down the questions. I knew that I would have to use a calculator and then, yeah, just to save time. That's stuff. Okay, number 36. Finally, well, it's not finally, another integration. This is almost like stand, but it's not. Okay, integral of tangent to the third power x dx. Now, let's integrate this guy. Not so bad. What I can do is split them and do the following. I'm going to split them as this. Tangent x times tangent square x dx, yeah? And we know that this right here has a nice identity for that, namely secant square x minus 1, isn't it? And then, of course, we can distribute and all that, and that's very nice. When I distribute, let me actually break the integral down as well. First one, tangent x times secant square x. That's the first one. I will close that. And then for the second one, I will have this times that. That's a minus integral tangent x, or stan x if you would like. Anyway, this right here, we can do u sub. Let u equal to tangent x and try it. All right, you should be able to do it, but we'll just do it in our head. We get this right here, which is u, and then that's the du, so you just get 1 over 2 u squared. So that's going to be 1 over 2 tangent square x, like this. This right here is a standard integral you should know is ln absolute value of secant x, and you are done. Like this. Cool, huh? Next one, I'm going to fit in here as well. I'll see number 37. We're going to find a power series expansion for the following function. Namely, we want x to the 5 over 4 plus x squared, like this, right? So now, let's see if we can do it real quick. Whenever you have this right here, we have to utilize our best friend. We need to have the 1 on the top. This is not, so I'll put the x to the 5 right here, right? So this is the same as this times 1, yeah? And then I need to have a 1 right here. This is not, so it's okay. I will have to just factor out the 4, then it's okay, yeah? All right, now, 4, you factored it out already. So this right here will be a 1. This is a plus, but I want to have a minus so I can use my best friend. So it becomes minus. How's that? Sure, right? Originally, this was x squared, but we factored it out the 4, so we will have to put this down over 4. So that will be the algebraic work that we will have to do. Again, if you multiply this out, you actually get back to that. Now, this right here is x to the 5th power over 4. We can use our best friend, which is just the sum as n goes from 0 to infinity, and you enter this into the best friend's x right here. Not the best friend's x, okay? Just yeah, not okay. Anyway, this right here is just the best friend's form, and you just do that, and then to the nth power, right? So just like this. However, though, you also have to give the radius and also the interval convergence. So be sure when you put this down right here, you also have to indicate that the absolute value of negative x squared over 4, it has to be less than 1 for the radius and interval convergence later on. Perhaps we can focus on this one first. Okay, here I'll just do everything. We will just finish this right here, okay? Okay, first of all, this right here we have a negative 1, yeah, to the nth power. So let's break it down like this. And then we have 4 to the nth power. So I'll put down 4 to the nth power. But we have a 4 in the front right here. multiply this in, so we have to add a 1. 4 to the first times 4 to the n, so we have this. Okay? And then we have x to the 2 and then to the n, so we have x to the 2n. So x to the 2n. However, we have x to the 5 in the front, so I will just have to add a 5. Guess what? We're done with the form. Now, finish this up. Absolute value of negative doesn't matter, and we can just look at this as absolute value of x squared, absolute value of x, and then put a square on the outside. Over 4, it's the same as multiply the form both sides, so we have this. Square root both sides. This is doable because absolute value of x is always positive. Take the square root of both sides. Absolute value of x is less than 2. So this means r is equal to 2, and I is equal to, because we are at 0, so the center is at 0, so we go from 0 to the left 2 units to the right 2 units, so you have negative 2, comma 2. And notice how we just did the algebra with best friend. So the interval of convergence still, you do not include the endpoints because it's just algebra. So this is it. Only double check or triple check the endpoints of the improper of convergence to see if they converge there when you are doing some calculus like differentiation or integration, right? So this right here is question number 37. All right. I think this is way more productive, like if I can finish at least as 3 or 4 questions on a board and then erase, rather than I do one question and then erase. That means I will have to erase like 90 something times, right? And truth to be told, I seriously did prepare this a lot, but I have no idea why I really missed question number 21. Just don't remember to give a question number 21. I guess I'm the math teacher who can account. How can I make this cleaner? Let's see. Good enough, maybe. If you would like to answer, just comment down below, let me know. Okay, number 38. This right here is an interesting one. We are going to find the area of a polar curve. I will give you guys a picture. So I'll make it slightly bigger so we can all see it nicer. We can all see it nicely. So you have a circle right here. And this is meant to be a circle, right? So you have this. And this equation is r equals cosine theta minus sine theta, okay? And then you have another circle. This is the big one. And in fact, it's like this. It's actually the circle with the radius equal to 1, and the center is at 0. So again, both of them are circles, right? Now, we want to find the area right here. We want to find the area right here. So, of course, you can just do some subtraction in this case. You want to find the area of the small one, inside of the small one, but outside of the big one. That's pretty much the idea, right? So, I'll just break it down right here for you guys. This right here is equal to this area here. I will just put it down like this. It's equal to this area here, right? And then minus the area of the big one, but it's just part of it right here. So you have the extra part left, right? And this right here, you don't even need calculus. This is just pi over 4, I know, so that's good. That's very good. But we will set the integrals to do this. So now here we go. Well, as a reminder, for the area of the polar curve, you need to know theta 1, theta 2, and the inside is 1/2 times r as a function of theta. So you have to know r of x and r of theta, sorry, and then you have to square that, and you are in the theta world, right? So that's the formula. The hardest part is to figure out theta 1, theta 2. Sometimes they are tricky, just like this one that we are going to see. Here we go. So for this one, notice how if you let theta equal to 0, we're looking at this one. Cosine of 0 is 1, sine of 0 is 0. So this is when theta is equal to 0 for this point. And then it's going to travel to here at the origin, right? At the origin. Remember, when this is at the origin, what you will have to do is you will have to let r is equal to 0. And let me just tell you, you can go check this out. It actually hits the origin first when theta is equal to pi over 4, when it hits the origin right here, okay? And then you are going to travel to here, and this is the theta 1 that you care because you want to go from here to here. This is the theta 1 that you care. This right here, notice is how on the y-axis, even though it seems that, hey, I'm looking down, so it should be like 3 pi over 2, but it's not. This right here, if you want to talk about the first time that it covers it, you put down pi over 2. 3 pi over 2 technically works, but you actually have to go twice. This right here is actually 0, pi over 4, and then pi over 2. And then you go back to here. This right here is the theta 2 that you use, which is pi. Now, let me show you why. Because when theta is equal to pi over 2, you put it here and here. Cosine of pi over 2 is 0. Negative sine pi over 2 is negative 1. So when the angle is pi over 2, put it here. You're looking at the pi over 2 direction, but the r is negative 1. So you have to travel backwards. So you end up right here. So that's why this right here is pi over 2. Similarly, this right here is pi instead of like 0 or 2 pi. It's because, well, if you put in pi in here and here, cosine of pi is negative 1, minus sine of pi is 0. So when theta is pi, r is negative 1. That means you are originally looking at that direction, the pi direction, and then you go backwards 1 unit for that. Right? So if you want to talk about the first time that the curve goes from here to here, you will have to use pi over 2 to pi like that, right? But the truth is, if you continue, this right here, it's going to give you 5 pi over 4, and then 3 pi over 2, and then 2 pi. So if you accidentally, well actually not accidentally, but if you use 3 pi over 2 to 2 pi, that's actually okay, that's like fine, whatever. But anyway, so that's the deal for that. Anyway, this right here, you can just go ahead and integrate this from pi over 2 to pi. And then you can just integrate this 1/2. And you can enter this inside, which is cosine theta minus sine theta, like this, and you square that d theta. Okay? And again, be sure you understand what I'm saying earlier right here, because sometimes you have to really pay attention to if the origin matters. Because, for example, if you have the 1 plus 2 cosine theta, you get like a loop like this. You really have to know when do you start and all that, and then we will do that again. We will have a similar question like that later on. And here's a hint for you guys. When you are on the x-axis, the angle is either 0 or pi or 2 pi, right? When you are on the y-axis, the angle is either pi over 2 or 3 pi over 2 and all that. Sometimes if you go backwards, that's why pi over 2 is down here. It's just how it is. But for this one, r is always equal to 1, right? So if you want to be fancy, what you can do is, because r is equal to 1, this right here is angle 0, and then pi over 2, go up. You don't hit the origin at all. And then pi, and then 3 pi over 2. So, yeah, but just to keep things simple, this right here, the area is just pi over 4, because the whole thing is pi divided by 4, that's it. So just minus pi over 4. Anyway, use your calculator. This right here, just go ahead and do it on the calculator, because usually when you do this, right? Yeah, just do it on the calculator, 1/2. Okay? Because usually I like to just ask for the setup for many of these kind of questions, and I will indicate when should you use calculator, when should you do the things by hand. All right, so that's it. 39, we are going to see if the series as n goes from 1 to infinity, sine square 1 over n, converge or diverges. It seems that we should use some kind of comparison test, huh? Okay, so let's go ahead and put down what we know. We know that the sum as n goes from 1 to infinity, 1 over n. It seems that we use 1 over n because we have the 1 over n that we can see. We know this right here converges, right? But let me hold on what I said. And because we're using sine, cosine, all that stuff, so maybe it's a good idea to do a limit comparison test when we have sine, cosine. It's not easy to use inequality to do with sine, cosine. So here is the check. I'm going to take the limit as n goes to infinity, put down the one that we are trying to do, and put down the one we're trying to do on the top, and put down the one that we know on the bottom, which is 1 over n, like this. Now, here is the trouble. Notice sine square n means sine of 1 over n times sine of 1 over n, isn't it? Over 1 over n, we just have one of them. I'm not going to use this as the thing that I know, because to do the limit right here, you end up with 0. If you continue with the limit right here, you end up with 0. And remember, for the limit comparison test, 0 or infinity, you cannot draw any conclusion. You have to be really careful with 0 and infinity. That's not good in this case then, but it's okay, because we can use the limit if you choose this right here as n 1 over n squared. This right here we go. P is 2, which is greater than 1, therefore it converges. So I'm actually going to use 1 over n squared, and that means I can actually do this. We have 2 of them, so it pairs up really nicely. Now, n goes to infinity, so I will let this happen. Theta equals 1 over n. So notice, if n goes to infinity, theta will go to 0. And you see, this right here, I'm just doing algebra. You will see this is just sine of theta times sine of theta over theta times theta, like this, right? And by the limit laws, we can say the limit of a product is the same as the product of limits. So I can do this. I can just take the limits separately. And we know this right here will give me 1, because by the limit, as theta goes to 0, sine theta over theta is equal to 1. Likewise, this right here will also give us 1. So all in all, this right here was just approaching 1. Now, this is good because 1 is greater than 0. And the deal is that we can come back here and draw a conclusion and say this right here also converges, because this right here we use the convergence, so also converges. Also converges, and the thing that we did was limit comparison test. So that's all we have to do, and that's it for that, right? I don't know why, but for some reason, I feel like eating Panda Express right now. But like, no, I'm not going to, because I have a lot of questions, a lot more questions to do. All right, number 40. Seriously, this is like running a marathon, and I do have a marathon medal with me today. All right. Integrating inverse sine x. So by now you guys should be really familiar with these kind of things. So I will just go ahead and do it for you guys. Go ahead and use integration by parts, differentiating inverse sine x and integrating 1. Differentiating inverse sine x, we get 1 over square root of 1 minus x squared, and integrating 1, we get just x. So this right here, the first thing is this times that will give us the first part of the answer. And then this right here is still going to be an integral. So you see this is minus integral x over square root of 1 minus x squared dx, like so. Okay. Now for this part you can do this by substitution. So let's go ahead and do that real quick. Let u equal to 1 minus x squared, and you see du is equal to negative 2x dx. dx is equal to du over negative 2x. Take this integral to the u world, we will see that's the same as integrating x over square root, and this inside is the u. And then the dx is that, which is du over negative 2x. And nicely enough, the x cancel each other out. Now, we have 1 over negative 2, so negative 1 over 2, and then the integral. This right here is the same as saying u to the negative 1/2 power, and then you go ahead and add 1, which is 2 over 1, right? No, I'm one step ahead of myself. You add this, which is 1/2, and then you divide it by the new power. So let me just make this in black so you can see better. Divide the new power, so multiply by 2 over 1, they cancel. So in the end, we see this is negative, and this is u to the 1/2 power, namely square root of u, and u is that, which is 1 minus x squared, like this. So now, I'll come back there and then tell you guys the answer. We have x sine inverse, and originally it had a minus. However, I'm going to put this right here for the answer for that. Minus times a minus, it's a positive, and we have the square root of that, 1 minus x squared, and we are done. Plus c. That's it, right? This right here is a killer integral. I remember this one when I was preparing it. So we have a killer trick substitution. So I am going to erase this part just to make sure I have more space. I should be able, let me just erase this. Alright, number 41 right here. For you guys, integrating square root of x squared minus 9 over x cubed dx. Trick substitution. Here is 9. Look at 9 as 3 squared, and you have x squared minus 3 squared. The choice is secant. Yes. So you see x is equal to 3 secant theta. Why 3? Because again, you have to match the 3 squared, the 3. Alright, dx, really important, don't forget about that. This is 3 secant theta, tangent theta, d theta, like this. Okay? Throwing everything, we see that when we go to a theta world, this is the square root. We have 3 secant theta, and you square that, and you minus 9 over this right here is 3 secant theta, and you raise that to a third power, and you have this, which is 3 secant theta, tangent theta, d theta, like that. Okay? My God. Okay. Now, perhaps let's do a few things in your head, otherwise this is kind of like a crazy. Okay. Notice that we have the 3 squared, which is 9. We can factor the 9. Square root of 9 is 3, so we have the 3 on top. Right? And then it will end up with secant squared minus 1, which is tangent squared in the square root. So we end up with just tangent to the first power, theta. Don't worry about the absolute value. This is enough, right? So again, you can simplify that, you get that. On the bottom here, this is, of course, 27 secant third power theta, and then we have multiply 3 secant theta, tangent theta, d theta. Cancel, this is now 2, and this and that cancel, but you have the 3 left, right? So we see that this is going to be 1/3. I'll put that all the way in the front. And then integrating tangent square theta over secant square theta d theta, like this. Well, this is 1/3 and integral. Tangent square, you would like, of course, you can look at this as sine square theta over cosine square theta. Well, for the secant square theta on the bottom, it's the same as cosine square of theta on the top. So in fact, they cancel each other out, d theta. So this and that cancel each other out, okay? So now we have 1/3 right here, integrating. All right, this is why I chose this equation, because you have to know how to integrate the sine square theta. You have to use the power reduction formula, which is this. Power reduction, you do 1/2 times 1 minus cosine of 2 theta, like this. And then you have the d theta, all right? Yes, and now we can finally integrate, kind of. Yeah, let's see, should I have in the spare? Let's just do it. 1/2 times 1/3 is 1/6, so this part, I'll just put on 1/6. And so this times that, that's 1/6. Now, integrating, so I'll put on parentheses for the result of the integration. Integrating 1 in the theta world, we get theta, and then minus, let's maintain a minus. Integrating cosine, we get positive sine. So this right here stays the same. The input is just 2 times theta, that's good. But we have to do the loop chain, the reverse chain loop. The derivative of 2x, the derivative of 2 theta is 2. But you're doing the antiderivative, so you have to divide it by the 1/2. You have to multiply by the 1/2 divided by 2. So that's it. That's the idea, right? So we are kind of done with the integration. We are done with the integration. Now we just have to go back to the x world. To do that, sine of 2 theta is actually the same as 2 sine theta cosine theta. And notice this and that cancel each other out. Okay? So now I will just write this down for you guys, and then we'll go back to the theta world, x world. 1/6 times theta, and then minus 1/6 times this, which is 1/6 sine theta cosine theta, like so. Go back to the original choice for that thing, and then we'll see. I will put it down right here. Okay, so we have x is equal to 3 secant theta. That means secant theta equals x over 3, because we can divide the 3 on both sides, of course. And then based on this, it's good. We can draw a right triangle, put the right angle here, put the angle theta here, and put the right angle here. And secant is adjacent over hypotenuse. No, I lied. It's hypotenuse over adjacent. Okay, good. All right. Yes, hypotenuse over adjacent. All right. And then for this right here, go ahead and do the square root. This square minus that square, x squared minus 9. Well, it's 9, but like I'll need to show you guys 3 squared first. Right? Just that. With this triangle, we can actually go back to the x world. However, though, this right here, the first thing is just theta. We don't have just theta yet. You have to look at this. No, just put this down in red, in red, yeah. Notice secant theta is equal to this. That means theta equals inverse secant of x over 3. Right? So just take the inverse on both sides. So I'll put this down right there. We have 1/6 inverse secant of x over 3, like that. And then minus 1/6 times sine theta is this over that, huh? So I will just have square root of x squared minus 9 over x. And then cosine is this over that, multiplied by 3 over x, like this. Okay, finally, I'll just clean up some little fractions. Yeah, this is 1 over 6 inverse secant of x over 3. And then this right now can cancel. This is 1, this is 2. So we have minus 1 over 2. Perhaps I'll write it down this. This right here is a square root x squared minus 9 over 2. Don't forget the 2, because that's where I messed up when I was doing the integration, when I was doing the 100 integrations. Yeah. Anyway, 2. And x times x is x squared. So I believe that's it. I hope I didn't make any mistakes. And then maybe later on, sometimes I will actually come with answer key if you guys would like me to. If enough people are watching, and then if you guys would like me to come with answer key, then yeah. Okay, number 42. God, this is only number 42 and a half, 3 hours already. God. Thankfully, I have 10 true-false questions. Because I want to go home, that's why I have the 10 true-false questions. Alright, number 42. So, I'll just read this for you guys. We want to find the equation of the line tangent to the parametric curve at t is equal to 2. So, this is what we need to know. Alright, so equation of tangent line. So we need two things. The first thing is, of course, the derivative. And by the way, let's get the point first. We have the x and y, yeah? X is t squared minus 6t, and then y is equal to square root of t plus 7. Yes, yeah. So the point when t is equal to 2. Right? So this will give us the point. The point right here will be, when you put 2 in here, this is 2 squared, which is 4, minus 12 is going to be negative 8. So x is going to be negative 8, I believe, I hope. Negative 2, no, negative 12, 4, yeah. Anyway, right here, y will be, put 2 in here, is 9 square root of that, so it's, so we have the point, negative 8, comma 3. Now, for the slope, well, dy dx is, I'll just do this in red, dy dt divided by dx dt. All right, let's see. dy dt, you differentiate this guy, which is going to be 1 over 2 square root, right? The derivative of square root of something is 1 over 2 square root of something, t plus 1. And does the chain rule matter in this case? Chain rule will be just 1. So if you forget, it's okay, lucky you. Oh, this will be a 7. All right, so that's what we have. Over dx dt, so we have 2t minus 6, am I right? Yes, hopefully. Okay, now we want when t is equal to 2. So let's see, right here I will be getting 3, so on the top we have 1 over 6, am I right? 3, that's 6, and then 2, that will give us 4 minus 6, negative 2. Yeah, so all is negative 1 over 12. Oh my god, negative 1 over 12. Lucky number, huh? Didn't expect that. But, you know, don't go too crazy in the comment section. So, okay, guys, this is just an innocent slope for that. All right, so now y minus y1 equals m times x minus x1, yeah? So this is the x1, y1, if you would like. That's the point that we'll use, x1, y1. And that's the slope, of course. This is the m. So go ahead and do everything now. Y minus y1, which is 3. And this is negative 1 over 12. X is x, minus x1 is negative 8. So you have all that stuff. And shall we put this in the slope intercept form? No. We're in calc already. If you leave like this, should be good enough. I didn't say it. It's okay, you guys. Okay, so, man, that takes some time. I should be doing like a 50 true false question. That would be much easier. By the way, if you guys are taking linear algebra in the future, don't forget to check out Dr. Pam's channel because he has a lot of linear algebra videos on his channel, right? And that's his favorite class to teach as well. Right? And one fun fact is that he and I we knew each other back in 2006 when we were in school. So yeah, and I'll tell you guys a few more things if you guys will. Anyway, so I'm just going to do the math. Number 43. This one is a really crazy one, right? We're going to prove the volume of a cone, right? Is 1/3 pi r squared h, like that, right? So prove the volume of a cone is equal to 1/3 pi r squared h. Do not just put this down. I have this down on the paper for you already. You have to show me how you derive it. We can use calculus to do this. This is how. Well, this is how a cone looks like. So you have the base and it's a circle. I'm trying to draw a 3D picture like this, right? And of course the cone will look like this. So what you can do is, you can again consider your base as your x-axis. Again, set up your reference frame. See, in real life, if you want to solve any equations right here, you actually have to start with your x and y axis before you can do a thing. Oops, that's so bad. I shouldn't be talking while I do math. I mean, I shouldn't be talking while I draw. Here we go. Right? So that's the idea. And what you can do is, of course, you can come up with the equation of the line right here, and then do a rotation about the y-axis, so you can get this picture. And then you can just go ahead and find the volume of the solid of revolution. And because this happens to be a cone, if you get the answer for that, you get the volume of the cone, of course. So now, here is the deal. The bottom base right here, the radius is just r. And we also know that from here to here, the height of the cone is h. So we will have to come up with some coordinates so we can write the equation of the line. This right here will be r, 0. This right here will be 0, h. So to the line equation again. So this one right here, the slope m is equal to this minus that, h, the y2 minus 1, all the good stuff. This 0 minus that, so 0 minus r. So we end up with negative h over r, like this. And then y is equal to, let's use mx plus b, yeah? So the slope is negative h over r times x, and the b is h, the y-intercept, right? The y-intercept plus h. So the equation right here is y equals negative h over rx plus h, like that. So if you want to write a whole proof, you can say something like, consider the equation y is equal to negative r over, so negative h over r, I wrote it down right, but I said it wrong, plus h, right? Consider this equation. And yeah. Well, let's do it like this. You can just say rotate. You can just say rotate. This is how you spell rotate, yeah? So you can just say rotate this line about the y-axis, right? You just rotate this, and then I think the picture will be pretty clear. And of course, r and h should be positive. You are doing geometry and stuff, so that should be a pretty clear picture. Then, in that case, you'll see that the volume of the revolution is the following. We can do it by the disk method, and the disk is just like my marathon medal. It's like this. You have a thickness right here, right, for the volume. Okay, so now let's see. Come back here. I will just do this for you guys. I will just put on the h right here down below, slightly lower. All right, so draw this. This time you actually use a disk not like the part of the cone, right? So this is the disk, so it's meant to be straight. For the volume, use disk. And the reason that you do surface with the part of the cone is because you have to take the surface area to make sure you can wrap it around all that stuff. I have other videos for that if you want to check it out. Anyway, this right here, the height of this is dy. And from here to here is x. So the volume of a cylinder is pi r square thickness, right? Pi r square h. But this time it's the thickness like this. So we just have to integrate, right? Pi is always pi, of course. And the r is x in our situation. You square that, and you have the dy right here. The idea is that this part is the volume of the small disk. You are going to add them up. We'll add them up from 0 to h. Add up all such disk. Then you can get the whole volume for that. Now, this right here is x. It's not allowed in the y world. So, man, we have to solve this equation. Let's see. We can minus h on both sides, right? So that means, let's see, we can minus h on both sides, so we get y minus h, yeah, on both sides. But I will have to multiply the reciprocal of this on both sides. So that will be r over h, and that's negative. So x will be like that. So I will have to enter this right here. So I'll just go ahead and do that. This is integral from 0 to h. Perhaps put a pi on the outside. And then this right here is parentheses with negative r over h now. And then we have the y minus h like this, and you square, and you have the dy like that. Okay? Then what you can do is, of course, you can do the following. Pi is still on the outside, just chilling on the outside, that's good. Negative r squared is just past the r squared now, and that's a constant multiple. I can put it down on the outside. Similarly, h squared, I can also take it out on the outside. And then look at the integral going from 0 to h, and here we have y minus h squared dy. You can expand this and then integrate all the terms, but I will prefer to do a substitution. It's easier to integrate this way. That u equal to y minus h. du is the same as dy. Very nice. You will see we can finish this in the u world much better. This is pi times r squared over h squared. Notice how earlier this is y equals 0 to y equals h, yeah? But u is going to be, okay, y minus h. When y is 0, put it here, we get negative h. And then you put h in here, h minus h is 0. You are doing the shiftment. And then here you get u squared, dy and du is the same, so you have this. It's much better this way. Now, here you get, I'll just put on pi r squared on the top like this, over h squared, like that. Integrating this, of course, you just add 1 and all that stuff, right? So you just add 1, which is 3, and divide it by that. So I will have the 1/3 right here, okay? And we're looking at u to the third power, but I will have to enter this from 0, I will have to enter this from negative h to 0, like this. So, let's see, when we put in 0, just put on pi r squared over 3h squared. When you put in 0, of course, this is just 0 to the third power. And then minus, putting negative h right here, third power. This right here is 0. This right here is going to be positive h to the third power. Can we cancel? Yes, we can. Cancel, cancel. You get h squared like that. That's very good. So finally, 1/3 all the way in the front. Pi is pi, r is square, and then h, no, not h squared, h, because this is h to a third power. This is h squared, so you just have h, right? So cancel that with h. Done. So this is the proof for the volume of a cone, like that. Okay. Right now it's 314, which is pi time number 44. Let's see. So here we have integrating e to the x cube like this. Don't worry, yes, we are using power series. So with power series. So of course you have to remember e to the x is equal to what, right? So here we go. E to the x equals the series as n goes from 0 to infinity, and we have 1 over n factorial x to the nth power like that. Now this right here is not so bad because we just need to have e to the x to the third power. Therefore, it's the sum as n goes from 0 to infinity, 1 over n factorial, and we just have to do x to the third power raised to the nth power like that. And then of course we can just go ahead, integrate both sides like this. So now this right here is going to be c plus. Let's put on c plus. And then we have the series as n goes from 0 to infinity. How do we integrate this? Well, worked out the exponent. This right here is the same as saying 3n, right? And then, I'll actually write it down like this so to make it more clear. This is the same as saying x plus 3n. To integrate this, we just add 1 and divide it by the new power. So I'll just put down 3n plus 1 like that. So we're done. This is going to be 1 over 3n plus 1, and then we have the n factorial and x to the 3n plus 1 like that. Yes. So don't forget you do 3 times n first and then you add 1 over it. So it's like this. And we're done. Yeah. And by the way, try this on your own. Okay? The radius of convergence is infinity. You can do the formula, but another way to look at it is you're integrating into the x and all that stuff. But r is infinity and I is negative infinity to positive infinity. So yeah, like that. And the truth is, when you have a factorial right here, because this right here is at most exponential, when you have a factorial here, it will be infinity. That's pretty much the correct way to do it. So if you would like, right? So how large should n be to guarantee that the trapezoidal rule will be accurate within 0.0005? So here we go, number 45. Consider the integral going from 1 to 4 e to the negative x squared dx. Very similar, but totally different. Okay. So I will say 1n so that Tn is accurate within 0.0005, right? So that's pretty much the direction of the question. Now, well, this is about like the maximum error that we can possibly make, right? So we have to talk about the error bound formula. And let me just remind you guys, then put it down right here, then I guess, yeah. Error bound formula for the trapezoidal rule, take the absolute value because sometimes you don't care about it's over or underestimating. This right here, it says it's going to be less than or equal to k times b minus a to the third power over, for the trapezoidal rule is 12n squared, like this. And for the k, that's the hardest part. You have to do the derivative for that. You have to do 2 derivatives. That's the maximum value for the second derivative. Sorry, the maximum value of the absolute value of the second derivative. So let's go ahead and do this right here. I'll just put it on right here. Okay, so I will put on y as my function here, e to the negative x squared. First derivative, well, e to the negative x squared stays, but use the chain rule. Multiply by the derivative right here. So multiply by negative 2x, like that, right? So perhaps I should have write it down like this, negative 2x e to the negative x squared. But we need a second derivative, so y double prime. So use the product rule. Multiply the first function with the derivative of the second. So I'll multiply by this, which is e to the negative x squared, and use the chain rule again. And we get negative 2x, and then we add the second function, which is this, which is e to the negative x squared, and we multiply by the derivative of the first, which is negative 2, right? So that's the second derivative for that. And now we care about the absolute value of the second derivative. So be sure on your graphing calculator, you have the absolute value. And you have the absolute value right here. And you just have to do this on the graphing calculator. That's all I ask my students to do. So I'll just show you guys. Graph this on your graphing calculator. Your picture is going to look like this. Right? So your picture is going to look like this. And this is going to be like 1 right here. And then you're looking at 1 to 4. So of course you can see that we do have a maximum here. And this right here is exactly what you want to use. And is 0.82. This right here is 0.8925. And that's the k value that I want to use. So that's the graph of the second derivative, right? So just graph that. And you have the x value. The x value here is 1.22 something. But again, don't let this confuse you. You're looking at the y value. So that's the one that you are going to use. So use your graphing calculator, the maximum function, and get that. All right? So now, with this being done, the rest is just a matter of doing the computation. You want this to be within 0.005. So you set this to be 0.0005. Like this. Yeah, how many zeros? I forgot how many I said. And your goal is to solve for n, of course. So now, here we go. K is this. I'll put that down, which is 0.8925. And the B is this. A is that. So we have 4 minus 1 to the third power, right? And we have this over 12. But I want to solve for n. So let me multiply the n squared on both sides. Let me divide this on both sides. So I will multiply this by 0.0005. And the inequality shall stay. This is n squared right here. So bring this here. I brought this here. Of course, you can take the square root on this. And yeah, that's pretty much all you have to do. So you will see n has to be greater than or equal to. And the number that I got is 63.3, like this. So I will tell you n should be, you should always round up at least 64. You should always round up to the nearest whole number. And if you're talking about the Simpson's rule, you have to make sure you round to the nearest positive even number, right? But this right here, you round up regardless, just to guarantee something. So that's why 64 instead. Yeah. Okay. All right, now we'll do a limit question. It's not so bad. Number 46 right here. Here we have to evaluate the limit. I'm using t, okay? T approaching 0 plus, and we have 1 over t minus 1 over e to the t minus 1, like that. Okay, if you plug in 0 plus into here and here, you will get infinity minus infinity. That's indeterminate. Do more work for that. So, combine fractions because of 2. Multiply e to the t minus 1, e to the t minus 1. And then for this one, multiply the top and bottom by t, like this. Then we see that this is the limit as t goes to 0 plus. And now on the bottom here, they have the same denominator. So it's t times e to the t minus 1, like this. On the top, this is just e to the t minus 1, and then minus t, and minus 1. This time that's minus 1 and minus t, like that. Now, once we have this combined it, we can do L'Hopital's rule. This is a 0 over 0 situation if you just give a quick check. Then you will just go ahead and do the derivative on the top and also on the bottom. So we see, again, this is the 0 over 0 situation. Use L'Hopital's rule. We see that this is going to give us the limit as t goes to 0 plus, and here we go, the derivative time. Derivative e to the t is e to the t. The derivative of that is 0 bye-bye, and then this is going to give me minus 1, right? Yeah. And then on the bottom, we will do the product rule, right? So t times this, so we get t first times the derivative of this right here, which is going to be e to the t. So t times the derivative of this, which is e to the t, plus the second function, which is the whole thing, e to the t minus 1 times the derivative of first, which is 1, like that. Okay, it seems pretty good, huh? But I believe we still get 0 over 0, do we? I think so. Because if you do that 0 and that's 0, that's no good. It's okay. We can do it again. dt, dt, right? So here we go. This right here is the limit as t goes to 0 plus. And again, 0 over 0, we use L'Hopital's rule. Differentiating the top, we just get e to the t this time. On the bottom, this right here, we use the product rule. E, this. Right? And then differentiate this, we get one more e to the t. Right? So be really careful. When you differentiate this, you end up with that part. Okay? Now, plugging 0, e to the 0 is what we have over, this is 0 e to the 0 times plus e to the 0, and then plus e to the 0. On the top is 1. On the bottom, this is 0, and 1 plus 1, which is 2. Okay? So I just want to show you guys all the details because this is actually one of the questions I gave out on the test to my students, and then some students just missed the computation here, or maybe just, somewhere. Yeah. So that's the whole thing. Okay, number 47. Another integration questions. X to the 5, e to the x to the third power dx, like that. How should we do it? Wolfram alpha. Yeah, perfect. But no, that's not good. You cannot use Wolfram alpha in your test. Integration by parts. So here we go. D and then I plus minus to get ready. This time, this is why I like to tell my students that I don't like to teach Liang-T, L-I-A-T, that method, because I like you guys to think about how to do things rather than memorize anything, if whenever possible, you know. So here's the deal. Which part should we integrate? This right here is e to the x to the third power already, right? Can we really integrate e to the x to the third power? No, we cannot. No, we cannot. Seriously, no. Don't do it by power series. No, don't do it. No. This right here is not doable, but we do have some help from here. Imagine if we happen to have x squared in the front, can we do it? Yes, right? Because we can do u sub, let u equal to this, and the derivative of x to the third power is 3x squared. As long as you have the function part x squared, then you can make it happen. Originally, we had x to the 5. I put x squared here already, so I just need x to the third power right here. That's the idea. Now, continue to differentiate this guy, we get 3x squared. Integrate this guy, well, we get 1/3 e to the x to a third power. Why? Because you can again do the substitution, you need to have that 1/3 because earlier we don't have the 3. You can multiply by 3 and divide it by 3. So you have the 1/3 like that. Right? So now, first part of the answer, here we go. We get 1/3 x cubed e to the x cubed. And then another integration. This is a minus. Integration. 3 and 1/3 cancel out. So we just have x squared. Hey, look, this is x squared. And then we have e to the x cubed again. That's very nice. So in fact, this is the same as from this part. So we know the answer. This right here is going to give us 1/3 x cubed e to the x cubed minus 1/3 just e to the x cubed like this. And then we are done. Like that. Right? Now, number 48, let me see if I can fit in here or not. Integrating 1 over square root of 1 minus x squared, and then this right here is to the third power. So be really careful to have the third power. However, when you have a radical and 1 plus whatever, give the trig substitution a try. Usually that works out really well. So I'm going to let x equal to sine theta. And this is 1 already, so sine theta will work nicely. And dx will be cosine theta, so I will just put it down right here. D theta. Now, this right here is the integral. We have 1 over square root, and this is 1 minus sine square theta. But we take this to the third power, like this. And then we have the dx, which is all that. So write down cosine theta d theta like this. Okay, let's do this in our head also. This right here is, actually I'll show you guys the work, but I will have to erase so I have more space. This right here is cosine square, yeah, theta. And then you raise that to the third power, which is cosine to the 6th power, multiply the power x, right? Theta. Yeah? But don't forget we still have the square root. So in all you get cosine to the third power theta only. Okay? But this and that cancel out. So you have 1 over cosine square theta. I will leave it right here for you guys actually. And 1 over cosine is what? Secant. And you have the square. So this is integrating secant square theta d theta, which is tangent theta. Go back to the x world by looking at this triangle. Well, it's not there yet. We got to draw it. All right, so draw a triangle. Angle here, theta here. X over 1. This is sine, so it's opposite of hypotenuse. And for this one is square root 1 minus 1 squared minus x squared, like this. Tangent is what? Opposite over adjacent. So we have all in all opposite x over adjacent, which is 1 minus x squared. And we are done. Okay, so have a look. Number 48. Can I fit in number 49? I can, but no, I don't want to. I think you guys will prefer me if I start a question over there, right? So, all right, 7, almost 7:20. Number 49. Okay, this is going to take me 7 hours, so God. All right, anyway, for what value of r will y equal to e to the r x satisfy y double prime, 3y double prime plus 2y prime minus 8y equals 0. So we are going to find r so that this will satisfy. And now this is how you can do it. This is the general form already. So all we have to do is differentiate this twice because we need to get to the second derivative. So this is e to the something, so y prime is equal to e to the rx, but use the chain rule, multiply by the derivative of that, which is just r. Do not minus 1. This is the exponential situation. And then y double prime is just same thing, but you have r squared instead. Like that, yeah? And now I was drawing this right there, so we are looking at this as 3r squared e to the rx, and then continue plus 2r for the first derivative, just r, and then e to the rx, and then minus 8 erx for the original. So that's pretty much how you make this work. Now, notice that everybody has e to the rx, so we can factor that out. So we will just do that, e to the rx, and then this is 3r squared plus 2r minus 8, that's equal to 0. But this right here, can this ever be 0? No. So this is never 0. The only way that we can make it happen is to make this equal to 0, right? And can we factor this? Sure, we can, right? So let's go ahead and factor that. I'll show you guys the tic-tac-toe method for doing that. So perhaps I'll do this right here. I do a tic-tac-toe method to factor this out. I need 3r times r, so to get 3r squared. And I need to get negative 4 and 2. Yeah, negative 4 and 2. Because this right here times this will give me positive 6r. And this right here times that is going to give me negative 4r. Altogether, that will make positive 2r. So it works wonders. So this means you read it across to get the answer. You get 3r minus 4 times r plus 2, make it equal to 0, and we can calc 2 already. So by looking at this, doing your head, you get positive 4 over 3, and you get r is equal to negative 2. These are the only two choices. We are going to find the power series for our new friend, Kosh, right? And again, if your name is Josh, I still have a few of the Ninja Milk left in my office, so you can come redeem it. And I said this in my 100 derivative video. So yeah, and I did give my I did give my students both Joshes in my calc 2 class this semester, right? So Josh, if you're watching this part, just leave a comment down below so that people will know. Anyway, so okay, caution, right? So let's see our. I'll just probably write it down right here. So right, number 50. Woohoo! Finally, number 50. All right, so I want to get cos x, right? So let's see. You have two ways to do it. The first way is you can play around with the power series for e to the x and e to the negative x, up to you. But perhaps I'll use the Taylor formula, right? So let's go ahead and do that. To use the Taylor formula, what you do is you need to write the n values down, and then the derivatives, and then you also have to do the Taylor formula, which is Fn, and the a that we want is at 0, and divided by the n factorial. Okay, so now continue. I think this is enough. 0, 1, 2, 3, 4, 5, maybe even 6. I don't know, 6 maybe, if you would like. Now, check this out. This right here, derivative, or the series derivative of cosine is cos is just cos. You don't do anything. Differentiating cos, you get positive sinh. So you get positive sinh x. And then you get cos. Yes, it's just cos and sinh, cos and sinh. And you don't even have plus, minus, all that stuff, like alternating and all that stuff. So yeah, it's just like that. All right, now putting 0 in here, cosine or cos of 0 is 1. Yes, just like cosine 2. Why? Because this is e to the x plus e to the negative x all over 2. So it's 1 plus 1 over 2 when you're putting a equal to 0. Anyway, you get 1, and then you divide it by the 0 factorial. Well, when you put in 0 into here, you get 0 actually. So 0 divided by anything is just 0. And then if you put in 0 into calc, again, you get 1 over 2 factorial. And then you get 0. And then you get 1 over 4 factorial. And then you get 0. And then 1 over 6 factorial. And all that. So that's pretty much the idea, right? And if you would like, I will actually put it down right here, cos x. What you should do is, because earlier I used n right here, you should not look for formula with this, and that, with the zeros inside. Don't do that. You should be looking for formula for this, that, the remaining term only. So instead of using n, because I don't want to cause the confusion with the n and the n I'm about to use, I'll be using k. K equal from 0 to infinity. Now I'm looking at this. 1, 2, 3, 4. Those are my new labelings, right? Technically, start with 0. 0, 1, 2, 3, okay? When k is 0, I will have just 1 over 0 factorial. When k is 1, it's 2 times 1, so, and then 2 times 2. So here is just going to be 2k. And then you do the factorial. And then you have the even powers. Remember, this right here tells you x to the second power, x to the fourth power. So this is the 2k power because I'm using k like that. So if you use this, this is totally okay. But if you would like, because people would like to be slightly more consistent, you can still write it as n goes from 0 to infinity, 1 over 2k, 1 over 2n, factorial that, x to the 2n power, like this, if you like. Why? Because this n, you just have to know it's a different n than this, that's all. And as a little bonus, I will tell you, right here, r is infinity and I is also negative infinity to positive infinity, right? It's very similar than cosine, so if you need to determine that, you can just do that. So anyway, just like that, right? Number 51, integrating ln x over square root of x. Yes, we have a lot of integrals to do. That's pretty much what calc is, yeah? So a lot of integrals. Now here we go. How do we integrate this? Try integration by parts. So here we go. So don't forget the plus minus. I will be differentiating ln x and I will be integrating 1 over square root of x. You see, differentiating ln x, we get 1 over x. And integrating 1 over square root of x, we get 2 square root of x. Why? Because if we differentiate square root of x, we get 1 over 2 square root of x, yeah? You didn't have the 2, just have the 2 right here. That's pretty much it. Or if you would like x to a negative 1 half power, up to you. Anyway, here we go. This right here, first part of your answer. So here we go. This is 2 square root of x times ln x, like so. And then this part is still an integral. So we have the minus. Let me just write it down a little bit lower so I can line up the things all together nicer. Minus integral, and this is 1 over x times 2 square root of x and then the dx, like this. Okay. Now, how can we simplify this a little bit? If you would like, you can just look at this as the 1/2 power again, right? This is the same as 1/2 power, so you can just look at this as the 1/2 power. 1/2 power, and this is the first power. So all in all, you are just looking at this right here as the integral of, let me put the 2 all the way in the front, and then we have the minus here. And this is just 1 over x to the 1/2 power. 1/2 minus 1 is negative 1/2. Bring that down. Stop. Dx. And again, you can just do this minus 2 integral. This is negative 1/2 that, and then just add 1 to it, which is positive 1/2, and divided by the new power, so it becomes 2/1. Yeah, dx like this. So all in all, we're done. This is 2 square root of x, ln x. And this is minus 4 and square root of x. Just like that. Yeah, so just see how you want to do it. So, 2 and then yeah, just do it whichever way that you just do it. Depends on how much work you want to show, and yeah, that's it, huh? Okay, number 52. I have a pretty fun limit for you guys. This right here, it's a limit as x goes to infinity. And here we have square root of x squared plus 5x plus 2, and then minus square root of x squared minus x plus 5, like that. If you put in infinity into all the x, you will end up with infinity minus infinity, which is indeterminate. That's no good, that's bad, that's dangerous, but it's okay. Whenever you have radicals, why don't we try to use the conjugate strategy? With that said, what we'll do is multiply the top and bottom by square root of x squared plus 5x plus 2. But in the middle, we add. And the other part, x squared minus x plus 5. And we'll do the same thing right here on the top as well. So square root of x squared plus 5x plus 2. And then we add, can we still see? Oh yeah, hopefully. X squared minus x plus 5. My bad, I'm sorry. Yeah, that's all that's, I forgot to budget the space enough. Anyway, budget enough space. X squared plus 5x plus 2, and then add this on the bottom. Better, huh? Hopefully. All right, anyway, here is the deal. This right here is the limit as x approaching infinity. And now, on the bottom, we are not going to multiply it out because the top was the one that we were trying to fix. So, well, actually the bottom we cannot do anything anyway. So leave it, x squared plus 5x plus 2 plus square root of x squared minus 2 minus x plus 5, like this. On the top though, this is a minus b times a plus b, so it's just a squared minus b squared, namely, just the inside. Namely, we just have the, let me just put this down, x squared plus 5x plus 2, and then we minus, right? So it becomes parentheses minus the inside, which is x squared minus x plus 5, like that. Good, huh? Now, let's see. Of course, we can do a few things. Notice how x squared and minus x squared cancel, and 5x minus negative x becomes 6x, and 2 minus 5 is negative 3, like that, yeah? So that's pretty much all we have. And notice how on the top is x to the first power right here. On the bottom, in fact, it's also x to the first power, if you just ignore this and that. And we can ignore that because x is approaching infinity. If you want to be slightly more formal, what you will have to do is divide everybody by x. Inside here, you divide this by x squared. But on the outside, it's the same as, x squared is the same. X squared, you take the square root, it's the same as x. So divide everybody by x squared inside. Divide everything by x on the outside. But if you would like, you can just circle this. It's a quick way to do it. And this right here, you just care about this. And you also care about that. Don't forget you have two of them, right? And notice how x is approaching infinity, right? It's passing infinity. So square root of x squared is just going to be past the x. So in fact, this right here is just x plus x. So on the bottom, you just care about 2x. So if you look at this now, it's 6x over 2x, which is 3. And you're done. Okay? Now, 53. Okay, given the sequence, we have this. We have 1/2 and negative 1/3 and 2 over 9, negative 4 over 27 and dot dot dot. Okay, does AN converge? Well, shall we come with a formula for AN first? We should, huh? It looks like we multiply by negative 2, multiply by 3. Does that work? In other words, from here to here, we multiply by negative 2 over 3. Does that work for this? Multiply by negative 2, multiply by 3. It does. Right? Multiply by negative 2 over 3. And does this work? Multiply by negative 2, but 2 and 2 cancel, so we have negative 1. So it does. Just because we cancel the fraction. So in fact, it's a geometric series, and not clean enough, the r is actually less than 1. So part A, we know AN equals A1, which is 1/2, times the common ratio, namely negative 2 over 3, to the n minus 1 power. And a note right here is that n start with 1, right? When we're doing sequence in this textbook, we're using n start with 1. So that's why it's this right here. Notice if the r is less than 1, the absolute value of r is less than 1, then AN will approaching 0. So I will just tell you guys, maybe down here, if you take the limit as n goes to infinity of AN, this right here will be 0. So I'll just say yes. AN converges, and we know that it converges to 0. That's very nice. Now, part B. Does the series of AN converge? N goes from 1 to infinity, and this is again n start with 1. So AN, in our case, is just that. We have the series as n goes from 1 to infinity. And we have all that, which is 1/2, negative 2/3, n minus 1. Right? Again, r is negative 2/3. Absolute value of that is less than 1. So this right here does converge. So we can say this right here is the first term. And the first term is when you putting the starting n value in here. Putting 1 in here, that's 0. So we have this to a 0's power is just 1, namely the 1/2 for the first one, which is the same as that. Right? See. So we have the first term is 1/2 divided by 1 minus the common ratio, which is negative 2 over 3. All right, so that's pretty much the idea. And now, let's see. This is 5 over 3. And then do the reciprocal, you get 3 over 10. Yeah, so just work out the fraction. That's pretty much it, all right? Man, this is really much. Wow, this is a lot. Can I go home by 10? I don't know. That was my goal, but I don't know anymore. Number 54. And for my Calc 2 students, either current Calc 2 students or my future Calc 2 students, seriously, give this video a like, all right? I'm doing this for you guys. So, yeah. All right, we are going to find a parametrization of a line segment, and you also have to give me an interval. So we need a parametrization of a line segment from 1, 2 to 5, 4, right? And I let my students use any way that they want, but of course, we all know about the easiest way. as I show you guys, if you like, you can come with the equation of a line y is equal to mx plus b. That's the easiest way, and then you just say x is equal to t, y is equal to whatever, right? But here's the better way. So take good notes if you don't know this already. So a parametrization of a line segment from x0, y0 to x1, y1. This is the starting, this is the end. That's why we say x0, y0. Okay? Parametrization of this is that x is equal to x0 times 1 minus t plus x1 times t. Why? Because, oh, by the way, this right here allows you to move from one point to the other within just 1 second. Just like Goku, Dragon Ball Z, if you know what I'm talking about. When he does this, he can go to anywhere within like split of a second, almost instantly, right? By the way, with this right here, you can go to anywhere within just 1 second. So this right here, it's good if t is in between of 0 and 1. So that's the time interval I was referring in the equation. Okay, when t is equal to 0, you see this is out. This is out. So you start with x0. When t is 1, this part is out, x1. So that's pretty much the idea. Y equals y0, same thing, 1 minus t plus y0 t. And again, you can just use this right here to do the parametrization of a line. If you want to be fancy, you can put a square. That works too, if you like. But how does it go? Let me know if you didn't notice any difference. Okay, so here we go. Answer, this is x0, y0, x1, y1. So once you know this, you know the answer. X equals x0, which is 1. And this right here takes care of the direction already, from any point to any point, right? And then you just multiply 1 minus t, and you add 5t. And then for the second one, y equals 2 multiplied by 1 minus t plus putting 4 in here, you get that. And that's pretty much it. And I think I'll just leave it like this instead of telling you guys to combine like terms, because we prefer to have this, I believe, right? It's easier to see, that. So I'll just leave it like that instead of combining terms. Okay, number 55. I feel much better after question number 50 in the sense that I feel that this is doable and we can make it. Together, you and I, we can make it. Right? It's just calculus 2 class. And then calculus 3 is waiting for you though. I know, yeah. Especially if you are like math major, engineering major, physics major, science major, maybe you have to take more math classes. There are a lot out there for you guys to learn, right? Okay, number 55. Right here. And this right here is improper integral going from 0 to infinity. Let me make the 0 bigger. Oh man, this is 1 over 1 plus e to the x dx. Oh, I know, this right here converges. You can do some comparison test for this, but we're trying to get the value of it, right? So trying to get the answer out of this. Well, how can we integrate 1 over 1 plus e to the x? We don't have a lot of things to work with. We don't have the e to the x on the top. Imagine if we have e to the x on the top, we can just do u sub, right? So, this is how we can make things happen. Let me show you. Well, wouldn't it be nice if we have e to the x on the top to help us out? And in fact, this question, we don't like it too much. Imagine if we have 1 plus e to the x on top, wouldn't that be so nice? Yes, because this is just 1. Very nice. But I cannot do that because that will change the whole thing. It's okay though. Let's go ahead and minus e to the x after that right away. So, as you can see, this right here is actually the same as integrating from 0 to infinity. Let me write this down again. This is 1 plus e to the x over 1 plus e to the x, and then minus e to the x over 1 plus e to the x dx. Why is this so much better? Because this right here is just equal to 1. Right? So let's go ahead and integrate that. Integrating 1 in the x world, this is just x. Done. Right? This is just x, and we are done. Just done for that. Okay? And then minus, we'll integrate this. Just do this separately. And you can do a u sub now because we have e to the x on the top. So for this one, we get natural log. We just get natural log, absolute, well, don't need absolute value because it's always positive anyway. We have 1 plus e to the x. Again, because on the top we have e to the x to help us out. So it's natural log of 1 plus e to the x, just like this. Okay, now we have to go from 0 to infinity though, so that's the issue. We're not done yet with the integration. This is natural, this is not natural log, so this is what we are going to do. Look at x. I also want to come with natural log to help us out. X is the same as saying natural log of e to the x, isn't it? So that's the idea. Now, have a look here. This natural log, right, this is natural log, minus that natural log, we can combine them. And we have e to the x on the top now, over 1 plus e to the x on the bottom, like this. Combine the natural logs together. And then we go from 0 to infinity. Okay? Okay, when we plug in infinity, let me just show you guys this real quick. Plug in infinity, technically you should do the limit as x approaching infinity of ln of e to the x over 1 plus e to the x. That's the idea of do the infinity, right? And you will see that, in fact, this is just ln, and this is just e to the x, and just a plus 1, so it doesn't really matter. So you actually just get ln of 1, and you actually just get 0. When you put infinity into the expression, you get 0 first, right? And then minus ln, you put 0 in here and here. This is 1 now, right? And then this is again, e to the 0 is 1, and you have 1 plus 1, which is 2, like this, when you put a 0 to here and there. So you have all that. Lastly, if you would like, you can look at this as negative, and you can bring the negative 1 to the exponent here. So you're looking at this as ln, positive now, right? And this is like saying 1 over 2. And negative 1 right here doesn't matter. Negative 1 right here. It says you bring that up, so you have ln 2. Like this. Right? So that would be how you can do it for that one. Number 56. Here we have a differential equation. And again, we cannot run away from integrals from calc 2. In fact, after you have seen integrals, you cannot unsee it. That's pretty much just how things are. Negative 2y. And then we know y of 1 is equal to 0. Here we go. Divide this on both sides, but that's negative. Divided here, it actually becomes positive. So we actually have e to the 2y, right? So I just want to make sure it's positive exponent here. And then we have dy. Put the dx here, so we have 8x cubed dx like this. Okay? And again, let me erase that. This is the 0 that I got earlier. So be sure you guys just do the limit, right? Just yeah. All right. Now we can integrate. So I will use the green pen again. Integrate. Integrating this, okay, e to the whatever. This is just a constant multiple with y, so we can just do the following. So we get e to the 2y, but do the reverse chain rule, namely the do chain, divided by 2. So we get 1 over 2, like that. And we'll just put on the plus c on the right hand side. Integrating this, we get plus 1, which is 4, divided by 4, we get 2. So we have 2x to the 4. And then here we go, we'll just put on plus c1, like this. If you would like, it's a good idea right now to enter this, I believe. Well, actually, up to you. Yeah. So if you would like, you can actually put it here if you would like. So let's see. If I put in 0 in here, I get So I'll just write it y of 0 is equal to, no, y of 1 is equal to 0. Actually, that's just multiply. Let's just, at least let me multiply everybody by 2 first, yeah? So this is the equation. Now, let's multiply everybody by 2. So that we get e to the 2y, that's equal to 4x to the 4 plus c2. Good. Now, it's much easier this way. We are going to use y of 1 is equal to 0. So we know that this is going to be e to the 2 of 0. And this is equal to 4 times 1 to the 4 plus c2. So this right here is 1. This right here is 4. And this right here is c2. So c2 is equal to -3, like this. All right, so now you're looking at this equation. C2 is -3. You can put it down here. You can take the natural log on both sides, right? You can pretty much take the natural log on both sides so that they cancel, and then divide the 2 on both sides. So you get the y by itself. And we have the 1 over 2. Again, divide the 2 on both sides. And then you have the natural log of 4x to the 4 minus the c2 is -3. You're done. Right? Okay, so that's pretty much it. All right, so now for number 57, I am really tired already, but I will still do this legitimately, okay? Find the exact value for this surface area, so I'll still do it legitimately. So here we go, number 57. Okay, find the exact value for the surface area. You are given the arc. So you rotate the arc, and I'll just write it down like this. X is equal to t e to the t minus t, e to the t minus t, and y is equal to 4, e to the t over 2. Rotate this, and we just care about from 0 to 1, about the x-axis, and again, on the surface area. So here we go. Here we go, surface area. Rotating about the x-axis, it goes like this way, yeah? So the radius is y. So here we go. This is going to give us the integral 2 pi y. 2 pi y, okay? And then we have the square root. And we have to do the derivative. Okay, so perhaps I'll set it up for you guys first. So again, you need the derivative. So I'll say dx dt, and you square that, plus dy dt, and you square that, dt, and you go from T1 to T2. So that's the surface area when you rotate about the x-axis. All right, now we'll take everything to the t world, like all the y's and also the derivatives, all that stuff. Integral from 0 to 1, T1 to T2, and then 2 pi. And here we have the y, which is just that. So I will just multiply by 4, and we have the e to the t over 2, like so. And then we have the square root. This is going to be longer. Parentheses, differentiate this. So we get e to the t minus 1, and you square that. And then differentiate this. This right here is e to the t over 2. But use the chain rule. Multiply by the derivative of t over 2 is 1/2. 1/2 times 4 is 2. So here inside, you have the 2. Square that, and you have the dt here. All right? So what we're going to do is just clean this up a little bit. I'll do this in green. So expand this, you get this thing square, which is e to the 2t, and then minus 2 times this and that, so it's 2e to the t, and then plus this thing squared, so it's 1. And this right here, we add this thing squared, 2 squared is 4. This thing squared is just e, multiply the powers, you just get t, like so. And then this and that together, you just get e to the 2t plus now, right? This and that becomes plus now, plus 2e to the t plus 1. But we can actually factor this and we get e to the t plus 1 square. Very nice, huh? Yeah. Again, just do the square root, and cha-cha, they cancel out. Haha. All right, so now we can come back here and we can say that this right here is the integral from 0 to 1, 2 pi, and we still have, actually, let's multiply this number out already. Okay, let's multiply out the 4 and 2, so it's 8 pi, so let's put 8 pi all the way on the in the front. Integral 0 to 1, yeah? And then we have e to that, so we have the e to the t over 2 still, yeah? Let's see if this is right. Yes. This, no, it's no more square root, so we just have this. I'll put this down in green. So we have e to the t plus 1, like that. Okay. Then you do dt. And then we'll see this is going to be 8 pi. Let me just multiply this in first before I integrate so that I don't get mixed up with all that. Multiply, you add a power, so you get e, and then you have this power slab, which is 1/2 plus 1, which is just 3/2. But of course, you have the t, and then plus e to the t over 2. So just put it as 1/2 t so that the forms are the same. dt, and finally we can integrate. Here we go. 8 pi all the way in the front. Integrating this is a constant multiple with the t, so it's e 3 over 2t, but you multiply by the reciprocal of this, because it's the reverse chandle, so you multiply by 2/3. Right? And then you add, again, you multiply by the reciprocal of that, which is 2 over 1, which is 2, e to the 1/2 t, like this. And don't forget, you take this and you plug in numbers from 0 to 1, like that. So let's go ahead and just see. This is 8 pi all the way in the front. I will put in numbers here now. We will have this. I'll put this down in green so that might be easier to see. So we have 2 over 3 e to the 3 over 2 times 1. And then plus 2 e to the 1/2 times 1, yeah? So this is the first part, and then minus. Putting 0, so we have 2 over 3, e to the 3 over 2 times 0, and then plus 2e 1/2 and 0, like this. Right? So this is pretty much all we have. Now, we can add this up together. This is just a regular fraction. So this is 2/3 plus 2, which is the same as saying 6 over 3, which is 8 over 3. So this right here is 8 over 3. Yeah. And that right there is nothing too special that we can do. So why don't we just use a calculator, right? So let me see. 8 pi and I kind of want to factor things out or whatsoever, but no, I don't want to do any of that. So I just write it as 2 over 3 e to the 3 over 2 plus 2 e to the 1/2, and then this is plus a over 3. Yeah, because I mean, if you really want, you can just get a common denominator and all that, but no. After 4 hours, no. Oh, by the way, if you would like to know, the answer to this is approximately 90.94. So hopefully I'll ask you guys a question that you can just use a calculator for it. Alright? So that's number 57. Number 58, should I? I will. I will. Number 58. Integral x squared sine of 3x. Like, why am I so confident to be able to do this with this little place? Because we can use the DI method, right? All right, now let's go ahead and put this down. Let's put on D and I, and then plus, minus, plus. We need to differentiate x squared and then minus, so you see 2x, 2, and 0. And then we'll integrate sine 3x. All right, so focus. Integrating sine, we get negative cosine. So this is negative cosine 3x, but divided by 3, yeah? So it's like that. Integrating negative cosine, we still get negative, and that's sine 3x divided by 3, so it's 1/9. And then do it again. Integrating sine is negative cosine, but negative negative becomes positive, and that's 1/27, because you have to do that again. Right? You see the 0 in the D column, so you stop. All right, so here we go. All right, so just do the diagonals. This is nice and easy. So you do this times that, which is negative 1/3 x squared cosine of 2x. I don't know if I can finish writing it. So anyway, I think so. Yeah. This is negative times negative, so it's plus 2/9 x sine of 3x. And lastly, we have this times that, so it's plus 2/27. Oh, okay, I cannot finish this. So it's plus 2/27 cosine of 3x, and we're done, plus c. Alright, so this right here is it. Alright. For my future students, if you're watching this in 2022, right? If you guys want more practice questions, I will make more for you guys, but you guys will also have to do it though, okay? So if you guys really want to ask me for more, yeah, I will do another 100 calculus 2 questions for you guys. And again, this is only applicable to my future students in year of like 2022. I'm not going to do any of this in the next year, 2020 or maybe 2021. I don't know, but hopefully this is good for like at least 2 years or so. Anyway, that was 58. Okay, number 59. We have an infinite series. N goes from 3 to infinity. Leave a comment down below and let me know why I'm using n is equal to 3 instead of like 1 or 0, right? So this is 1/n square root of ln n. Anyway, does this converge or diverge? Why? You have to give a reason. Well, we have to check by using integral. We can do the integral test. So here we go. If you do the integral test, be sure you just go ahead and consider, or just check the improper integral going from 3 to infinity, 1/x square root of ln x dx. And be sure you supply a graph on the side just to show that, hey, this right here is decreasing, and the truth is when x is equal to 1, you get infinity. So yeah. Anyway, you get a positive, continuous, decreasing function from 3 to infinity. All right, so yeah. All right, now to do this, we can do by u sub. Yeah. So let u equal to ln x. du is very nice. It's just 1/x dx. Now take this integral to the u world. This is x going from 3 to infinity. So we have integral going from u equals, put 3 into ln. So we have ln 3, and put infinity into ln. ln infinity is also infinity, so u will also be going to infinity. This 1/x, hey, 1/x together with the dx, this right here is the du, so we are good. So I just pair this out with du, and then we have 1/, square root, this ln x is the ln u, like that, right? Now, integrating this, you get 2 square root of u. Why? We did this earlier already, so u to a negative 1/2, just doing all that stuff, right? So this goes from ln3 to infinity. We'll finish this in the u world. And you'll see this will be 2 square root of infinity. And then if you put this as the first term, and then you can minus 2 square root of ln3, like so. But this is finite, this is infinite, so all in all, this is actually infinity. So therefore, this improper integral diverges. Don't forget to come back here and say that this right here also, right, this right here also diverges by the integral test. Yeah. All right, number 50, no. I'm done with the 50, so 40 something more to go. 60. All right, number 60. We have a partial fraction question, man. Integral 2x plus 7 over x plus 1 times x squared plus 9 dx, like this. Okay, let's just face it. Let's just do a partial fraction. I'll do this in green though, so that, yes, we don't have purple markers anymore, so green's it. Anyway, 2x plus 7 over x plus 1 times x squared plus 9 equals something over x plus 1, right? Something over x plus 1 plus something over x squared plus 9. But for this situation, this right here will be just a constant, but this right here will be a linear term because this is an irreducible quadratic. So now that's all you have. All right, for A, it's not so bad at all. We can do this by the cover up. Go back to the original, cover up this, and let x equal to -1. Put -1 in here. 2 times -1 is -2 plus 7 is negative, no, it's positive 5. -1 here is positive 1 plus that is 10. So it's 5 over 10, 1/2. Man, why did I choose the fraction ones for this? All right, so we have the A is equal to 1/2. For B and C, I would recommend you guys to do it the traditional way, meaning that just take everybody and multiply by the common denominator. Right? So just do it like that. This times this, on the left-hand side, we get 2x plus 7. And this is 1/2 already. We got it from the cover-up method. This times that is x squared plus 9. This times this is this times that only, right? So we put down plus the bx plus c that we still don't know, and we multiply this with x plus 1, like that. Multiply out the right-hand side. This right here is 1/2 x squared plus 9 over 2. And multiply this out, we get this plus. All right, so this times this is bx squared. This times this is plus bx, and then plus cx. And lastly, we get plus c. And as usual, we collect the like terms. This guy is the only guy that has 1/2 x squared. Oh, this is also with x squared. So this and that together, we have 1 over 2 plus b, and then you have the x squared. This is a constant, that would be with that, so b plus c. So we have this and that together. Okay, so I will put down plus b plus c, x, and lastly this and that. So we have plus 9 over 2 plus c. Match coefficients. This right here, we don't have any x squared, so this 0 plus x, 0x squared. So that means this right here has to be 0. That means b has to be -1/2. All right, depends on how you want to do it. B has to be -1/2 already, and we can do it right here. I think it's easier this way because I don't want to see any more fractions. It's purple. This and that, right? So that means -1/2 this is a negative 1/2, plus c has to be 2. That's the coefficient on the left-hand side for that. So that's pretty much the idea. So now let's see what c is. So in that case, c will have to be, you add 1/2 on both sides, that will be the same as 5/2. Whew, like that. Man, it's a lot of fractions. Not so bad though. B is negative 1/2. C is 5/2. Okay? Now, we are going to integrate this right here. Break this apart. The first thing that we will have to integrate is 1/2 over x plus 1. Yeah? Next, you are going to integrate this over that. You have to split the fraction. And this right here is negative 1/2. So I will put down minus 1/2. And we have the x here over. And we have the x squared. Let me do it like this. Minus 1/2. And then the x over that. So we have the x over x squared plus 9. Okay? And then we have this, which is positive 5/2. So I'll just put on plus 5/2. And we have 1 over then because I separated it like this. And for this situation, notice how on the top we don't have x. So I will look at the 9 as 3 squared because this is the inverse tangent situation. Right? Now we just have to integrate everybody. Integrating the first guy, this is 1/2 ln absolute value of x plus 1. Done. So that's the nice part. Okay, this one is really tricky. So slightly trickier, be careful. The derivative of the derivative of x squared plus 9 is 2x. On the top, we only have x. So imagine that you just multiply this by 2, but you just have to divide that by 2. So that's the idea. You have to divide it by 2, so you actually get the minus 1/4. So I'll put this down in purple. Just do the use up if you were like, this is the final review, so you should be comfortable doing use up all that stuff, okay? And then this is going to be u, right, on the bottom now, and you just get ln, and the input is x squared plus 9. Parentheses is enough. And then this right here, you have the plus 5/2. So I'll put on plus 5/2 that we have earlier. But use this right here, you have to do the inverse tangent. So you do 1/3, and then you have the inverse tangent formula. Input is x divided by 3, like that. Okay? So in the end, of course, you can just multiply this out. I will just divide it by 3, which is 5/6, like what I showed you guys earlier, like that. Plus a fish. Right? So, yeah. Some fancier fish, I don't know. Alright, so that's it. 4.5 hours, kind of. Alright, that's number 60. Right, number 61. Does the integral from 1 to infinity of 1 over x plus e to the x dx converge or not? Or diverge? Why? Right, so this one here, we are not trying to get the actual value out of that. We'll just try to argue if it converges or not. So for this one, we'll just be trying to do a comparison. All right, so here we go. Let's put on something that we know much better instead. So here we go. I will put down what we know. And here we go. Well, I said here we go like 3 times already. Huh? Okay, so on the top it's just always 1, so it's just 1, so that's good. But on the bottom we seem to have two choices. Shall we just look at 1 over x? Or shall we look at 1 over e to the x? Well, the truth is, if you put down 1 over x, this is going to be a divergent integral. And unfortunately, this integral will be less than the divergent integral, so we cannot draw any conclusion, right? The truth is, pick up e to the x instead. Does this converge? Well, it's much easier to deal with this because you can integrate this really nicely. This right here is e to the negative x dx. Integrating this, you get negative e to the negative x, and then you just plug in 0 to infinity. Plug in infinity, you get 0. Right? Plug in infinity, you get e to the negative infinity's power, so that's 0. And then, so that's the first part. And then minus negative, you put in 0 here, you get e to the negative 0 like that. So this is just 1. Yeah. So of course, this right here converges. We can work it out very nicely. So that we know that, and it converges. Now here is the check. This is convergent. So we wish to show that the integral that we're doing is hopefully less than or equal to the one that we are the one that we know. So check 1 to infinity 1 over x plus e to the x dx. We hope to show this is 1. This is less than or equal to. Why did I put down 0 over there? My bad. So this right here should have been 1. And then this right here should have been 1. And this right here should have been 1. So that means this right here should have been positive 1 over e. Yeah, so, but still converge anyway. Anyway, 1 to infinity, and then we have 1 over e to the x dx, right? Alright, so notice that everybody will be positive, so this is legit, and you can just compare the inside, 1 over x plus e to the x. Is this less than or equal to 1 over e to the x? It's pretty easy to see. If you don't see it, we can cross multiply. This go there, and we only care about for x greater than or equal to 1 because this says so. This times there, you get e to the x. Is this less than or equal to x plus e to the x? Sure, we can subtract e to the x on both sides. This is not just true, this is so true, right? Yeah, so I will just tell you guys the conclusion. The integral from 1 to infinity 1 over x plus e to the x dx. By the way, because we did the integral from 0 to infinity of 1 over 1 plus e to the x, it was from 0 to infinity. That converges. You could have used that one to compare with this if you would like. But suppose you don't see that question. You only have this one, then you do comparison with 1 over e to the x. Anyway, this right here, the powerful word, also converges by the comparison. And when, in this book, just weird, like in the improper integral section, they just talk about the direct comparison test, meaning the inequality. So that's their comparison test for the inequality, for the improper integral. Can you do limit comparison test for improper integral? Yes, it's just that the book doesn't do that. I don't know why. Right? Now for the next one, I have to again use like the whole board again. So number 62 right here. So it's being no, I'm just going to do this out. Find the centroid, all right? So we have e to the 2x. So here's the picture. 0, 0, 1. Okay, so e to the 2x looks like this. And this is y equals e to the x, 2x. And we want this curve, and then from 0 to 1, and also 0 here. So this is from 0 to 1, and it's this region. We want the centroid. So of course, we should get the area first. So here we go, the area. name the integration from 0 to 1 of that e to the 2x dx. And let's just do it in our head. So here, you will just have to do this. Integrating this guy, you will just get e to the 2x divided by 2, right? Plugging 1, so you have 1/2 e to the 2. Yeah, and then minus plugging 0, you just get 1/2. So that's the area. Yeah, I don't know why it looks weird, but that's the area. Just have to deal with it. All right, then let's see. Find the centroid. So x bar. Man, this is the integral from 0 to 1, x times e to the 2x, right? And then you have to do the 1 over a. And again, it's the x times the y, right? X times the function. So that's the idea. And then we have to do integration by parts for this one. So we will do the integration by parts for this one. 1 over a, man, this is 1 over a is all that. So perhaps I'll factor the 1/2. And e to the second minus 1. So about the 1/2, e to the second minus 1. And then, integrating this with integration by parts, we will have to do it here. Yeah, we just do it here. D and then also the I, plus minus, plus x 1, 0, and then e to the 2x, 1/2 e to the 2x, and then 1 over 4 e to the 2x. Okay, so we pretty much get the answer right away. All right, now this is the first part of the answer. We have 1/2 x e to the 2x, and the second part of the answer is minus 1/4, and we have e to the 2x. Am I right? Let's see. Yeah. Now, just go ahead and plug in numbers from 0 to 1. Just this part, right? So we get all the way. This is just 2 over e squared minus 1, right? 2. So let's see. Put a big parentheses. Putting 1, we get. Let's do this in Ohio, okay? So put a 1 right here. This is 1 times that is 1/2. Let's put it down in black. It's too confusing. 1/2 times 1, just 1, and then e to the 2. Putting 1 here, we get e to the 2, and that's 1 over 4. So minus 1 over 4, e to the 2. Okay, that's the first part. And then we minus, putting 0. This is gone. That's good. I know. And then putting 0 here, we get minus 1 over 4. Yeah. How can I simplify any of this? Not really. So I'm going to just, oh, okay, I see how. This and that, we can combine the terms. Let's see, multiply by the common denominator, of course. Multiply by, so we can get the common denominator, so it's 1 over 4. So both of this together give us 1 over 4 e to the second power. But this times that, oh man, I see. This is 1 over 4 e to the second power. This is also minus 1 over 4, right? So we can factor the 1 over 4. So this is 2 e squared minus 1. And we have the 1 over 4. So multiply by 1 over 4. And then, be really careful though. This is e squared minus minus. So it's a plus 1, like that. And in the end, we can cancel things out. So this is 1, this is 2. And on the top, man, it's pretty nice. E to the square, e to the second power, plus 2, plus 1 over 2 times that. So it's 2 times e squared minus 1. And we are done. Well, not really. This is just x bar. Yes, y bar. 1 over a times the integral from 0 to 1. We have the 1/2 here, okay? And then we are going to square the function, which is squaring e to the 2x. Okay, 1 over a. So here we go. 1 over a is the same as that, pretty much. So I'll just put this down. 2 over e squared minus 1. Okay, integrating from 0 to 1, this is 1/2. I know they cancel, but just let me do it later. And this right here is e to the you square it, so you multiply. So you multiply, so you get 4x dx. Now cancel these guys. All the way in the front, we have 1 over e squared minus 1. But to integrate this guy, this is still just that, e to the 4x, but you divide it by the derivative of this because of Lu chain. So the reverse chain rule. So go from 0 to 1 like this. All right, 1 over e squared minus 1 all the way in the front. Putting 1, we get 1 over 4 e to the 4th power. Putting 0, we just get minus 1 over 4. That's pretty much it. We can factor out the 1 over 4, and we can do some difference of squares. So here we go. This right here is 1 over 4 times, we have the 1 over e squared minus 1. But this is e to the 4 minus 1 now, and that's the same as saying e squared minus 1, e squared plus 1, isn't it? Cancel, cancel, very nicely. So this right here, it actually ends up to be pretty nice. Y bar is equal to e squared plus 1 over 4. So that was the x bar, and that's the y bar. Again, this one here, we cannot simplify anything, but the other one, we were able to, right? So that's the idea. And for the next one, I don't think, yeah, let me just erase the board. All right, so, yeah. I went to the gym yesterday, to bench press and also to do some shoulder press. I shouldn't have done that because my shoulders and my chest are extra tired. Yeah, and I'm holding this thing for 4 hours and 40 minutes non-stop already. All right. Okay, what the frick? What should we do next? Number 63. Number 63. We're going to find the slope of the tangent line to the curve. Consider that r is equal to cosine theta. And we want dy dx at theta equals pi over 6. Right? So, here we go. So we did a similar question in the multiple choice question earlier. So this is exactly how we're going to do it. Remember, x, change this to the parametric form, right? So x is equal to r times cosine theta, and r is a function of theta in our case. And the y is also r, but this time we multiply by sine theta. And the theta is just the parameter in this case. Now you see that r is the cosine theta. So x is just going to be cosine theta times another cosine theta for the x component. For the y, this r is that as well. So we have cosine theta, but we multiply by sine theta. Okay, for the top one, it's pretty good because this right here is just cosine square theta. That's good. And for the bottom one, it's also not so bad because this right here should remind you of the double angle identity for sine. But we need a 2. It's okay, we can just say that's 1/2 sine of 2 theta. Can we do that? Yes, right? So now we can do our derivative. dy dx is equal to dy d theta divided by dx d theta. And then this right here, on the top, it's not fish, right? I don't know why I wanted to make a joke about fish, but no, let's just finish doing this. dy dx, dy d theta, you look at this and differentiate. Okay, so you see that let me just show you guys all that. So this is 1/2. Derivative sign is cosine, and the input stays the same, but we use the chain rule. Multiply by the derivative inside, so multiply by the 2 right there. And then, for the bottom, dx d theta, look at this, and do the usual thing, bring that to the front -1. So we have 2. Cosine theta stays the same, but we also use the chain rule for the cosine here, and that will give us negative sine theta like that, isn't it? Well, can we simplify this in any way? Yes, this and that cancel nicely. We see the top is actually just cosine of 2 theta. On the bottom, well, this is just the double angle identity for sine, but it's the negative version. It's okay though. So we have negative sine of 2 theta. All in all, we get negative cotangent of 2 theta. And in the end, because we want the theta to be pi over 6, this is also a notation, by the way, but I haven't used it, so I will just do like this. When theta is equal to pi over 6, I'll just have to plug that in. I get negative cotangent of 2 times pi over 6, which is the pi over 3 inside. So this right here is negative, and let's look at pi over 3. With a special right triangle, this is pi over 3. Okay, we care about pi over 3. This is a special right triangle. This is 60 degrees, so this is square root of 3. This is 1, this is 2, like that. Cotangent, well, by the way, this is negative, so we'll have that. Cotangent is this over that, adjacent over opposite. So we have 1 over square root of 3. And because we're in calculus now, we are adults now, we don't need to rationalize the denominator. This is perfectly okay. Just like that. I don't know if I have enough space. Oh, let's try. Because I'm lazy too. Alright, so for the next one, we have a tank in the shape of like a frost tome. It's just like a bucket, but it's extended like this or like this. It's like a cone, but you chop it off. So it's a part of the cone. That's how they say it. All right, so I'll give you guys the picture, okay? So you have a frost tome. So you have the top is circular and the bottom is also circular, but the top is actually smaller, so it's top with the radius 2 meters. And the bottom is actually wider. So this is like that. So it's like a cone, but you just again you just kind of cut it off like that. Okay, and the radius of the bottom is 3. No, the 6. The radius of the bottom is 6. So this is 2 meters, and this is 6 meters. And then again, you should be looking at the PDF and then following along, okay? And the whole height is 5. So I'll just put this down right here for you guys. This right here is 5 meters. Okay, but the water is only up to 4 meters. So the water is only up to here. So I'll just put it down like this. I'll put this down in green. I think I usually do that. I don't remember. Now let's do a purple water this time. So purple water, right? Purple water. So it's only up to there. So it's only filled up to 4 meters. Haha. Same thing. We are going to pump the water out, and maybe you will see a little hole on the top, so you're going to pump the water out. All the things. We want to find the work for this. And here we go. What's the first thing? You need to set up your x and y axis. So let's go ahead and perhaps put on. This is a 3D picture, by the way. So I'll try to do like this, right? This is my x-axis. And of course, putting right in the middle, here is my y-axis. And take a horizontal slice. It's going to be a cylinder, namely a small disk. Well, yeah, put this down right here. This time we're talking about volume. So you go straight down like this. Straight down. That. Like that, right? So we don't want the volume of that. Again, for the work, you have to know the 3 components. So I will put this down right here for you guys. The work. First, we need the volume. So let me put it down. And you should do this kind of questions from right to left. Next, we need the density. And lastly, we need the distance. Right? So I think it's much easier if you look at this from right to left. All right, so now for the volume, you just have to pay attention to the disk. And the reason I said you do this from right to left is because the distance depends on where the disk is, and then also labeling. So that's why. Anyway, the radius is x, and the height right here is dy, and the volume of the circular cylinder or the disk is pi r squared. So just pi, and the r is x, and you have the height being dy, the thickness. Okay, we're using SI units, so it's 9.8 times 1,000, and these are my baby x, right? Just multiplying. All right, now for the distance, you see this right here, from here to here, is y, and we have to go up all the way to the top of the tank so the water can be out. The whole thing is 5, so it's 5 minus y. Okay, 5 minus y. I'm sorry about my background. Let me just not do that anymore. 5 minus y. So I just have to multiply by 5 minus y. And then integrate this. The disk go from here to here. That's only up to here. The disk is just a amount of water. So you just go from 0 to 4 like that. So that's pretty much it. Okay. However, the problem is, of course, the x. It's not allowed in the y world. Go back here and then do the equation. It's just the equation of a line though. So look at the line right here. This and that. Okay, so from here to here, we get 6, 0. From here to here, notice that this is 2, so the x direction is 2, and 2, 5, like so. And do the slope. Man, the slope is m equals 5 minus 0 over 2 minus 6, which is negative 5 over 4. Yeah, negative 5 over 4. Is it? Yes. And then, oh man, how to do the y is equal to x plus y minus y1, all that stuff. So here we go. Y minus, let's say this is x1, y1. So y minus y1, which is 0, and that's equal to the slope, which is negative 5 over 4, and you multiply by x minus 6, like that. But I want to get the x by itself, so you see x will be, you multiply by the reciprocal on both sides first, so we get negative 4 over 5 times y, right? Multiply that on both sides. And then you add the 6 on both sides, so plus 6, like that. This right here will be for the x. And then you just put this down right here, so x right here. You plug in negative 4 over 5, y plus 6. Right? So this is the setup. This is the most important part. In the end, I'll tell you guys what the answer is. It's 8623. Sorry, 8623 814. I feel like I'm reading a phone number, but it's not. 0.25. And this is for work. So what's the unit for that? Joules. J. Just like that. All right, have a look. Have a look. Have a look. Crazy stuff. All right, if this is helping you for your Calculus 2 final, I hope that's the case, right? Just let me know. And if I am missing any type of questions, also let me know too. Because I think I'll be teaching like calculus. Of course, I'll be teaching for the next 10, 20, 30 years. And hopefully YouTube will stay and my channel will stay so that I can be using this for you guys for the future. Yeah. number 65. I need to go get a new marker, I know. I just brought 2, so I need to get some new marker and then the black ones. So man, number 65. Integral 1 over x squared minus 4x plus 7. What? Yeah, can we do partial fractions on this though? Can we factor this? Well, if we cannot factor it, we are going to complete the square. In fact, this right here, it's an irreducible quadratic situation. So completing the square is the way to go. I will do this in purple for you guys, right? So here we go. Look at this denominator. We have x squared minus 4x and leave a space for now, plus 7. Complete the square. You see, this is 1, that's great. And then we are just going to look at half of this, which is 1/2 times -4, and we will have to square that. Inside is -2, square that we get +4. So we have to add 4 here, and then -4 there. And you will see that the first 3 terms will give us a perfect square. That's x, the x looks kind of weird. This right here will give us x minus 2 square, and this right here will give us +3. So that is very nice. Now we will be just integrating 1 over x minus 2 square plus 3 dx. Okay, so that's pretty much the idea. And here is the deal though. We can do a u sub real quick. U is equal to x minus 2, but you will find out it actually doesn't matter because du is the same as dx. So if you would like, take the u sub. Yeah. Anyway, this is 1 over u square plus something, and then dx is the same as du. But we are about to use the arctangent, so for the 3, this is what we should do. For the 3, I will be using square root of 3 square, because we have to look at u square plus a square, and a has to be a constant. And to get 3, we will have to just square root 3 square like that. Right? Okay, so do the inverse tangent formula, which says 1 over a, which is this. 1 over a, which is square root of 3, times the inverse tangent. And the input here is u, but u is x minus 2, so we just write down x minus 2. And then divided by a, which is again square root of 3. And again, we are all adults now, so we can totally have a square root number on the denominator, on the bottom. Done! Love integrals. Okay, number 66. 1 to infinity, series 1 to infinity, we have 4 to the n factorial over, and we have n to the nth power. Does this converge or not? Which test should we use? Well, notice that we have n pretty much in 3 places. Exponent, factorial, and also both base. So it would be a good idea to use a ratio test. So let's go ahead and do that. So let me just indicate that. Use the ratio test. So that means I will have to take the limit as n goes to infinity. You don't have to write down the LIM as n goes to infinity. You can just write this down and then just draw arrows for limits. Okay, so this right here is the an. You have to first set this up as absolute value for, and for the n, it becomes n plus 1. Likewise for that, it's n plus 1. Factorial this, divided by this is n plus 1 to the n plus 1. Okay? Times the reciprocal of the original, namely we get n to the n over 4 to the n times n factorial, like that. Now, break down the bigger factorial, which is this, and also break down the bigger power, which is right here. This is 4 to the n times 4. This right here is saying n plus 1 times n factorial. This right here, we can write it as n plus 1 to the n times n plus 1 to the first. So that's how we can break things apart. And then we see that 4 to the n and 4 to the n cancel each other out. N plus 1 cancel each other out. Factorial, right here, the n factorial cancel each other out. So that's good. And now we have the 4 right here. So let's go ahead and do the algebra. We have the 4. And you see we have this n and this n in the powers. So we can actually just take that out. And we can just do this over that. N over n plus 1 to the n's power. And the absolute value doesn't matter because everything is positive, right? So that's what we have. But what can we do though? Remember the fact. Oh, let's see. Where should I write it? No, just put it on here, right? So remember that if we have the limit as n or x goes to infinity, 1 plus a over n to the bn power, I call this to be the fact because this right here will give us e to the ab. Very nice, right? Very nice. I call this to be the fact so that I will have a name for it so that we can refer to this very nicely. So I'll perhaps write it down just to be respectful to the fact. How can we make this in the same form of that? Look at, we want to have 1 plus something. This is n over n plus 1. I want to have 1 term on the bottom. That would be better. So let's do it this way. 4 stays all the way in the front. Let's do the reciprocal, but we have to negate the exponent. So we are looking at this as n plus 1 over n, but raised to the negative n's power like this. Then we are still doing algebra, so that's why I still put on equal sign. This over that is 1, this over that is plus 1 over n, and then we have the negative n like this. And now, I just say, by the fact right here, and to do that, you can just tell me a is equal to positive 1, and b is equal to negative 1. So, for this part, it's going to give us e to the negative 1. 1 times negative 1, if you would like to show work. Right? 1 times negative 1 like this. But don't forget we still have a 4 in front. And now you see this right here. This is equal to 4 over, well, e to the first power, so just e. Now, this is the limit that we have after we run through the ratio test. It does sound good because this is not equal to 1, right? But is this bigger than 1, less than 1? Well, e is about 2.7 something. We have 4 over e, so this is actually greater than 1. Therefore, this right here diverges by the ratio test. Right? Diverges by the ratio test. If it's bigger than 1, for the limit for that. So, just like that. Okay. Five hours already. Oh my god. I'm totally not going home by 10. I should have got here earlier, like maybe like 10 in the morning. All right, number 67. So consider the integral going from 0 to 8. And we have the square root 1 plus x to the third power dx. And we want to find the Simpson's rule by using n is equal to 4. So we are going to find S4, right? And this is how you can do it. First of all, because n is equal to 4, let's compute our delta x, which is 8 minus 0 over 4, and that's equal to 2, like this, okay? Then I will just draw a number line. You don't have to draw the whole graph. Just draw a number line. That will be enough. Going from 0 to 8, but you have to cut this into 4 pieces. Each one is going to be with 2. So it's 2, 4, 6, 8, like that. And for the Simpson's rule, this right here will be your x values that you have to use. Now, for the Simpson's rule, what you do first is you do 2 divided by 3 like this, right? You do 2 divided by 3 like this. And then, here is the deal. This right here is your function. So you're going to be plugging numbers. This is the first x value you have to plug in, and the coefficient for that is just 1. So here you have f of 0. And then the next coefficient and the next x value is 2. But the coefficient right here is 4. You have to multiply by 4. And you have the f of 2. So that's the Simpson's rule, right? You have to remember that. Next, the coefficient is 2. And you put in the next x value into the function. And then the next x value is 6, and the coefficient is 4, and you have f of 6. Lastly, you see this is the last x value. Well, the coefficient for that is 1. It's just 1 and 1, and then it goes like 4, 2, 4, 2, 4, 2 in between. And then it should be like 1, 1, and then 4, 4, and then all that. And it has to be even for the Simpson's rule. But anyway, the last one is f of 8, like this. Okay? Use your calculator. You can do it the way I showed you guys in class, or whichever way that you would like. And I'll tell you, this is approximately 73.7985. Right? So that's the idea. Okay, number 68. This is another computational question. And usually for a computational question, I would just like to show you guys one example. You guys hopefully can remember it, because it's just about the formula that you have to know, right? So, for the next one, we are going to use the Euler's method. So, we have a differential equation, dy dx, that's equal to x times y minus 2. And y of 1 is equal to 3, right? So, I will tell you, hey, use the Euler's method. To get y of 1.2. Right? To get y of 1.2. So, what is the Euler's method? You have to remember that. I will just put it down somewhere for you guys. First of all, this right here is telling us that x0 is equal to 1. And this is the x0, and this is the y0. And the y0 is equal to 3, right? So that's the idea. Now, for the Euler's method, you have to remember this. This right here tells you how you can go to the next x, how you can go to the next y value. So, yn. So this is a sequence. Yn, right? This right here is equal to the previous y value plus h, and this is called the step size. Right? Step size, and times f of x n minus 1, yn minus 1. So, like this. And I forgot to tell you guys that to use this with the step size, I will have to tell you what the step size that we are going to do. We use 0.05. So this right here will be given. This again is called the step size. Right? So what's this then? Well, this right here is precisely your differential equation. And this right here, the reason that we put down f of x and also the y is because, remember, on the right hand side, it can be a function with two variables, both x and y. So this is f of x and y, like that. So now, let me show you guys how you can organize your work to make this work out nicely. You should put down the x0 and y0 like this. Next, x1. Well, you start with 1, and you add the step size, which is going to be 1.05. Right? So that will be the idea. Actually, why am I using red for that? All right, x0, it should be 1.05. Okay? Now, y1. Based on the formula says, you have to look at the previous y value, which is 3, and you add the step size, which is again 0.05, times, well, you have to find out the slope. This is actually derived from the equation of a line, right? The point slope form of the line. But anyway, this right here tells you the slope, and you just have to multiply. Okay, this right here tells you to put the previous x and also the previous y value into here and then work it out. x0 was 1, so just put that down, 1, times y0 is 3, so just put that right there, and then we have that minus 2. That's pretty much the idea. Work this out, we end up with 3.05, a pretty nice number. And we just have to continue until we reach the x value being 1.2. So next, this should be x1. x2, 1.1 because you add 0.05 again. Now, y2 equals the previous y value, which is 3.05. And then you add a h value, which is 0.05, and you multiply by the previous x and so the previous y, you put it here. So we get 1.05 times, this is a little multiplication, times y is 3.05, and then you add, you minus the 2 after that, like this. And you get approximately, I'm just going to round, okay, 3.1101. If you miss by the last digit also, it doesn't really matter. All right, next one, x3, it's going to be 1.15. y3, it's going to be this, which is 3.1101 plus 0.05 times this and that in there. So we have 1.1 times 3.1101, and then minus 2. And you work this out on your calculator, you get approximately 3.1812. One more. All right, so here, x4 is 1.2. And you have to know when to stop, right? This right here, we stop, right? 1.2, but you still have to get the y value. So that will tell you why 1.2 is approximately, thanks to Euler. Okay, so y4 equals this right here, which is 3.1812 plus 0.05 times, again, the previous the previous x value, which is right here and then there, and then just throw in. So you multiply 1.15 times 3.1812, and then you minus 2 after that, and this is approximately 3.2641. So this right here, it's the answer for the y of 1.2. All right, so have a look here, and hopefully once you see one example for the Euler's method, you can pretty much follow along for the other ones. Okay. So again, which other calc 2 questions I shall be putting in? Maybe you guys can compile a calc 2 questions for me to do 100 of them. And please don't do like killer questions, because, well, if I want to do 100 questions of them, then be sure the questions are like a good mixture of like easy, media, and also hard, and a good mixture of that. Yeah. Okay, hydrostatic force. Oh, this one is a really fun one, but I'm not going to read this number because I know some people will be like, I don't know, childish. I don't know, whatever. Anyway, here we have the water, and then you submerge the plate into the water, so it's going to look like this. Horrible picture. Let me just do it again. Right? So this right here is 3 meters, and this right here is 4 meters, and then you see that from here to here, it's 1 meter. Okay, so that's pretty much the picture. And now we are going to find out the hydrostatic force that's acting on this side of the plate. Okay, so here we go. Draw the reference frame. I'll show you guys 2 ways. So if you are watching this, I will show you guys a shortcut. Yeah. For the triangle of other stuff. So here we go. So go ahead and draw the x and y axis. So here's the x. And of course, we can just line up the y. So that's good. Then you remember the hydrostatic force. So just tell you guys this right here. We need 3 components. The first component is the area. Right? Next, you need a specific weight, or maybe the you can also call this to be the density. Depends on how you want to say it. And lastly, how far down you are underneath the water, the depth or the distance, so that I can keep the components very similar for the hydrostatic force and also the work, right? So anyway, this is what we have. Look, what happened to the label? Man, this marker. All right, anyway, for the area, you consider horizontal slice, right? So go ahead and draw a triangle. What did you say? Draw a rectangle, right? Now, check this out. From here to here, well, it's just x. It's not 2x this time because we just have one side. And from here to here, it's dy because that's a small change in the y-axis. So the area of the green rectangle is just x dy, so that's good. Now, for the density, well, density will underneath the water, so I'll just put down 9.8 times 1,000. So this right here is just constant, so it's no big deal. Distance, again, is how far down we are underneath the water. So we are here to here. This right here is y, but let's see, what's this? Well, this to here is 3, this to here is 1. Altogether, the whole thing is 4. So from here to here is 4 minus y. From here to here is 4 minus y. You have to account for the gap right there. Okay, so it's 4 minus y. And then you integrate this from 0 to 3 because this is where the plate is, right? The top of the plate. And yeah, but not done yet though. You guys know this, the x right here, right? The x is right here, so that's not good. Good thing is this time the triangle, the vertex here is at 0, 0. And let's see the slope. But this is 4, 3. So the slope is 3 over 4. And the equation is just 3 over 4 x. And y-intercept is 0, so that's great. But for the x is actually 4 over 3 y. Now I put this down right here, right? 4 over 3 y. So go ahead and substitute this right here for the x. And then you enter this onto your calculator and you work this out, and you will get 117,600 Newton. Done. Actually, it's exact. It's not even approximation, sorry. So it's exact. I believe this is exact, so I'll just put an equal sign. Okay? So this right here is it. Do you guys want to see a fast way? I'm sure you do, right? So fast way, but this is for like maybe you will learn this in statics. This is static by using integral for y, but you will learn the theory behind this in statics. So let's go ahead and do this. Same picture, right? So you still have the 4 and you still have the 3, but you'll see this is much better. The statics way to do this is that the hydrostatic force is equal to the following, right? I will just write this down in words so you guys can see how this works. So first thing that you have to know is that instead of the distance of all that, what you need to care about is the distance, right? The depth of the centroid. That's all you care about, right? So, man, this is running out of ink, so I'm sorry. Just try to use this again. It gets enough rest and then it's going to work a little bit more. So, the distance from the surface of the water to the centroid, right? So, that's it. So, it's the depth of the centroid. Right? And then for the density, you still multiply it by the density, and sometimes they'll call that to be the specific weight. So it depends if you want to be fancy or not, but this is the same as that if you would like. So yeah, it's up to you. So it's actually the same as that. And the last part is, instead of the area of the rectangle that we drew, what we do is the area of the whole thing. So just put down the whole area like this. And in fact, these are just 3 numbers you have to multiply. That's all. You have no worry with integrations. So here we go. Okay, no integration needed, right? No integration needed. What's the area of the triangle? Well, the area just 3 times 4 is 12, divided by 2, which is 6. So the area is 6. Right? Actually, let me show you guys the work. I don't know why, but yeah, 3 times 4 divided by 2. Anyway, specific weight, you are doing the same as that, so that's why I'm using the same color. So we have 9.8 times 1,000, pretty much. Okay, the distance from the centroid. This right here may involve calculus if you have like weird shape, but this is just triangle. It's not that bad at all. Let me show you how to do it. Look at this as a base, yeah? This is the height, yeah? As long as you go out 1/3 of the distance of this, that will give you the location of the centroid. So from here, you go out 1/3. 1/3 of 4 is 4/3, right? But in fact, you don't care about that. You care about from here, 1/3 of that. 1/3 of 3 is 1. So you actually go out 1 unit. So technically, you go out to be right here and that. So let me just indicate that this right here is actually 1, because 1/3, more like this, yeah? 1/3 of 3 is 1, yeah. And from here to here is 4/3, because 1/3 of 4. And that's it. So what's the distance? This right here is 1 already, and then you add another 1. So altogether you have 2. So that's 2 multiplied by 2. Multiply this out, and surprise enough, well actually no surprise, because they are the same. Again, this works nicely when you have like good shapes, such as rectangles, triangles, and whole circle. And yeah, but if you have different shapes, maybe you still want to do that, because to do the central, you still have to use integration anyway. So that's it. That's that question. And perhaps I'm going to get some new marker, and I'm going to wash my hands. So just excuse me for a little bit, and I will be back. This time, actually, I'm going to clean my hands before I touch anything. So I brought things I can actually wipe out my hand. It's just the markers. That's pretty bad. Right, so let me just clean my hands. Oh, just for fun, let me show you guys what I got recently, yeah? Especially if you are still here. And if you have been doing calc 2 for 5 hours and 22 minutes straight, yeah, good job, right? I mean it. You're awesome too. If you watch this in one go, man, that's amazing. Let me show you guys what I got. Can you guys guess what this is? Ready? It's a t-shirt. It's a unit circle t-shirt. But this right here is 5XL. Yeah, this right here is 5XL, and of course you have the identities on the back. And yeah, you can see how huge this is. I bought this on purpose. Yeah, it's fun. And I'm going to wear this one day, and I'll show you guys how I look when this is like, I don't know, it's like a blanket. I can sleep in this already. But I will show you guys how I look when I wear this. Anyway, be right back. Okay, I am back, but it's cold, so I'm going to put on a sweater, right? Oh, cold, really cold. Well, not really. Compared to other country, I don't know. Okay, I have the markers now. Okay, so the black ones are not doing well anymore, so we'll just do this. Okay. So now we'll be getting to the next one. Hopefully they are quick and easy, all right? I don't know. All right, let me just actually write down the questions. Number 70. Number 70, fresh marker. True false questions, okay, for the next 10 questions. So the first one, I prepared it. Well, if I just ask you the derivative of cos x, and I said this right here is negative sinh x. Is it true or false? Well, it looks true, right? But it's actually false. So, how should I write this? Let's say, I'll just say this is false. Yeah, I'll just put down this is false. Probably just write down, I don't know, just this is false. Well, the correction is that this right here, it should be what? Positive sinh x. So that's why it's false, right? And how should I correct this for you guys? Let's see. Yeah, I'll just cross it out, and I'll just tell you guys it should have been positive sinh x, and that's it. Okay, so that's it. Now 71. The question I have for you guys is that it says the sum of infinitely many rational numbers has to be a rational number. So what do you guys think? So just say infinite sum of rationals has to be rational. And by the way, by rational, we mean a whole number divided by a whole number. Okay, so pi over 2, it's not meant to be a rational number, right? So what do you guys think about this? And notice it's an infinite sum. So what do you guys think? 1/2 plus 1/2, well, it's 1. 1/3 plus 1/2. It's not 2 over 5, but it's still rational anyway. But this right here, it's actually false. This right here, it's actually false. Why? Because here's an example for you guys. Okay, so here we go. I'll give you guys this one. Let's do 1, yeah? And then plus 1, yeah? And then plus 1 over 2, yeah? Plus 1 over 6, yeah? And then plus 1 over 24, 1 over 125, so 120, plus dot dot dot. What do we get? This right here gives us, if you stop right here, you will end up with a rational number for sure. You can get a common denominator, you will still get a whole number divided by whole number. But if this right here keeps on going forever, meaning you get the sum as n goes from 0 to infinity of 1 over n factorial, this right here you actually get e, which is not rational, right? This e right here is actually not rational. So this right here is a counter example for that. All right, so number 72. Okay, it says y equals x cubed is a solution to x squared y double prime plus 6x y prime and plus 6y equals 0. Well, in Calc 2, we don't go about how to solve this from scratch. But if you're given a possible solution, how can we verify that? Just go ahead and differentiate this, right? So y will be x to a third power, so y prime will be 3x squared, and then y double prime is going to be 6x. Put this back here. Let's see. This right here gives us x squared times y double prime is 6x plus 6x times y prime, which is 3x squared, and then plus 6 times y is x cubed. Okay, do we end up with 0? Let's see. Okay, everybody has, well, do I have a minus? I don't even have a minus. What am I talking about? You have this, and let's see. Yeah, right here you have what? This is, everybody have x cubed. This is 6, 18, and 6. So 6 plus 6 is 12, plus 18 is 40. Altogether you get 40x cubed. This right here is of course not always equal to 0, right? So this right here is false. This right here is false. I should have changed this to a minus so that it's slightly more fun, but like, no, it's just not anyway. So this is still false. But this is how you check it. Just kind of throw in numbers. You see, I just put on the plus. By the way, anyway. Okay, number 73. I have a polar graph for you guys, and the polar equation is r equals theta squared. And if you graph this, I say is a parabola. If we graph this, what do we think? Well, you can just go ahead and graph that on your calculator if you would like, but this right here is actually really false, right? Because this right here, you're in a polar world. The truth is, if you graph this, you actually get a spiral. So you actually have to, each time you rotate, you have to go out. So it's like rotate, you go out, rotate, you go out. So you have to rotate about the angle, so it's going to look like this. So it's 1, it's pi over 2 and all that stuff, and then something like that. It's like, it's really hard for me to draw. Yeah, something like that. So false, right? Yeah, I cannot really draw, so just something like that. This is not like a perfect circular spiral. So just graph it on your calculator. That's much better, right? So this right here is not a parabola if you graph it. Now I'll just erase this. I don't have any space. Number 74, right here. Number 74. And I said the question is, all right, this one, I did go over this earlier, but imagine I asked the true-false question earlier first. So we have d2y over dt2, d2x over dt2. Is this true or false? And that's the question. Well, this right here is false. Why? If you just kind of divide it dt2, you get d2y over d2x. That's not even the same as that. So the notation suggests it's false. But again, the right way to do this is that you actually have to differentiate. So d2y dx2. In the parametric situation, you actually have to differentiate with respect to time of the first derivative that you get in terms of t, and then you divide it by the expression that you get from dx dt. So you have to do that. So that's pretty much it. So number 75. Now, okay, right here it says the sum as n goes from 1 to infinity, cosine n over n squared. This right here, I said it converges conditionally. So what does that even mean? Is this even alternating? Kind of. It's not like positive, negative alternating, okay? But this right here is actually false. Why? Because what you can do is you can apply the absolute value. Whenever you have sine cosine, you can just apply the absolute value because we know sine cosine will be just less than or equal to 1 at most. So we can say this is the sum as n goes from 1 to infinity. This is 1 over, and n squared is always positive. It's like this, right? And as you can see, this right here is a convergent p series. The p is 2, which is greater than 1, which it converges. So the truth is, this right here, I will just put this down in purple because why not? The idea is that this right here, if you have this over n squared, this right here actually converges absolutely, because when you take the absolute value, it still converges because this right here is converged by DCT, direct comparison, because we have the inequality. So that's just like that. So now let's see number 76. We can use the ratio test to show the series as n goes from 1 to infinity of 1 over n squared converges. First thing first, this does converge, but can we use the ratio test to show? Well, let's take a look. For the ratio test, you have to remember, you have to say as n goes to infinity, right? Take the limit, and you have to do this. You do 1 over, you put n plus 1 in here, and you square that, and you multiply by the reciprocal of that. Yeah? Absolute value doesn't matter because everything inside is positive. And notice on the top it's just n squared. On the bottom, you get n squared plus 2n plus 1. As n goes to infinity, you just care about this and that. And this right here will give you 1. This right here will give you 1. Can you use 1 for the ratio test? No. So this right here is false. And the idea is that if you do the ratio test with any p series, you always get 1. Well, actually, p series especially, yeah, let me see. Depends on how difficult the limit is. Yeah, p series, just don't do ratio test for that. You will end up with 1, which is not desired. So that's the idea.
Go ahead.
My Siri wants to say hi.
Sorry, I didn't quite catch that.
Can you say?
Please repeat it.
Can you say hi to my subscribers?
I don't have an answer for that. Is there something else I can help with?
No.
Okay.
Anyway, yeah, I don't know why today when I mentioned about series, my series is like, oh, really active today. All right, number 77. Okay, true false, right? Limit as n goes, I use x, sorry. Limit as x goes to 0 plus of sine x times ln x is equal to, I put on 1. It's true or false? False. Why? Because it's supposed to be 0. That's why it's false. Just real quick. This right here, you put 0 right here, this is 0, sine 0 is 0. If you put 0 plus right here, it's negative infinity. So it's a indeterminate form. So what you can do is the limit as x approaching 0 plus. Bring this down, so you have the ln x over, you can look at this as, you can look at this part as cosecant x. And then you can do the L'Hopital's rule. So we will do the L'Hopital's rule. Why not? So here we have to differentiate and also differentiate all the good stuff. And then you can see that this right here is a limit as x approaching 0 plus. On the top is 1 over x. On the bottom, do we remember the derivative of cosecant? It is negative cosecant x cotangent x. Right? Cosecant x cotangent x. Right? Now, here is how you can pair things up. This right here, you can bring it up and become sine, right? So let's see how we can write this down. we have the negative all the way on the outside, so we have a negative, and this is the limit as x approaching 0 plus. And again, this is like the same as saying sine x and over x, yeah? And then when you have cotangent, this right here on the bottom is the same as saying tangent x, right? And now, when you take the limit of a product, it's the same as taking the limit of this and times the limit of that. This part, we get negative, and this right here is the limit, right? When using x, so it's okay. So we multiply by 1. This gives you 1. And when you're putting 0 in here, tangent of 0 is 0. So you multiply by 0. So all in all, we do end up with 0. So that's why. All right, so that's number 77. I love like quick questions for this. Perhaps for the next 20 questions, man, I'm almost done. This is going to be the longest video, I know for sure. All right. This is very cool. Number 78. Integral sinh third power x dx. This is right here. Oh man, can we just add 1 and divide it by that 1 over 4 sinh to the 4th power x plus c. I remember the plus c though, even though I'm not wearing the, I don't see the plus c on the screen anymore. This is for all epsilon greater than 0. This is the definition of limit, by the way. Huh? True, false. Of course, it's false. Why? I remember the plus c. Why is this false? Well, because no, you cannot do it like that. It's sinh to the 3rd power, right? So that's no good. That's bad. That's dangerous. This is how you can do it. So correction for this is going to be, you take the sinh out, and you're looking at this as sinh square x times sinh x dx. It's very similar to integrate sine to the 3rd power, right? And now, for the sinh square, we do have a nice identity for that. You have to remember cos square x minus sinh square x is equal to 1. Okay? So if you want to talk about sinh square, you move this to the other side and move the 1 to the other side. Therefore, this is integral, and here you have cos square x minus 1. And then you have the sinh x on the outside, like so. And then you can do a u sub, let u equal to cos x, and du is exactly the same as sinh x dx though, okay? Derivative of cos is positive sinh. So now you are looking at this as the integral u square minus 1, and all that is just du. Very nice. So here we go. 1/3 u is cos, so we have cos to the 3rd power x. And integrating 1 in the u world, we get u, which is cos, and then we just minus cos of x. We're done, plus c. This right here is the answer, right? I know what you guys are thinking. Yes, I did that on purpose for all the true-false question. Number 79. This is just the practice. That's why I can do it. But on the actual thing, I don't think I will do it. Right? So that's bad. I know. Number 79. Without looking at the question, I know it's false. All right, I'm sorry, but I will just do it. All right. So it says if you have a series n goes from 1 to infinity, and if you know this right here converges, does that imply the series as n goes from 1 to infinity, an squared also converge? Well, in fact, this is false. I knew it, huh? Interesting. Of course I knew it because I designed the test. All right, here's an example. Technically, this is called a counter example, okay? So I should have put on C or whatever. Counter example. The idea is that, well, how can you run this? Something square is still a divergent. Can we do that? Yes, 1 over n is a divergent, right? If you take the series. Well, if you take this, an is equal to -1 to the nth power over square root of n. Okay, for this right here, the series as n goes from 1 to infinity, an, you put it here, you see this is negative 1 to the n, 1 over square root of n. This right here converges by the AST, alternating series test. You can go try that out. But if we do the series as n goes from 1 to infinity, if we put this inside and square that, we have negative 1 to the n over square root of n. And then you square that, well, this right here is the series as n goes from 1 to infinity. This is going to give you positive 1. Oh my god, you don't have the alternating anymore. And even worse on the bottom, it's just n. So this right here diverges, right? Could this be true? Yes, but does this work all the time? No, right? So that's what it means by true false. This does not work all the time. So that's the idea. Okay, so that's, man, these are the nice true false questions. It only took me like a couple minutes to do. 20 more questions. Maybe I go home by 11. We'll see. I have a really like, the hard ones I put it at the end. I don't know why. Okay, we'll just go ahead and do the work. Okay. Number 80. Prove the inverse sinh. Right? Prove inverse sinh is equal to ln of x plus square root of 1 plus x squared. No dx, no. So this is just a proof, right? And it should work for any real number. So here we go without further ado, right? So what we do is, starting by, put up here, let's call this to be y. So we have y equals inverse sinh of x. Well, you have inverse. You can apply the origin on both sides. This means you have the sinh y equals x. And the purpose of us to do that is because this right here, we know is e to the y minus e to the negative y over 2. We can apply the definition for that, and that's equal to x. And now our goal is to solve for y. Well, multiply 2 on both sides, and you see this is e to the y minus e to the negative y equals 2x. And then, notice how this is e to the negative y. Let's multiply everybody by e to the y. Because this way, you see this times that is e to the 2y. This times that is minus 1, and that's equal to 2x e to the y. Technically, this is a 1 over e to the y, so clearing the fraction. That's pretty much the idea. Now, in fact, this is a really cool quadratic equation. Look at this. This right here is the same as saying e to the y, and we square that. Bring this to the other side, so we have minus 2x, and this is also e to the y, and then we have that minus 1. This is equal to 0. Quadratic formula in action. The input is e to the y though, so we have e to the y. That's equal to negative b. It's this. So this right here is the b right here, okay? So this right here, I'll just put it down. We have to have the negative b, which is negative, let's put it down as, let's do it like this. Yeah, negative b, which is negative 2x here, okay? Because that's technically our coefficient. Plus minus square root of b squared, which is that square. We have negative 2x squared minus 4ac, 1 and negative 1. A is 1, c is negative 1, like this. And then divide everybody by 2 times 1. 2 times a, of course. So that's pretty much the idea. So now, we are going to work this out a little bit. Notice this is going to give us 4x squared plus 4, yeah? So we can factor out the 4. So this is going to look like 4, and you have the parentheses x squared plus 1, like this. And don't forget, you still have to do the square root. So you are looking at this as e to the y, that's equal to plus 2x, and then this is plus minus. This is the same as just 2. Square root of 4 is 2. And then square root of x squared plus 1 all over 2 times 1, which is, of course, just a 2, right? Now, if you would like, of course, you can just cancel everybody out, the 2's. So you get x plus or minus square root of x squared plus 1, like this. But as you can see, this right here is always greater than 0. If you have a minus here, you are saying x minus square root of x squared plus 1. That will give you negative value. That's no good, so you have to rule out the minus. So with that said, you can see that this is not integral, this is just an arrow. You can say that e to the x, so e to the y, is equal to x plus square root of x squared plus 1. Take the square root on both sides. No, take the natural log on both sides. So we get this and that cancel, so that means we get y, which is that the inverse hyperbolic sine of x is equal to natural log of x plus square root of x squared plus 1, like this. And with that, we are done. Okay, so that's how you prove it. Secondly, number 81, we are going to do the derivative of the inverse hyperbolic sine function. Well, you have two ways to do it. In fact, you can do implicit differentiation, or you can just do the derivative right here. I will do the implicit differentiation because it's quicker, and you should know how to do the derivative right here based on the L and all that stuff, right? So what I can do is this. I can again call y to be inverse sinh of x. Apply the original on both sides. So sinh y equals x. And do the implicit differentiation under the assumption that we know how to do the derivative right here, which is really easy. Just e to the y and all that stuff that we know. This right here, we get cos y, and use the chain rule, multiply by the derivative y, which is dy dx, right? And the right hand side is just going to give us 1. Divide the cos y on both sides. So we get dy dx equals 1 over cos y. But the thing is that if you want to get the derivative, you should get this in terms of x, right? So this is in terms of y, that's no good, but it's okay, it's not so bad. Because, I don't have it right here. Because we have the identities. We know that, let me put it down right here. We know that cos square of anything, so just put on cos square t, okay, so something like that. Because I'm using y, sometimes you're saying x, so t, minus sinh square t, this is equal to 1. So of course, this right here, we can look at this as 1 over. This right here, it's the same as saying you bring this to the other side and just open the square root because you have to get rid of the square. And you will just have 1 plus sinh square, and here I'm using y, so I will also use y right here, of course. So that's the idea. And again, seriously, it depends on how you want to write this down. So I'll put on y then, I guess, to reduce confusion like that. Okay. So this will be the identity. Again, move this to the other side, take the square root, so we have this. And now, what's sinh of y? Sinh of y is nicely equal to x. So finally, we get 1 over square root of 1 plus x squared. So that's it, 1 over square root of 1 plus x squared, and we're done. Just like that. Yeah, so it's not so bad. I have no idea why I was thinking that I was able to finish this in 5 hours. Honestly speaking, okay? I really don't know why I thought I would be able to finish this in 5 hours. When I was driving to school today, I said, oh yeah, let me finish this in 5 hours, but no. All right, so now we are going to calculate the sum. This time it's not geometry anymore, so it's slightly more fun. Number 82, we are going to calculate, and it goes from 1 to, and it goes from, okay, 1, okay, 1. Even 0 works. I'll actually change the question for you guys. I will make this equal to, let me see. Let me see if I want to do 1 or I want to do 0 with you guys. Let me see. It doesn't really matter though, to be honest. This is right here, 1 over n. Let's just do it with 1. So I had 1, but I changed to 0. So yeah, n plus 2, and then n factorial. No, I think I actually don't remember the answer for this. I have no answer for this, so I don't know what the answer is. I should be able to find out both of them. Oh yeah, n should be starting with 1. Never mind. N should be starting with 1. I know why. I know why I start with 1, yeah. So compute this right here, right? But I have a hint for you guys. Find a formula for the n's partial sum. That's why I want the n to be start with 1. Alright, so here we go. This right here is our an, and n start with 1. So, it's not just 1 over n factorial. That would be too easy for the e to the something, right? It's actually similar to that, but we do have the n plus 2. So, I want you guys to remember the n's partial sum approach to do the infinite series. That's why I have this question. And here we go. Let's go ahead and just write down the first couple terms and see if we can find a pattern for that. A1 is going to be 1 over 3, right? That's A1. Let me just indicate that for you guys. A1. So you're putting 1 in 1, so you have 1 over 3, just like that. And then when you have A2, well, you're putting 2 in here, which is going to be 4 times 2 factorial, which is, again, 2, so you have 1 over 8. And then A3, I don't know what's on the top, or I don't know what's on the bottom, but I know the top is 1. You're putting 3, you get 5 times 3 factorial. 3 factorial is 6, so you have 30. And then maybe we need a few more. So A4, that's 6 times 4 factorial, which is 24. It's going to give me, oh my god, 144. Hopefully this should be enough for me to have a really nice formula for that. So now here we go. S1, this right here is just 1 over 3, like this, okay? And then S2, meaning you add this out, so 1 over 3 plus 1 over 8. And let's have a look. This right here, we just have to multiply by 8, multiply by 3. So this is 8, this is 3 is 11, 11 over 24. Yep. And then S3, it's going to be, I'm doing right on the spot, okay? I don't have the answer with me. Actually, I don't even remember if I did this beforehand or not. But anyway, this is the same as saying 124, 11 over 24 plus 1 over 30. I need to, man, I don't like this question. This 6 in common, so I need 4 and 5, so I need to multiply by 5, and I need to multiply by 4. So this is going to be 55, so this is going to be 59 over 120. Okay, it's really weird, but okay. Yeah. Next, S4. I do have another way though, by the way, just to let you guys know. 1 over 3 plus 1 over 8 plus 1 over 30 plus 1 over 144. Alright, so 59 plus 120 plus 1 over 144. This is not a good way to add. Let me just use the calculator real quick. 59 over 120 plus 1 over 144. 359 over 720. Wow, let's see how we can come with a nice formula. Is this the double of that? Almost. Have a look here. If you double this, this is going to be 118, yeah? Over 120. If you double this, it's going to be 22. If you double this, it's going to be 368. So it's 2 less than the double of the bottom. So perhaps we can do the following. All right, so let's see. How should we write this? Yeah, I guess you all know every 100 everything video at some point I get stuck on my own question. So this is the one that I'm kind of stuck. But let's see how we can write that down. Okay, what's this? This right here is the same as 3 factorial. So we're good. This right here is 3 factorial. Right? No. What am I talking about? This is not 3 factorial. What's that 3 factorial? Okay, that's just, okay, I'm not looking at any factorial. This is 4 factorial, good. This is 5 factorial, and this is 6 factorial on the bottom, okay? That's good. How do I interpret the 3 then? It's almost like 3 factorial, but it's not quite 3 factorial. 3 factorial is what? 3 factorial is 3 times 2, so it would be 6. So maybe I should multiply this by 2 and 2. So I'm looking at this as 2 over 6. So I can look at this as 3 factorial, okay? In that case, it makes some more sense. See? And then, let's see. I see. Let's have a look at this one, for example. How can we get how can we go from here to here? We can just divide the bottom by 2 and then subtract 2. So if you want to do the top right here, how we can do it is just do 1/2 of the bottom, which is 4 factorial, and then minus 2. So that's going to be 12, minus 2 is 11, and divided by 4 factorial. How's that? Yeah. Likewise, if you would like, the bottom is 5 factorial already, right? And notice how if you double this, it will be 2 less. So what you can do is you take half of the bottom, which is 5 factorial, and then minus 2. And here you go, that's a pattern, so it takes some time to do it. On the bottom here, you get 1/2, and then 6 factorial, and then minus 2 over 6 factorial. If you look at it this way, in fact, you can still have the 3 factorial, and you can do this. Take 1/2 of 3 factorial, and then minus 2, and then divided by 3 factorial, right? And of course, if you would like to simplify more, you can split the fraction. This is be 1/2, right? This is 1/2, minus 2 over 6 factorial. Split the fraction, you get 1/2 minus 2 over 5 factorial, and so on, so on, so on, right? And let me just put on one more, why not? Minus 2 over 4 factorial. Now, here is the deal. We need to come with Sn. So I should put down plus dot dot dot. No, not plus dot dot dot, just Sn. Notice how earlier when we have 4, this is the 6 factorial, and everybody has a 1 over 2 in the front. So this right here is just 1 over 2 in the front, minus this right here is, well, 2 more than whatever that is. 2 more than whatever that is. So I just have to do n plus 2 factorial that, and then on the top, well, everybody has that 2, so we have that 2, right? And technically, once you come with a formula, you should prove by induction and all that stuff, but, you know, I will not trick you guys on the final exam whatsoever. When you see a good formula, that's pretty much it. Okay, so now, does this converge? All we have to do is, this right here, I'll just put it down, okay? The sum as n goes from 1 to infinity of 1 over n plus 2 times n factorial. This right here is just the limit as n goes to infinity of the Sn formula, the partial sum. So I will just write that down. 1 over 2 minus 2 over n plus 2 factorial that. And again, this is just the Sn formula. So that's the definition of that anyway, right? So this right here was the An. And do the limit plugging in here. This will approach 0. So you just have a nice 1 over 2 and you are done like that. I think I really went crazy about picking a lot of hard questions on the I want to go home by 11. Find the area under one arch of the cycloid. So here we go. We have number 83. X equals r times t minus sine t. Y equals r times 1 minus cosine t. And here is the picture, right? So here's the idea. If t is 0, you get x and y both being 0. So you're starting like this. And for the cycloid, it's just that you rotate a circle. And you just keep track. So it's going to look like this. Right? Something like that. But anyway, so you have a circle inside, right? So that's just pretty much the idea. We want to show that this right here is 3 pi r squared. Right? This is 3 pi r squared for the area. And now, this is how we can do it. First of all, this right here is when t equals 0. Okay? And then you should find out where is this, what time will this happen. And that's precisely when y equals 0. And that will happen when t is 2 pi. There we go. Yeah. When t is pi, you get 2r, that's like a tab, and then this is when t is equal to 2 pi. When t is 2 pi, you get 1, and that will also be 0 for that. Okay? So for y, make y equal to 0. So for that. Anyway, that's how you figure out the limits of integration. Here is the area integral from 0 to 2 pi. And as always, it's y is the rectangle under the curve, right? And this is y, this is dx. So the y, in our case, is y of t though. So we just put on y, but I will still write down the dx. Okay? But the problem is that these values are going to be in terms of t. So what I will do is, this is integral, and technically I should say this as y of t, and then dx dt. So how should I write that down? dx dt. It's just a notation, it's a bizarre notation, y dx. All right, we have x. Let's just put it down like this. The area is going to be y as a function of t times the derivative of t, the derivative of x, and then you multiply by dt. And then you just have to tell me the t1 and t2. So that's pretty much how you find the area for that. All right, so in this case, we go ahead and set up from 0 to 2 pi. Again, when t is 2 pi, y will be 0. That's how you hit another, that's how you hit the x-axis again. Y of t is that, which is r times 1 minus cosine t. Okay, and then you have to differentiate this. Okay, differentiate this right here. We will get r times 1, and the derivative of this is minus cosine t, like that. So yeah, yes, we are doing another trig integral. We have more. Anyway, r squared all the way in the front, integral from 0 to 2 pi. Just multiply this out. That's pretty much how you do it. So you have 1 times 1 is 1, minus, you pretty much will get 2 of the cosine t, and then you get plus cosine squared t, like so, right? How do you integrate this? Use the formula 1/2 1 plus cosine of 2t, like this, right? So again, this will be r squared, and we have the integral going from 0 to 2 pi. And let's see. This is 1, and this is 1. And you have the 1/2. So altogether, you get 3/2. And then, this right here is just pretty much by itself and all that. So I will just write it down for you guys. Minus 2 cosine t, but this times that we have plus, this is not t, plus 1/2 cosine of 2t, like this. Then you go ahead and integrate everybody term by term. So all the way in the front, we have r squared. Okay, first one, we have 3 over 2t. Next one, integral of cosine is positive sine, so this right here pretty much becomes -2 sine t. And then, again, this will be positive sine, so the sine stays, the plus stays, and then you have sine of 2t. And of course, earlier we had that 1/2, yeah? But the derivative of the 2t is 2, so you have to divide it by 2, so you have to multiply by 1/2 because the reverse chain do. So that's how you integrate it. And then you go ahead and plug in from 0 to 2 pi, like so. So here, all the way in the front, you have that r squared. And then 2 pi in here. So we get 3 over 2, and then you have the 2 pi. And then the good thing is that you use 0, and then 0 sine of the 2 pi or 4 pi whatsoever is 0, so you are good. So I'll just put a -0 plus 0, yeah? So that's the first term. Minus the second, you're putting 0, 0, so everybody's 0. Thank for the everybody is 0. So everybody is 0, so that's good. So in the end, you see that this and that cancel, 2 and 2 cancel. So in the end, you just have what? We'll just put it down right here. 3 pi r squared. Yeah. Don't you guys feel so accomplished when you guys are doing proofs just like that? Okay? Alright, I'm going to solve the next differential equation with this little space right here because I'm really tired of like erase the board. So I think that's why make me so tired. So differential equation, and then we have an initial condition. Here we go. Bring this to the other side, multiply dx on both sides. 1 over square root of 1 minus y squared, and we have the dy, that's equal to x dx, integrate, and be happy. On the left-hand side, inverse sine, it's just a regular one, okay, of y. This is equal to 1/2 x squared plus c, right? C1 if you would like. You don't need to though, actually. And now let's go ahead and plug in numbers. So I will just put this down right here. When y is 1/2, we'll just put it here. So we get inverse 1/2, sine of 1/2. And this is going to be 1/2, 0 squared plus c. And sine of one angle will give you 1/2. Well, you can draw a right triangle very quickly. Sine is going to be 1/2 if you have pi over 6, namely 30 degrees. This is 1, this is 2, so 36. That means 30 degrees, which is pi over 6. So, you see it? Yes. So that will be pi over 6. That's equal to c. So finally, you can say that after you apply the original sine on both sides, y is equal to the original sine of 1/2 x squared plus pi over 6. So that's it. I'm still smiling though. Alright, that's yeah. I'm still focused, okay? And you guys should be focusing too. Okay. Next one, 85. So here we have to compute a limit as x approaching infinity. Let me just write it down like that, infinity. And then we have ln x squared over x. Good. Okay. Without further ado, infinity over infinity, that's actually a L'Hopital's rule ready form, right? So go ahead and do the derivative. You cannot really use the list that I demonstrated in class or maybe in my other videos because here we have not only ln x, it's ln x to a second power. So I haven't covered that yet, so you have to just do the L'Hopital's rule for this. But you'll see the answer is still, yeah. Anyway, this right here is the limit as x approaching, I don't know why. Anyway, on the bottom is 1. Bring the 2 to the front, and the ln x stays, but use the chain rule. Multiply by 1 over x like this, right? And now, this is the same as saying the limit as x approaching infinity to ln x over x. And yes, this right here. Let me just show you guys the derivative. So again, L'Hopital's rule. This is the limit as x approaching infinity. This is 2 over x over 1. So finally, you can conclude that, yes, it's still equal to 0. The truth is, if you have ln of like whatever, like to the 175 million powers over x, I think that will still give you 0. Okay. Thus, the series as n goes from 3 to infinity of 1 over 2 to the n, ln n, converge or not. This right here, we can do a nice comparison. This is what we know. 1 over 2 to the n is a geometric series when n goes from 3 to infinity, 1 over 2 to the n. Let me just put it down like this. This right here. We know r is equal to 1/2, and the absolute value of r is less than 1. Therefore, this right here converges. Now, do the check. The situation here is that you cannot use the limit comparison test. You get 0 or infinity. That's not good, right? Depends on how you put it. But you can do a direct comparison test. This is the one that we know. That's the one we're trying to do. So I'll put this down first. The one we're trying to do. Try to always put it on the left-hand side so that we can be consistent. We're using a convergence, so we hope to show that this is less than or equal to the one that we know, which is this. 1 over 2 to the n. Well, take out the absolute, take out the summation. By the way, everybody's positive. Take out the summation, 1 over 2 to the n, ln n. Is this less than or equal to 1 over 2 to the n? Well, for n greater than or equal to 3. Cross multiply if you like. This right here is 2 to the n. This right here is 2 to the n, ln n. Divide both sides by 2 to the n. That's positive, so that's good. True. Right? Therefore, this right here converges, right? This is really true. Converges by direct comparison test. So, just like that. Okay, so the next one, we're going to do a polar equation. Yeah, I will just erase. '87. My God, I'm almost done. Number 87. Number 87. Convert the polar equation, namely r equals 6 sine theta minus 4 cosine theta to Cartesian, all right? To Cartesian this time. So this is what we are going to do. You have to remember, for this, r is always r. You can just keep the following like this, okay? For sine, you can change that to y over r. That's how you can go back to the Cartesian, right? Y over r. And this right here is minus 4, and the cosine is x over r. So just keep that in mind. There are the cases like this. And because everybody has r, so we can multiply everybody by r. So we can clear the fraction. So now, you will see on the left-hand side is r squared, and that's equal to 6y minus 4x. Then, the beauty of the r squared is that we know it's precisely x squared plus y squared. That's equal to r squared. Very nice. And that's equal to 6y minus 4x. Put everything onto the other side. This right here is x squared plus 4x, and then plus, well, sorry, because we have to complete the square. Plus y squared minus 6y, and that's equal to what? Well, for this one, we will have to add 4 on both sides, because you take 1/2 of this number, which is 4, and you square that. So that's still 4. And for this right here, we have to do the magic number as well. We take 1/2 times -6, and we square that. That will give us 9. So we plus 9 here and plus 9 here. Just like that. Let me just double check. Yes. Yeah. So this right here is x plus 2 square plus y minus 3 square after you factor it. And this right here will give you 13. With this being done, you can say this is a circle. This is a circle with the center at -2, comma positive 3. So remember, you change the sign, right? If you see this is +2, it's actually -2 for the h and k and all that stuff. And the radius is the square root of this. This is 13 only, so the radius is square root of 13. So this right here will be the information that you have to provide, just like that. So that's how you describe the shape. All right, number 88, integrating this guy, integrating sine to the 4th power sine to the 4th power x. Unfortunately, this one is just the even power, but it's not so bad. I'll show you how. This right here is integral, parentheses. This is sine square square, right? So we can look at this as sine square x and then square that dx. And the reason we want to do that is because this is the integral of this right here is 1 minus cosine square x and square dx. Very good, huh? And now we have to just expand this. This is the integral. Expand this, we get 1 minus 2 cosine square x, and then you square this guy and you add it. So plus cosine to the... No, my bad. I'm sorry. This is bad. This is bad because I will pretty much go back to the original. So I demonstrated wrong one, so you should not do that on the final exam neither, okay? This is the one we actually have to do. Power reduction formula when you have the even power only. You do 1/2 1 minus cosine 2x. Right? So in your parentheses like that. Okay, 1 over 2 squared, you get 1 over 4. Let me just put that all the way in the front. And then the integral, I will have to square this guy. So this is 1 minus 2 times this and that. So we have 2 and we have cosine of 2x. So that's good. But for this guy, I will have to add the square of that, which is cosine square of 2x, like that. Right? So that's dx. And this is similar to one of the examples that I did earlier. And notice how this right here, you have to use the double and the power reduction again, right? So this right here, how we are going to do is, this is, remember, cosine 2, right, square right here. If you have theta, this right here is the same as 1/2, 1 plus. For sine is minus, for the cosine is plus. This is cosine of 2 theta, like so. When you have the 2x here, this is going to be 1/2, 1 plus cosine. So the input here is 2x, so you have to actually do 2 times the 2x. So be really careful with that. So just write it down nicely and all that stuff. So that's pretty much what we have. Okay? And then, of course, you can distribute this a little bit. This is 1/2 plus 1 over 2 cosine of 4x. And this and that can be combined. Notice we haven't done any integration yet. Again, we have 1 over 4 all the way in the front. Integral, this and that is 3 over 2. It should be in green. And then this right here is the minus 2 cosine of 2x. And then this right here is plus 1 over 2 cosine of 4x. Yeah, dx, like this. Okay? Finally, we can integrate. This is 1 over 4. Open the big parentheses. Integrating this in the x world is 3 over 2x. And now this is minus 2. Integral of cosine is positive, so this doesn't change. We have sine of 2x, but you guys all know you multiply by 1 over 2. And then we are going to add, this is 1 over 2, this is sine, and the 4x stays, but we multiply by 1 over 4. Yeah, just like this. But not done yet. Distribute this, so we get 3 over 8x. And this and that cancel, but if you multiply this in, it's 1 over 4 sine of 2x. And then this right here is 1 over 8, and that 8 times 4 is 32, plus 1 over 32 sine of 4x, like this. And then we're done. Plus c, right? Okay, so have a look. Right. How are you guys doing? I'm doing okay. How about you guys? Huh? Let me know in the comment down below. 2 more pages on my handout. On yours, I'm going to give you guys like a version that doesn't have that much space, so that when you print out, it may save you more paper and all that. But anyway, at what point of the curve does the tangent line have the slope 1 over 4? So this right here, we want the following, number 89. Given the parametric equation, x is equal to 3t squared plus 1, and y is equal to t cubed minus 1. We want the points so that we want the points so that dy dx is equal to 1 over 4. So that's the question that we want. Now let's go ahead, of course, get our derivative, and yeah. Okay, so dy dx equals dy dt, which is just the derivative of this, so I'll just do it, 3t squared, and yeah, that's it. Over, and differentiating this, we should get, I think I make a, okay, so we have the 3t squared here, and then if we do that, we have 6t, like this. Yeah, so 6t, differentiate that, we just get 6t, so just like that. And yeah, that's pretty much a derivative, so we are talking about 1 over 2t, so it's t over 2, like that. This is pretty easy, actually. Oh, I didn't put that, I don't remember. And then you set this to 1 over 4. Because you want the derivative to be 1 over 4. So that's pretty much the idea. So man, I gave myself an easy question for number 89. Lucky me. Anyway, this will mean that t has to be 1 over 2, right? T has to be 1 over 2 for this to happen. But we're not done yet though. This is a tricky part. We want to know the points. So putting 1/2 into there, so x is equal to 3 times 1/2 squared plus 1, and y is equal to 1/2 third power minus 1. So here we go. This is 1 over 4, so this is going to be 3 over 4 plus 1, so it's 7 over 4. And that's 1 over 8 minus 1 is negative 7 over 8. So the point, and this is the only point. The only point is 7 over 4, comma negative 7 over 8. Yes. So just like that. Okay, yes. Okay, does this converge or not? Let's see. Number 90. I have to write this down for you guys. We have 1/3 minus 2 over 5 plus 3 over 7 minus 4 over 9 and plus dot dot dot. Does it converge or diverge? A good idea is to write this in the sigma notation so we can understand better. Hopefully that's the situation. So now here we go. This is the sum as n goes from 1 to infinity. We're using 1 if you would like. You can use 0 if you would like. Now everything is alternating, so we have negative 1. The first term is positive, and I use n is equal to 1, so I will just say n minus 1, like this, okay? And then I put down n is equal to 1. You can use 0 if you would like. But we have this. If n is 1, look at the bottom is just all the odd numbers. So we have 2n. I need to get to 3, so I need to plus 1. So I can get to 3, and then when n is 2, I get to 5, so that's good. And when n is 1, on the top is just n. So that's pretty much it. So that's the sigma notation for that. It looks like we have an alternating series. Shall we do the alternating series test? It's not going to work. Yeah, you'll see one part is not going to work because here is the deal, right? So notice if you take the limit as x, if you take the limit as n goes to infinity of the formula part, in fact, you will end up with 1 over 2. But this will be alternating between positive 1 over 2, negative 1 over 2, and so on, so on, so on. So technically, this limit right here does not exist. And of course, does not exist means it's not equal to 0. So this right here diverges by TFD. Yeah. Number 91, man. Number 91, but I have to do a big proof. God. Okay, I have to erase this. 6:30. This is taking me longer than when I first run my marathon, okay? Anyway, 91. Prove the R-length formula. So, number 91. By the way, let me tell you guys, my Calc 2 students, if you guys are watching, this is the question that I will ask you guys for the final exam for this semester, okay? So be sure you guys know how to do this one. Prove the R-length formula for the polar curve, because this one is usually I don't prove in class, but I want you guys to know how to do it. So here we go. I'll just tell you, given, so this is how you can start. Given R is equal to a function of theta, so R is equal to a function of theta, like this, okay? And we are trying to get the R lengths from theta 1 to theta 2. So I will show you guys a picture. Suppose you have the curve looks like this, and you just want to get the R lengths from here to here. So this is the portion that you want. And now here we go. How can we do it though? Go back to the parametric situation. Do that. That's the idea. X is equal to R, but R this time is a function of theta, and you have to multiply by cosine of theta. And then Y is equal to R. Again, it's a function of theta. Just have to remember that. And multiply by sine theta. So that's pretty much the idea. R length is equal to, what you do is, you do the square root and all that stuff. This is integral from something to something, but let's worry about that later. Actually, we can put that down right now. It should be still pretty legit to do that. Theta 2 to theta 2. Theta 1 to theta 2. Square root. You have to differentiate this. Put it there. Differentiate that. Put it there. Square them and all that. So here we go. I will have to differentiate this. And again, remember that R is a function of theta. So here is how we are going to do it. I'll just put on R prime for the derivative, okay? Anyway, squaring this, the derivative and square that, I will first have, I don't know if this is long enough. I'll try. Okay. First one, I will just put on R instead of R theta. You just have to remember that, okay? Times the derivative of this, which is negative sine theta. So just put on negative sine theta, and then we add this times the derivative of that. So it's cosine theta times, man. I'll just write down dr for the derivative. Okay, hopefully you guys. Dr d theta, that's how I put on. Yes. Let's see. Hold on. How should I write this? Is the proof wise? Oh yeah, I can just put on. Should I put on R prime? Okay. I need to do the derivative, but I just want to know what notation that I'm supposed to use. If I put on dr d theta, then okay, let's do this. Right? Sorry, so you guys. So here is the question. I'll put on the timestamp right here. Okay, so for my Calc 2 students this semester, be sure you guys know how to do this, because I'll ask you guys how to do this proof on the final exam for sure, right? So here we go. Well, we want to get our length of the polar curve, just like what we did with the parametric equation. We will just change that to a parametric equation and talk about the DL. That's pretty much the idea. So if you look at DL, well, it's just going to be, for this situation, all we have to do is just do the dx and the d theta in our case, because we're using theta as our parameter. And you square that, and you add it with dy d theta, and you square that. Okay, so let's just do it this way. Yeah. So here we go. Open the big square root. Now, dx d theta, you look at this and differentiate that, and you have to square it. So here we have r times cosine theta, so just r. The first term is r times the derivative of cosine theta is equal to r times negative sine theta. Let's do it again. First function, r. You don't have to put on theta if you don't want to. Times the derivative of the second one, because we're taking the derivative, so it will be negative sine theta, yeah? And then we add the second function, which is cosine theta times the derivative of the first one. And the derivative of the first one is going to be dr d theta, okay? And you square that, all right? And then, I know why I had to do it like this, because this is how I wrote down the formula, so yeah. Anyway, so you do it like this, and then you add it with this guy, which you pretty much do the same thing, but you have the sign instead. So first, you have to do this times the derivative of that, which is going to be r, derivative of sine is cosine, and then you add sine times the derivative of the first, which is dr d theta, like that. So you're just trying to find the dl, which is the small change amount in the r length, right? Now, I know it's going to be a long one. Okay, I'll do this in red, okay? So this thing square. So you get r square sine square theta, because you have to multiply this out. And then you add 2 plus this and times this and that. But this is minus, so it becomes minus 2 times r. And then you have sine cosine. And then you have the dr d theta. And then you have to add this thing square, so plus cosine square theta, and then you have to have the dr d theta square, like this. That's the first part. And then you have to add this one. I'll do this in green. So I square that, so I add r square, and the square of that is cosine square theta. That's actually pretty nice. You see, huh? And then I will do 2 times this and that, and that's actually positive this time. So we have 2r times cosine and sine. So let me put on sine theta, cosine theta, and then we have the dr d theta. And then you add this thing square, which is sine square theta, and then you have that dr d theta square, like so. And of course, everything is inside of the square root. That's a horrible square root. And then, now check this out. This and that, let's just do this. Let's just do this. We can factor out the r square, yeah? So you can see, we can factor out the r square. And then you have the sine square theta plus cosine square theta. And of course, this is nicely equal to 1. So in another word, all this is just equal to r squared times 1. This and that are exactly the same. So bye-bye. Same thing here now. Sine, cosine, both of them have that. So you can look at this together, and you just have cosine square theta plus sine square theta times dr d theta square. And of course, this is just equal to 1. So all in all, you just have dr d theta square. That's pretty much the idea. So finally, you can see this right here is the square root of just r squared, and then you have the dr theta squared. So that's pretty much it. Really cool, huh? Plus dr d theta squared. So this right here is your dl, okay? This right here is your dl. Well, how can we get the whole r length? Okay, in that case, we can say that just integrate both sides. So we get L, and that's equal to the integral, and we will just have to go from theta 1 to theta 2. So theta 1 to theta 2. And the idea is that if you integrate this, then, integrate this with respect to d theta, of course. Yeah, and then you will get that thing pretty much. So you get r squared plus dr d theta square d theta. So that's pretty much it. Okay? So for my Calc 2 students, you guys can watch this one, or maybe I do have another video that I made when I was more awake. So maybe you want to check that out. But anyway, this right here will be the proof of that. Okay, so that will be legit. 10 more questions. Why? Because it's not 100, it's 101. But the problem is that I forgot to label number 21. But maybe you didn't even know, so I don't know. So we'll see. Number 92. Okay, so here is the differential equation application. Okay, I'll read it for you guys. So you put a bottle of beer, right? Room temperature 75 degrees Fahrenheit. You put it in the refrigerator. The refrigerator is 36 degrees. After 40 minutes, it cooled down to 60. And then use the Newton's law of cooling. Find the temperature after another 40 minutes. So here we go. This is what we know. dt is equal to k is proportional to the temperature of the beer, so let's use capital T for that, minus the surrounding. You put in the fridge, which is 36 degrees, so the fridge is the surrounding temperature, so minus that, right? And the original temperature was the room temperature, which is 75. So that's it. And also we have T of 40 is equal to 60 degrees Fahrenheit, like this. And based on this, we want, it says another 40 minutes in the fridge. So we actually want T of 80. Right? T of 80. So now look at this and we'll solve the differential equation. Divide this on both sides. We get 1 over T minus 36. And we have the dt. This is equal to K dt. Integrate both sides. So we see this is very nice. It's just ln absolute value T minus 36. But the truth is, you will see that this is always going to be greater than 36. So if you don't want, you can just take out the absolute value if you like. But let me just keep it because it's been 6 hours and 30 minutes. Anyway, this right here is kt plus c1. All right, do e to this power, do e to that power, they cancel. And you have the absolute value t minus 36. This is equal to e to the kt. And then we have to multiply e to the c1. But e is a constant, c1 is a constant. I said that like 5 hours ago or something. So I can label that as c2. And then get rid of the absolute value. Put on plus minus. Move that to the other side. So you have t as a function of time. It's equal to 36. But c1 is c2 is a constant. Negative c2 is also a constant. So I'll just write it as plus c3 e to the kt. So that's pretty much the idea. Okay, because we know t of 0 is equal to, because we know t of 0 is equal to 75. So just put that down. And then, of course, this is going to be 36 plus c3 e to the k times 0, like so. This is 1. So minus 36 on both sides. c3 is equal to 39. I don't know, people are talking on the outside, I don't know. Anyway, and then because we know t of 40 is equal to 60, so that means we have 36 plus 39 e to the k times 40, like so. And you should know how to solve this, okay, seriously. K is approximately equal to negative 0.0121. So just go ahead and solve that on your own. And then t of 80, which is the one that we want, is 36 plus 39 times e to the negative 0. Let me just write down the k in black. 0.0121 times what's that? 80. And I will tell you this is approximately equal to 50.81 degree Fahrenheit. Right? So it dropped 15 degrees and then it just dropped 9 degrees something after another 40 minutes. So that's pretty much the idea. So it's not a linear drop, right? So that's the idea. Now, for the next one, I will speed up the next one because we have done this a lot of times. So hopefully you guys will see, once you see it, you know it. So I'm going to kind of speed up for the rest. Because I remember, yeah, let me just do it so that I save some energy to talk. Number integral e to the 3x sine of 2x dx. What do we do? Integration by parts. Good choice. So now, let me just do it down, put it down right here. I don't know. If I should have enough space if I put it down right. I know, I remember. I'll put it down right here. It should be enough. So d and I. Just kidding. Differentiating what? Up to you. I will integrate sine of 2x and then differentiating e to the 3x. If you switch, it's okay. Differentiating 3x, differentiating e to the 3x is 3e 3x, and then 9e 3x. Integrate this, you get negative 1/2 cosine of 2x, and then you do it again, you get negative 1/4 sine of 2x. And it should be followed along the way. Hopefully you are doing this along the way, okay? Function part repeats, so you can continue to do the following. Okay, so go ahead, do this times that. Notice this times that is minus 1/2. Minus 1/2 e to the 3x cosine of 2x. This times that, you get positive, right? Positive, and you have the 3/4 e to the 3x sine of 2x. Yeah? Let me see. Yeah. Okay, and then make sure I don't make any mistakes, even though I want to be hurry, but I still want to make sure I give you guys the good ones. So this right here, again, it's going to be an integral. It's a minus though, so minus times positive is a minus, so it's a minus. This times that, it's 9/4, so I will just have to do 9/4, and then the integral of the same thing as the original sine of 2x dx. Right, so that's the idea. Now we can add 9/4 of the same integral on both sides. So that this and that will cancel. I will just come back here, plus 9/4, the same integral. Right? So that's pretty much a strategy for these kind of equations. All right, so now, oops, wrong color, my bad, but whatever. Okay, this is one integral plus 9/4 more, so this is 4/4 plus that is 13/4, and we have the 13/4, and the integral e to the 3x sine of 2x dx, and that's equal to negative 1/2 e to the 3x cosine of 2x plus 3/4 e to the 3x times sine of 2x, yeah? We don't like the 13/4, so multiply everybody by 4/13. Multiply everybody by 4/13. So finally, you see that integral of e to the 3x sine of 2x dx, this is equal to, this times that, the 2 cancel out, so you have the negative 2 on the top, and you have the 2 on the top, yeah? This 2 is out, so you have the 13. 2 over 13, e to the 3x, cosine of 2x, and then plus 4 cancels out, so you have the 3 over 13, e to the 3x, sine of 2x, like so. Put a plus c, we are done, right? Maybe one day I'll challenge myself, like 100 integrals in 100 minutes, but no. Just kidding, don't even take that seriously. Okay, number 94. X is t squared minus 6t, and then y is 2t plus 1. Change this to Cartesian. So this is how we can do it. Right here, get a magic number, which is half of this, and square that, which is a plus 9 on both sides. Right? So as you can see, this is x plus 9, and that will be t minus 3 squared. And I will take the square root on both sides. You will see t is equal to square root, and don't forget the plus minus, and we have the x plus 9 inside. When I do that, I still have the minus 3. I have to add a 3 on both sides, so 3 of that. Then put this right here, so we are looking at this as y equals 2 times 3 plus minus square root of x plus 9, and then plus 1 after that. Okay? So in fact, this right here we can write it in 2 ways. This is 6 plus 1, which is 7, plus 2 square root of x plus 9. This is the first equation, and then you tell me another one. 6 plus 1 is 7, minus 2 square root of x plus 9. So this is like a question that we did in class, okay, you guys? Yes. My longest video, I know. So I would like to see, yeah, this way, you know, because cannot complain anymore about like, okay, no study guide or whatsoever. And the thing is that I can tell you guys, hey, if you don't practice this, man, I'm doing this for you guys. So if you put in the effort, all the stuff, right? Anyway, I don't even know what I'm talking about anymore. Number 95. Series as n goes from 1 to infinity, 1 minus 1 over n to the n squared power. Does it converge or not? Wow. This one, we can use the root test. Why? Because we have the n in the exponent, so root test is the way to go. So here we go. I will say you take the limit as n goes to infinity, you open the nth root, and you put everything in here. So we are looking at this as 1 minus 1 over n to the n squared power. And for the nth root, this is the same as saying 1 minus 1 over n raised to the n squared power, but we divide it by the power by n, like this. And now, this is 1 minus 1 over n raised to the nth power only. Okay, don't forget the limit is, don't forget to take the limit, right? So how can we do this? Yes, the fact. A is negative 1, B is 1. So all in all, we get e to the negative 1 times 1, which is negative 1. And this is, of course, the same as saying 1 over e. What does that mean? That's less than 1. So we can come back here and say, this right here does converge by, please do not label this as RT, okay? Spell this out, by the root test. Like that. Okay? Okay. Number 96. Given a differential equation, dp dt, and we have a logistic differential equation, which is 0.02p. And I'm not asking you guys to solve it, so don't worry. I'm just asking you guys some computational questions. Okay, this is a logistic differential equation because we discussed the form before. This is the maximum, right, the carrying capacity. The question is asking at what value of P will the population increasing. So it depends. It depends if you can talk about the situation or not. But in general, this is how you do it. All right, so for A, you want the derivative. You want the derivative to be greater than 0 so that it will be an increasing situation, right? And likewise, I will actually do B as well. For B, because the question is asking us the population to be decreasing, so we want dP dt to be less than 0. And part C, equilibrium means it doesn't do anything, right? It just stays. So you want dP dt to be 0. I forgot to write down the want. All right, so now equilibrium, make it 0. You want this to be 0 or you want P to be that. So this is pretty easy. So this right here is P equal to 0 or P equal 4500. Okay, so that's pretty easy. Now, to be less than 0, this is what you can do. You can draw a number line if you like. So this is 0. This is 4500. Pick a number, let's say 1. You put it here. You get positive, yeah? And yeah, you pick a number, you just plug in positive times 1 minus whatever, just positive in that case. So you want the P to be, or just write it down in red. For this one, you want the P to be in between of 0 and 4500. When can the population be decreasing? Well, if you have negative, you actually end up with negative here and negative here. I will tell you P greater than 4500 or P less than 0. It depends if this makes sense or not. Not really, because if you're talking about population, you can't really have 0 population or negative population. So this right here might not make too much sense. So just if you have a bigger population, you'll decrease until it reaches the carrying capacity. So just do it like that. Right? So that's it. Number 97. So this time it's not because I cannot draw, it's because that's how the picture is. You guess this picture, and you want the area right here. And you have an equation, R is equal to theta times sine theta. This is how you do it. You see, it touches the origin, so you have to set this equal to 0. Well, first you can have theta equal to 0, and that's done deal. But when you have sine equal to 0, from here you can say theta is equal to 0, pi, 2 pi, 3 pi, and all that. You can check this out in your graphing calculator. When you have theta equal to 0, that's the first one. It's going to go like this, right? And then it's going to hit, and the theta 2 is going to be a pi. And then you are going to go again, and you are going to have theta 3, which is going to be a 2 pi. Now, to get the area of the shaded region, you do the big minus the small. So the area is just going to be integral from theta 2 to theta 3. So it's pi to 2 pi, 1/2, and you have that equation. So theta sine theta square d theta minus the inner loop, which is from 0 to pi. So you go from 0 to pi only. And then you have the 1/2 theta sine theta and then square d theta, like this. And you can just do this on your calculator, okay? So this is approximately 15.503, yeah, 15.5031. Right? This right here, I just want you guys to do it on the calculator. Yeah, so just like that. And for the people who would like to know, this right here is actually equal to pi to the third power over 2. Very cool, huh? Couple more to go. Number 98. The limit, and we have the limit as x approaching 1, x to the 1 over 1 minus x power. And this is an indeterminate form because you get 1, and in fact it should be 1 plus, sorry. And you get 1 to the infinity's power. Let me see. Actually, it doesn't matter. Did I put it down? Yeah, doesn't matter. Yeah. You get 1 to the, if you have 1, let's see. Yeah, so just 1 to the infinity form or any kind, right? Technically, you have to consider plus and minus because you get this, but just don't worry, just do the following, okay? It's late. All right, so this is how you do it. The limit as x approaching 1. You don't like to have base x, you like to have base e, so you do the following. Look at this as ln, e to the ln x power. This is the same as x, okay? Raised to the 1 over 1 minus x power, like this, okay? Then you have the limit as x approaching 1. Powers multiply, so you have e raised to the ln x over 1 minus x power, like this. Now, here is the deal. You can now just take the limit right here because e to the x is a continuous function. So you get to look at this as e and just have to focus on the limit as x approaching 1 of this ln x over 1 minus x. You get 0 over 0, so you go ahead and do the L'Hopital's rule. So you get e, and you have the limit as x approaching 1. This is 1 over x over, this is negative 1. And you putting 1 in here, you actually end up with negative e. Well, negative 1, right? Let me see. Yeah. So this is just e, and you put a 1 in here, you get negative 1. So all in all, you get 1 over e. I have to double check on this because I don't remember. It's kind of weird. So let's check on Wolfgang Alpha real quick. One over e, I got it. Yes. So 1 over e. So that's how you do it, right? So just do L'Hopital's rule, so just computation, so it shouldn't be that bad. Now, oh my freaking God, we have the oh my God, I'm so happy. You guys cannot believe how happy I am. Just a few more to go. Number 99. Oh my God, number 99. Integral square root of e to the x minus 1 dx. I'll speed this up, okay? Let u equal to the square root of e to the x minus 1. Do all that. So you can just differentiate this if you like. So you get this, and then you get 1 over 2 square root of e to the x minus 1. Don't forget the chain rule, the derivative inside is e to the x, like this, and you have the dx, yeah? Isolate the dx if you like. This is going to be, you do the reciprocal, which is 2 square root of e to the x minus 1 over e to the x, and then you have the du like that. Now take this to the u world. We have what? This is the integral, this is u, and then dx is all that. And notice that oh man, this right here, yes, it's nicely equal to our u, yeah, isn't it? Yeah. So I'll put down the u right here, so we have the 2. So we have 2u over, but we have e to the x. And we have the dx. Oh man. It's okay. Don't worry, you guys. It's just another integral. This is that, everything's good. So all in all, we have the integral. This is 2u squared, but for e to the x, we can just go back here. We can square both sides, so we are looking at this as e to the x square both sides and add 1, so this is u squared plus 1. Just like that. So e to the x is u squared plus 1, and the dx is the du. No, sorry, I forgot to put this down. This is the du. Dx is all that, so we had the du earlier, and I will maintain the du right here. Right here, you can do long division if you like, so you can just go ahead and do that, and I will do this. I will put a 2 in the front, right? And how I'm going to do is I will just do plus 1 minus 1. We did this earlier, okay? So 2 in the front, and we have the integral. This part, u squared minus u squared plus 1 over u squared plus 1 is just nicely equal to 1. But this is the minus. Don't forget to have the minus, so we have to account for that. Minus the 1 over the original u squared plus 1 du. Integrate this guy real quick. This is 2u minus inverse tangent of u. Yeah? What's u? That guy. So go ahead. Distribute, so we have 2. U is square root of e to the x minus 1. And then distribute it, so we have minus 2 inverse tangent of square root of e to the x minus 1. Done. Very, very good. Does this converge? Yes, man. 100. Oh my god, this is like the best day of my life. Seriously, man. My teaching or my YouTube days, whatever. Anyway, 2n cubed minus n over square root of n to the 9 plus 10n to the third power minus 8. Right? So do a comparison, limit comparison. That will be the idea. So we know this over that will be easier, and perhaps if you don't like, you can into the 2 if you don't want. So look at the sum as n goes from 1 to infinity. This is n cubed over, this is n to the 9 over 2. Okay? So we can see that this right here is the sum as n goes from 1 to infinity. Let's see. This is 6 over 2. So this is 1 over 3 over 2, n to the 3 over 2. This is the p, which is 3 over 2, which is greater than 1. Therefore, it converges. Right? Converges. Okay? Now, do the check. Right? Do the check. How do we check it? Limit comparison test, please. So I will say as n goes to infinity. Put the one that you're doing on the top, 2n cubed minus n over all that. So square root of n to the 9 plus 10n cubed minus 8. And then divided by the one that we know much better, which is 1 over n to the 3 over 2 power, like this. Well, do some algebra. We can multiply the top and bottom by this guy, n to the 3 over 2. Multiply by n to the 3 over 2, okay? So they cancel. Take this, distribute. You get, man, 3 plus 3 over 2 is 6, so it's 9 over 2. So this is going to be 2n to the 9 over 2 minus n. And this is going to be 5 over 2. I have to multiply, and also this square root of n9 plus 10n cubed minus 8. Okay? And then take this and that. Oh, what did I put on 4? This times that, it should be over 2. Sorry. All right, so now this right here, this is also 9 over 2, right, for the power. So all in all, you get this approaching 2. In the limit comparison test situation, 2 is a good number because it's greater than 0. Therefore, we can come back here and say this right here also converges, okay, also converges by LCT. One more. I haven't done anything with my best friend, yeah? How can I not do anything with the best friend? Of course not. That's not possible. Find the Taylor series of the best friend when A is at 3, right? So here we go. Number 101. As you guys all know, there is going to be a bonus, but this time, sorry. Yeah. This. Best friend, we want 1 over 1 minus x. But this time, we want the center to be at 3. So this is what we have to do. Well, if we want to have the center being at 3, then we must have the factor being x minus 3. We must have this factor, right? Now, that would do some algebra to make sure this and that are the same. I want to have the minus stay, so I will just have the minus. And now this is technically negative x plus 3, right? That's no good because I need to have the 1 stays the same. It's okay though, just go ahead and do negative 2. Negative 2 plus 3, we still get the 1. So that's the idea. Can we use our best friend now though? Not really. Again, this right here is just to fix the center. But to use our best friend, the 1 on the top is good, but this right here is not so good. We need to have the 1 right here as well. It's okay, we can just factor that out. We can factor out 1 over 2, like so. Factor out the negative, okay? So in that case, we have the parentheses, and then the 1. Negative factored out, it becomes plus. But we need to have the minus for the best friend. It's okay, just to minus, minus. Originally you have this, but we factor out the 2, so we have to just do x minus 3 over 2, like this. Okay? So we can use our best friend now. This is negative 1 over 2, and put this in the summation, and goes from 0 to infinity. And you enter this into your best friend, so you get negative 1 times x minus 3 to the, well, not really, over 2 to the nth power, like this. And don't forget to also say the absolute value of this, negative parentheses x minus 3 over 2, set this to be less than 1 for the best friend because you have to know the r and also the I. Now, let's do this right here. Okay, here we have the sum. N goes from 0 to infinity. This to the nth power, so I'll just put that all the way at the end. We have the x minus 3 to the nth power, yeah? And you see, here we have negative 1 to the nth power, so I'll also write it down like this. But we do have another negative 1, so just go ahead and add 1 to this right here. On the bottom, we have 2 to the n, but you have another 2 right here, so just make sure you add the 2, like this. So this is will be the form of the best friend. Now do this real quick. Negative doesn't matter, and we have the absolute value of x minus 3. Multiply the 2 on both sides, you can put a 2 on the bottom like this, and that's pretty much it. So you can say r is equal to 2. Well, the center is at 3 now. Go to left, go to right, 2 units, so you get 1 and 5. Do not include the endpoints because the best friend, we just did the algebra with this. So this right here is the idea. I don't want to drop the mic, but I feel like it, but I still won't not do it. 7 hours, 16 minutes. I just want to go home. That's all I want. Right? All I want for Christmas is to go home right now. That's all. But anyway, my students, this right here is mainly for you guys. My fall 2019 calculus 2 students. Right? 4 p.m. also 7 p.m. class for you guys. Here, I'll show you guys. This is the marathon medal. Perhaps the hardest marathon because in San Francisco, it's a lot of hill. I did this back in 2017. One of the hardest marathon because, again, a lot of hills. Just like today, very hard. Just back. Nope, I want to do it. So how do I do it? This right here, okay? What am I doing? I don't know, maybe take a screenshot for the thing. But anyway, hopefully you guys all find this to be helpful, okay? I did this for you guys, 7 hours and 17 minutes. So please make good use of this and please do study. I spent a lot of time for you guys, so please study. And then if you guys find this to be helpful, you guys hit the like button so that I know and all that stuff, okay? And again, best of luck to you guys for your Calculus 2 final exam. And as always, that's it! Bye.